Azure AD Connect is used to link an on-premises Active Directory domain services environment with Azure AD. The benefit here is that we end up with no user account duplication. So if we've already got hundreds of users defined in our on-premises Active Directory environment, we don't have to recreate them in the Azure AD environment to allow those users to access things like cloud-based apps. So instead, we can link the two directories together so that a user can use their on-premises username and password to authenticate to Azure services. The way that Azure AD Connect works is we have an on-premises server joined to an Active Directory domain, so it does not have to be a domain controller, and on that server, we would install the AD Connect agent. Now that goes through a configuration process whereby it links to the Azure AD directory. Now, in order for that to happen, we need to know Azure AD credentials. In other words, we have to have the user account credentials for an Azure AD user that has been assigned the global administrator role. Then we also need to have on-premises Active Directory Domain Services, or ADDS, credentials. Now, normally what you'll do as well is you'll configure in Azure AD a custom DNS domain name that matches the name of your on-premises Active Directory domain name. The next consideration, and you'll be prompted for it during installation of the AD Connect agent, is whether you want to perform an express installation or custom. So a custom installation would be useful if you already have an on-premises SQL server that you want to use for Azure AD Connect, amongst other options. With Azure AD Connect, you can also configure specific types of authentication config settings, such as password hash sync. Now you can make this change after the fact, after you've installed and initially configured the Azure AD Connect agent. With password hash sync, what's happening is that a hash value is generated for user passwords on premises, and that hash is what gets synchronized to Azure AD. We then have pass-through authentication. What this means is that Azure AD can receive user authentication requests and can hand it off to the on-premises AD to actually perform the authentication, hence pass-through authentication. You've also got federation integration if you're already using Active Directory Federation Services, or ADFS, on premises. You can also enable single sign-on, and you can also enable domain filtering. So you can filter by domain within a forest or even within a domain by OU. So you might only want to synchronize the attributes for users within a particular OU in your Active Directory domain. You might not want to push everything into the Azure AD tenant. In preparation for linking your on-premises Active Directory to your Azure AD tenant, you can configure a custom domain name. Here in my on-premises Active Directory environment, we can see the domain name is quick24x7test.info. So ideally, what we want to do is create a custom domain name that's the same in Azure AD. So here in the Azure portal, I've already navigated to my Azure AD tenant. It's called quick24x7, and the domain name is quick24x7test.onmicrosoft.com. .onmicrosoft.com is, of course, the default DNS suffix, but we're going to change that in the sense of adding a custom domain name. So I'm going to scroll down in the navigation bar, and when I click custom domain names, I'm going to see the current configuration, which is the default .onmicrosoft.com DNS suffix, but I have the ability of clicking the Add Custom Domain button at the top, which I will do. So here I'm going to specify quick24x7test.info. Now, first of all, this matches what I'm using on premises, but I also actually have registered that DNS domain name with an external registrar. Now, that's important because when I click Add Domain, it's going to open up a screen where it asks me to prove that I own that domain by adding either a TXT record with the listed details down below or an MX record. So for a TXT record, the alias or host name would be an @ symbol. The destination or points to address is MS equals with a unique code, and the TTL, or the time to live for the record, is 3600. So what I'm going to do then is flip over to my external DNS registrar, in my case GoDaddy, where I've registered the quick24x7test.info DNS domain, and I'm going to create this TXT record. So here in the GoDaddy web interface, I've signed in, I'm looking at DNS management for my quick24x7test.info DNS domain, and I can see the records currently present in that zone, but I'm going to add a new one. I'm going to click Add, and in my case, I'm going to make that a TXT record as we were given instructions for in the portal. I'm going to put an @ symbol, going to paste in the TXT value and the TTL. I'll switch to custom, 3600 seconds, and I will save. So we've now added the TXT record, which will be used to prove that we own this domain because we were able to sign in and add this record. Now, the thing to bear in mind back here in the Azure portal is it can take time before that new record is known. So back here in the portal, I'm going to click on the Verify button. Now, if we're lucky, it will have verified it right away, and it looks like it worked. Verification succeeded, but if it doesn't when you set this up, don't worry. As long as you've configured the record correctly and the DNS domain name is correct, then it's just a matter of waiting until it propagates and is visible. So at this point, we now have our custom domain. So if I go back to the custom domain names view, we can see the original default DNS suffix on Microsoft.com, but we also see our custom DNS suffix, quick24x7test.info. So if I were to go back, let's say, to the users view, and let's say I were to create a new user. Well, when I create a new user, because we've got a custom domain name added now, I'll be able to select it from the drop-down list when I put in the username. So after the @ symbol, I have both domain names available. So at this point, it's finished. We've created and verified a custom DNS domain name. You can use Azure AD Connect to link your on-premises Active Directory infrastructure with Azure AD. You do this by installing the Azure AD Connect agent on an on-premises domain joined server. So to start off, first here in the portal, I've navigated to the custom domain names view for my Azure AD tenant, where I see I've got a custom domain name I've added here. It's verified, and it's called quick24x7test.info. Now, if I take a look at my on-premises environment, which I'm doing here in the Active Directory Users and Computers tool, I can see I have my Active Directory domain of the same name, quick24x7test.info. It's got the standard users container where the administrator account lives. I've also got a couple of OUs, organizational units. One's called East with a couple of sample users in it, and one is called West, again with a couple of sample users in it. So what we want to do then is get the Azure AD Connect agent installed on this host. Back in the portal, I'm still looking at my Azure AD tenant. What I want to do is click on Azure AD Connect in the left-hand navigation bar. So we can see here that currently the status is such that it is not installed. For last sync, it says sync is never run. For password hash sync, disabled. So it's not been set up. Now, we do have a link here to download Azure AD Connect. So this is what we need to download and install on the on-premises server that's joined to the domain. It doesn't have to be a domain controller, but it needs to be a part of the domain. So once I've downloaded Azure AD Connect, I'm going to go ahead and I'm going to right-click on it and choose Install. This is the software agent that's going to link my on-premises Active Directory environment to my Azure AD environment. After a moment, we have the Welcome to Azure AD Connect installation screen. So I'm going to put a check mark in the box to agree to the license terms and privacy notice, and then I'll click Continue. Now I can either use Express settings, and I can see what that means here. So it's going to configure synchronization of the items in my current AD forest. It picked that up because it knows what this server is a member of. It's going to configure password hash synchronization from on-premises AD to Azure AD. Password hash synchronization means we aren't actually syncing the actual password to the cloud. Instead, we are generating a hash locally, and then that is what is being synchronized to Azure AD. Express settings will also start an initial synchronization of on-prem objects to the cloud. It's going to synchronize all Active Directory object attributes and enable auto upgrade. It says if you want different settings, click Customize. And when I click Customize, I can specify details like the use of an existing SQL server or an existing service account or custom sync groups for synchronization. However, in this case, I'm going to go to the previous screen. I'm going to leave it on Express Settings, and I'll click the Use Express Settings button in the bottom right. The next thing I have to do is specify Azure AD Global Administrator credentials. So I'm going to go ahead and enter the username and password to that effect. And next, we're prompted to authenticate to our local Active Directory Domain Services, or ADDS, admin account. Now, before we do that, let's go to the portal for 1 second. Here in the Azure portal, I'm still looking at my Azure AD tenant. If I click on Roles and Administrators on the left, I need to make sure that I have a global administrator. So in the alphabetical list of roles, I'm going to go find Global Administrator and take a look at the members. There it is, Global Administrator. I've added a user named Cody Blackwell. So this is a Microsoft Azure AD user account, and I have to have a user with global admin privileges in order to sign in when I install Azure AD Connect, as I just did. So I have to have someone that's a global admin before I can successfully sign in. So now I'm going to go ahead and sign in with an administrator account in my local environment. After I click Next, it goes to the next screen, which is labeled Ready to Configure, and notice it tells me what's going to happen. It's going to install the sync engine, configure the connector, enable password hash synchronization, and so on, and also start the synchronization process after the configuration has completed. So I'm okay with all that. I'm going to go ahead and click the Install button to get going with this. Depending on how many objects you'll be synchronizing from your on-premises domain will determine really how long this takes. Other factors like the amount of throughput you have on the network also plays into this. At any rate, it won't take very long before you get to this configuration complete screen. It says the configuration is complete. You can now check the Azure or Office 365 portal to make sure that users have been synchronized there. That's great. Okay, I'm going to click Exit, and let's go and take a look at this in the Azure portal. Here in the Azure portal, I'm looking at the same Azure AD tenant, Quick24x7. I'm looking at all of my users, but I have a number of new users whose source is showing as Windows Server AD. They've been synchronized from the on-premises Active Directory. We see users such as Maria Martinez and Matt Foster. Let's take a look at that in our on-premises Active Directory infrastructure. Back here on premises in Active Directory users and computer, I can see there's Maria Martinez, and if I go to East, there's Matt Foster, plus we have other users like Julio Chavez and also Nikki Flores, so they're all showing up now as well. The other thing you'll notice on your on-premises server where you install the Azure AD Connect agent is that you're going to have an Azure AD Connect icon. So if I go ahead and launch that, it will allow me to make configuration changes should I choose to do that. So it says, Welcome to Azure AD Connect. I could click Configure, and from here I could continue on and configure this, or I could troubleshoot any problems I might be having, such as with object synchronization. After you've installed and configured the Azure AD Connect agent, and even after it's synchronized to your Azure AD tenant, you can go back and make configuration changes. Now, why would you want to do that? Well, you might want to change settings such as what gets synchronized. Maybe you only want certain OUs with user accounts on premises to have their information synced into the cloud. Or maybe you want to enable an option like password write-back, so that if the password is changed in Azure AD, it gets written back to the on-premises copy of the user account. Or maybe you want to enable single sign-on. There are plenty of reasons that you might do this. So to get started here on my on-premises server where Azure AD Connect is already running, I'm going to click on the Azure AD Connect icon. That's put there automatically when you install the Azure AD Connect agent. So I'm going to go ahead and click on the Configure button, and from here I get to select what it is I want to configure. So in this case, I'm going to choose Customize Synchronization Options, and then I'll click Next in the bottom right. So I'm going to have to authenticate, in this case, to my Azure AD Global Administrator account. After that, it knows which directory or Active Directory instance I'm connected to locally, which is good on premises. So I'm going to go ahead and click Next. Now here it's set to sync all domains and OUs, but I can sync selected domains and OUs, and down below, I might uncheck the entire domain and say, look, all I want to do is synchronize West and East. Those are organizational units that I have, or even just only one of them. And then from there, I could click Next. Then I have other options, such as, do I want to enable password hash synchronization? Well, that's the default's already checked. That's where a hash of the password of the on-premises user account is taken, and that hash is synced to the cloud. We could also enable password write back and so on. However, I'm going to leave that selection and I'm going to click Next. So it's going to check for the installed components and verify that this is going to work. And of course, it's going to make sure it has connectivity to Azure. So it's going to update the connector configuration and configure sync services. Now, when this happens, synchronization is temporarily suspended, so it's going to start the synchronization process when configuration completes. Perfect. I'm going to go ahead and click Configure to get that started. And before you know it, we'll see the configuration is complete, so I'm just going to go ahead and click Exit. If we take a look at the users in our Azure AD tenant, we can see that some of them are sourced from Windows Server AD, that's on premises. Users such as Maria Martinez and Nikki Flores. But we don't see a whole lot of other users. We just see those two and the default on-premises directory sync account. So we see Maria and Nikki. That's consistent with my on-premises Active Directory environment where the West OU contains those users, Maria and Nikki. But if I go to the East OU, we see Julio and Matt, and they are not being synchronized because we've just reconfigured Azure AD Connect with domain filtering. And basically, the only thing we're synchronizing is user accounts that exist in the West OU. After you've installed and configured Azure AD Connect to link your on-premises AD to Azure AD, here in the portal, when you're looking at your Azure AD tenant, you can pull up the Azure AD Connect blade. And over on the right, you'll see under the Azure AD Connect Sync section that the sync status should say enabled. It should have a last synchronization. In this case, it says less than 1 hour ago. And in this case, with my configuration for password hash sync, it says enabled. But there's so much more you can do to monitor the health of your Azure AD Connect environment. To get started here in the portal in the top center, I'm going to search for Azure AD Connect, and I'm going to choose the Azure AD Connect Health option. So that takes me into Azure Active Directory Connect Health, and I'm in the Quick Start section, Quick Start Blade, where over on the right, I can download Azure AD Connect Health, the agent, software agent, for ADDS. ADDS stands for Active Directory Domain Services, and so that refers to your on-premises AD. So I'm going to go ahead and download that on my Azure AD Connect server where I've installed the agent. Once that's been done, I'm just going to go ahead and right-click on the AD Health Ads Agent Setup file. I'm going to right-click it and choose Run as Administrator. When I go through the installation and configure it, it'll prompt me to sign in. So I'm going to go ahead and sign in with a global administrator account in Azure AD. So you'll see that it started a PowerShell administrative window where it's starting some services that are being installed in the background. On that server, if I pop up the Services app, I can see in the A's that I have a number of Azure AD Connect Health services that are running in the background. Back here in the portal, in the Azure Active Directory Connect Health service, we can on the left click on Sync Errors to see if there are any synchronization errors from our on-premises AD to Azure AD. We can see that we have sync errors listed by type, but they all have a value of 0. So that's a good thing. It means we don't have any sync issues. If I click on Sync Services on the left, we can see the service name. This is our default Azure tenant, our Azure AD tenant DNS name, and we can see that it's got a status of healthy. I can also click on it to open it up, and I can see it's linked with an Azure Active Directory Connect server called DC1. Now that's the server where I've installed the Azure AD Connect agent on my on-premises environment. That server is joined to an on-premises Active Directory domain. Down below, we can see there are no alerts. That's a good thing. We can see when the last export to Azure AD occurred in terms of the date and the time stamp. If we click ADDS services on the left, we'll see the name of our on-premises Active Directory domain, quick24x7 test.info. We can see when it was last updated. There are 0 active alerts and the status is healthy. If I click on it, because we've just enabled this, it might take a few moments for this information to update. So we can see we've got 1 domain, 1 site. We have 0 errors on domain controllers or DCs for replication, no alerts. Everything looks good. So we have no problems currently with our current configuration. And that's the purpose of using these tools, is to be able to monitor the health of the link between our on-premises AD and Azure AD. Azure AD Domain Services is a managed solution to run Active Directory in the Microsoft Azure cloud. Now, it's unlike Azure AD. When we go into Azure AD, we have limitations. We don't have the option of using organizational units to organize resources. We don't have options like group policy. These are things we would normally have available on premises in AD. And you can have that in the Azure cloud when you deploy Azure AD Domain Services. So this is different than Azure AD. Although what it does do is synchronize objects from Azure AD. So let's get started here in the portal. I'm going to click Create a Resource, and I'm going to search for Domain Services. So I'll type in Domain, and right away I can see Azure AD Domain Services. So I'm going to select that. And then I'll choose Create. So I'm going to specify the resource group that this should be deployed into. And down below, for the domain name, I can use the DNS domain name for the default Azure AD tenant, or I could use a custom domain name, which is what I'm going to do here. So I'm going to use quick24x7 test.info, which is a custom DNS domain name I've associated with an Azure AD tenant. For the region, I'm going to leave it on Canada East. I'll leave the SKU on Enterprise, and I can use either a user or a resource forest type. So with the resource forest, this means users and groups that are created directly in Azure AD get synchronized to Azure AD Domain Services. Whereas a user type of forest would sync all of the objects that are in Azure AD, even those that might be synchronized from on-premises AD through Azure AD Connect. So I'm going to leave it on user, and I'm going to click Next. For the networking, I can use an existing VNet that I could select from the list, or I can create a new one. So it wants to create a new one to host Azure AD Domain Services, as well as a subnet. I'm going to accept the defaults. Bear in mind that what's going to really happen in the background is there are going to be 2 background VMs running as domain controllers to support my Active Directory domain services here in the Azure cloud. So that's fine. I'm going to go ahead and click Next. That takes us to the administration part of the wizard. I'm not going to change anything for group membership or notifications, so I'll leave all that as it is. I'll click Next. For the synchronization, I'm going to leave the synchronization type set to All. Now, if I only had a few groups in Azure AD that I want synchronized to Azure AD Domain Services, then I could choose Scoped, and then I could select the groups. However, here, I'm going to leave it on All, and then I'm going to click Next. I'm on the Review and Create page now, so the end of the wizard, it's validating my selection. And then we can see our summary page, and I'm going to go ahead and click Create to deploy this. Then I'll click OK. And after a moment, we'll see that our deployment is complete. Now, instead of going to Go to Resource by clicking on that button, instead I'm going to go back to Home. I'm going to click Home in the upper left here in the navigator, and I'm going to go to my All Resources view here in Azure. I want to check out a few things. First of all, I want to filter by type. I'm going to uncheck Select All. I'm going to check Azure AD Domain Services, but I also want to turn on Virtual Network. So I want to see those types of objects, and I'll click outside of that to filter it. So notice here that we have a VNet, a virtual network created called AADDS VNet. That's our virtual network that was used for deploying Azure AD Domain Services. We can also see a reference for Azure AD Domain Services with the name of our domain, in this case, quick24x7 test.info. So I'm going to go ahead and click on that to open up its details. In the overview blade, we can see that it's still in the midst of being provisioned, and it says this operation will take a while. So I'm going to give it a few minutes to complete this. After a moment, we'll see that we've got our Active Directory Domain Services Azure instance up and running. Technically, it's 2 backend VM instances, and we can even see if we scroll down here in the overview blade, under required configuration steps, it talks about updating the DNS server settings for our VNet and configuring the 2 DNS server IP addresses here for our 2 VMs. Active Directory requires DNS to locate domain controllers. And so we have the option of clicking the configure button to make that happen. So I'm going to go ahead and click configure to do it. And we'll see that we've got something happening in our notification area in the upper right, and it says it saved the virtual network settings. Well, let's go take a look at that. I'm going to go to the All Resources view here in the portal, and I'm going to filter out the type here. Let's see, how about we only look at virtual networks, since that's what we're trying to get to. So I'm going to go to virtual network. Here's the virtual network created for our Azure Active Directory Domain Services deployment. So once the navigation bar with the properties for the VNet pops up, I'm going to scroll down and choose DNS servers. Now, normally you have the default Azure provided DNS selected, but here what's been changed is it's added the 2 private IP addresses for our 2 backend VM instances that will support our Azure Active Directory Domain Services deployment. Using Azure AD Domain Services instead of just Azure AD gives you additional capabilities. Running things like group policy configurations and using organizational units or OUs is possible with Azure AD Domain Services, whereas it is not if you're using just Azure AD. I'm going to click on my deployment of Azure AD Domain Services to open up its properties, and I'm going to scroll down and click Properties in the navigation bar. The reason I want to do this is I want to see the VNet and subnet affiliation. So I can see that Azure AD Domain Services was deployed in a VNet called AADDS-VNet. The reason that's important is because I'm going to deploy an Azure virtual machine in that VNet because I'm then going to join it to my Azure AD Domain Services domain so that I can actually manage it and work with things like group policy and OUs and so on. So the next thing I'm going to do here in the portal then is go home and I'll click Create a Resource. And I'm going to deploy, let's say, a Windows Server 2016 data center server. It doesn't have to be that version of Windows, but that's what I'm going to choose to deploy here. I want to make sure I deploy it into that VNet. So as usual, when deploying a VM, I'll deploy it into a resource group and I'll give it a name. I'm going to call this WinServe 2016-1. And I'm also going to specify the region where I want this deployed. In this case, I'm going to deploy it, let's say, in Canada East. So I'll select that from the list. And down below, as per usual, I need to specify down below the administrator account credentials. So I'm going to go ahead and do that. And I'm pretty much going to accept the defaults for pretty much everything else. So I'll click Next to go to disks. I'm not going to change anything about the disks. I'll click Next in the bottom right for networking. I just want to make sure this is deployed into the AADDS VNet. So I'm going to accept that. This server is going to have a public IP address resource. That's all fine. So essentially what I'm going to do is click the Review and Create button in the bottom left. I'm not going to change anything else about this VM. And then I'll click on Create to deploy the VM. Now what we have to do after this is deployed is sign into it and join it to our Azure Active Directory Domain Services domain. So now the VM is deployed, so I'm going to click Go to Resource so we can learn a bit about it. One of the things I'm interested in the overview blade is seeing the public IP address, which I'll copy so I can make an RDP connection into that VM. So here in my RDP or Remote Desktop Connection client, I've pasted in the public IP, so I'm going to go ahead and click on Connect. Just make sure that there are no network security group rules that are preventing access over port 3389 to that Windows host into that VNet. So now I'm being asked for the credentials for that Windows VM, so I'll specify them and I'll click OK. I'll choose Don't Ask Me Again for connections to this computer, and I'll choose Yes to get into my RDP session. Now just back here in the portal, I've opened up my Azure AD Domain Services configuration so that we can see the exact domain name. Here it's quick24x7 test.info. We're going to need that if we're going to join a station to the domain. So back here in my Windows VM that I've deployed in Azure, I'm just going to go to the Start menu, fire up the control panel, and perhaps search for Join, and then that way I can choose Join a Domain, because that's what I want to do, so I can manage Azure AD domain services. So I'm going to click Change here. I'm going to click Domain, and this is where I'm going to specify quick 24x7 test.info. That was the name of our Active Directory domain. And then I will click the OK button. Now, because I've deployed this Azure VM in a VNet that uses the custom DNS servers that really point to the backend VMs for DNS, then it's able to find service location records for the domain controller, so therefore this is good. It's prompting me for credentials. And after a moment, we'll see that we were successfully able to join the machine to the domain. We have the little welcome screen, so I'm going to go ahead and click OK and close, and I'll choose Restart Now. Now, while that's happening, back here in the portal, I'm looking at my Azure AD instance, which of course is connected to my Azure AD domain services installation by way of the name of the custom domain. So if I go to custom domain names, we'll see we've got one here, quick24x7test.info. Well, one of the things that will happen here is if we look at the groups in Azure AD, we're going to see a group gets created when you install Azure AD domain services called AAD-DC administrators. And if I look at the members of that group, I've got a couple of users that I've added. Now, it's important that this set of users, you use one of these sets of credentials when you join the computer to the domain. Now, the thing is, you'll have to initially change the password for one of these users to trigger that change to generate a password hash, which is then going to be what is synchronized with Azure AD domain services. So just because you've got a user in the member section of this group doesn't mean you'll be able to use that account to sign in. You need to change the password for that account at least once initially. So once I've signed into my domain joined virtual machine and I've used the same admin credentials for an admin account that's a part of that Azure AD Domain Services group, next thing I'll do is fire up the Server Manager tool, because what I want to do is install the Active Directory tools I would normally use on premises. The only difference here is we're going to be using them in the Azure cloud. So once the Server Manager initializes, I'll click Add Roles and Features. I'll click Next and continue through and accept the defaults until I get to the Features screen. And what I want to do here is go down to Remote Server Administration Tools, Role Administration Tools. Because we're talking about Active Directory Domain Services, I'm going to turn on the check mark for ADDS and ADLDS tools. And then I'll click Next and I'll click Install. Once the tools are installed, I'll click Close and I'll close out a Server Manager. So now if I go into my Start menu and go under Windows Administrative Tools, I'll see the Active Directory related tools such as Active Directory Users and Computers, which I'm going to go ahead and fire up here. So because this is a domain joined computer, we can see the name of our domain. And as I drill down, notice that we've got some items here like AADDC computers. That's an organizational unit that was created automatically. Same with AADDC users. What we are looking at here is a list of users that were essentially synchronized from my Azure AD environment. Notice some of the usernames like Cody Blackwell, Jen Hill, Lucas Brenner, Marcia Hill, Maria Martinez, Nikki Flores, and Sharon Bishop, and groups like Team 1. Let's go take a look at that in the Azure portal. So here in the Azure portal, in my Active Directory tenant, I've gone to the All Users view, and I can see users like Cody Blackwell, Jen Hill, Lucas Brenner, Marcia Hill, and so on. And in the same way, if I take a look at groups, we'll see that the groups were also pushed into Azure Domain Services, Active Directory Domain Services. Here's a group, for example, Team 1. Back here in my domain joined computer where I've launched Active Directory Users and Computers, if I look at the Domain Controllers OU, notice we can see that indeed there are two back-end instances, although we don't see them in the list of normal virtual machines, but there are two back-end instances handling Active Directory for our deployment of Azure Active Directory Domain Services. In an Azure storage account, Azure Files refers to essentially sharing a folder in the cloud that you can then map a drive letter to from Windows or mount using standard Unix and Linux command line tools. However, when you want to be able to fine-tune the permissions, such as the share level and NTFS level security permissions for that Azure Files share, you need to do a few things first. Let's take a look here at our existing storage account, where I'm going to scroll down in its properties in the navigation bar, and on the left I'm going to click on configuration. The reason I'm doing this is because I want to enable support for Azure Active Directory domain services. So on the right in the configuration blade, I'm going to scroll down until I see identity-based access for file shares, under which it says Azure Active Directory domain services, otherwise called AADDS. This is not the same as Azure Active Directory, which is just a standard Azure AD tenant. What we're talking about with Azure Active Directory domain services is it's a managed service, but essentially deploying a domain in Azure that's linked to your Azure AD tenant, but it's not Azure AD. So what happens is that you have more capabilities than you would have with Azure AD. You can work with group policy, you can create OUs, and so on. So I'm going to go ahead and enable that and click Save, knowing that I've already got this configured. We'll take a look at that briefly, really quickly in a moment. Before we do that, I'm still in the properties for my storage account where I'm going to go to Access Control IAM. There are some built-in roles that you might find interesting that you can use with Azure Files. So I'm going to click the Add button on the right and I'll choose Add Role Assignment. And I'm going to open up the list of roles. This is an alphabetical list of RBAC roles. What I'm interested in are the ones that contain the text storage file data. This is for Azure Files, your shares that you define in the storage account. You've got SMB, share contributor. And if you look at the little help icon, it allows for read, write, and delete at the SMB level. However, we've also got storage file data SMB share reader. If you hover over and get the help on the icon, you'll see it allows for only read access to Azure file shares over SMB. And if you want share and NTFS permission capabilities of setting, then you would choose the storage file data SMB share elevated contributor role. If I hover over the information icon, it allows for read, write, and delete for NTFS permissions over SMB. So let's say I want to work with that. So I want to assign that to a user, let's say, called Cody Blackwell, and I'll just click Save. So I'm giving essentially Cody Blackwell the ability to manage share and NTFS permissions for this storage account where I've set those permissions. Let's just go to role assignments here. Let's check out our work to make sure it took. It will have. So if I just scroll down a little bit, what do you know? There it is. Storage file data SMB share elevated contributor for user Cody Blackwell. Now I'm just going to go home here in the upper left in the portal, and I'm going to go to all resources, and I'm going to filter out the type by deselecting select all, and I'm going to choose Azure AD Domain Services. I've already got this deployed. It's for a domain called quick24x7test.info. Excellent. So we've already got that configured, and I've got a computer, a virtual machine in Azure domain joined to that domain. So I've used Remote Desktop to remote into my Windows virtual machine in Azure that's domain joined. We can see here in the Active Directory Users and Computers tool that we are connected to the quick24x7test.info Active Directory domain. Okay, so that's fine. Let's go into Windows Explorer here, where I've actually pasted in the UNC path to a share, Azure Files share, defined within a storage account. So notice I've got a double backslash. I've got a reference here to the storage account in Azure, followed by a single backslash and the name of the share, in this case, budgets. Now back here in the portal, if I navigate to that storage account and scroll down in the navigation bar under File Service and File Shares, we'll see that we already have a couple of file shares previously defined, one of which is called budgets, which I'm going to click and open up. And we can see in the overview blade for the budgets file share that there are some files here and a folder called future. And if I go to the properties blade, I can see the URL. So basically I can copy that URL and just prefix it with the backslash for two backslashes for UNC path, and then change the slash between the storage account and the share from a front slash to a backslash. And of course, that's precisely what I've done here in Windows Explorer in my domain-joined computer, where I'm already logged in as user Cody Blackwell. And notice, without even mapping a driver, of course I could, I can see the contents of that Azure Files shared folder. And I can right-click, for example, on one of the files or folders in that location, go to Properties, go to Security, so I can set NTFS permissions. I can click Edit, and for example, I could click Add to add a new security principal, which will allow me to browse usernames and groups in Azure Active Directory domain services. So if you're already familiar with assigning permissions to Active Directory principals on premises, this feels just at home. It's the same thing at this point. So if I click on Advanced, I can click Find Now. I can see the domain here that I'm sourcing these security principals from. What I'm looking at is a list of users and groups that are available through Azure Active Directory domain services. This would include any users that might have been created in Azure AD. So as long as their password has been changed, that password hash would have been synced to Azure AD and they can sign in and access resources that way. So that's how we can use Azure Active Directory domain services to authenticate users and set permissions on Azure Files shared folders. So in this course, we've examined how to install, configure, and use the Azure AD Connect agent to connect an on-premises Active Directory environment with Azure AD. We also learned how to deploy and manage Azure AD domain services. We did this by exploring the benefits associated with using Azure AD Connect, how to create a custom DNS domain name for Azure AD. We also saw how to download, install, and configure the Azure AD Connect agent on an on-premises domain joined server. We looked at how to configure AD Connect settings such as OU filtering, password sync, and password writeback. And finally, we learned how to deploy Azure AD domain services, otherwise called Azure AD DS, how to join a computer to that domain, and how to enable Azure AD DS authentication for a storage account. In our next course, we'll move on to explore how to create and manage Azure AD groups and devices, including assigning licenses and creating dynamic groups. Organizing Azure AD users with similar needs together in a group allows us to grant permissions to the group and by extension thus give permissions to the members of the group. So it facilitates permissions management. To get started here in the portal, I've navigated to my Azure AD tenant. It's named Quick24x7. In the left-hand navigator, I'm going to click on Groups. And to create a group, I'm going to click the New Group button up at the top. First thing I'm going to do is create a group by giving it a name. And the name of this group will be Team 1. Up above, notice that the default group type is security, which is what we want. So we can add members and assign permissions, such as through roles, to groups. And the members would get those permissions from those roles. We could also create an Office 365 type group. When we do that, we then can specify some other details, such as the group email address. But in this case, it's just going to be a security group, not an email group. So I'll flip it back to security. We lose the email address field. Down below for the membership type, I can create an assigned group. Now, this means that we manually assign users as members to the group. But we could create a dynamic user group where we can create expressions that will look at user attributes to determine whether or not they should be a member of the group. Or we could build a dynamic device group. Same kind of thing, where we build filter expressions that look at device properties to determine if they should be a member of the group. But in this case, it's going to be old school. It's going to be an assigned membership type. We can also select a group owner. I'm going to click on the No Owners Selected link to do that. Now, the owner of the group, and I'll just select a user in Azure AD here and click Select, has the ability to completely manage every aspect of the group. We do have the option of adding members to the group at this point. I'm going to click on the No Members Selected, and we'll add a user here, and then we'll add them after the fact as well. So, for example, if I type in Jen, I have an existing user here named Jen Hill in Azure AD. I'll select her, and I'll click the Select button, and I'll click Create. So we're creating a security group. Membership type is assigned, and we can see the group is listed here, Team 1. And if I click on it and open it up, we can see if I look at the properties of the group, we'll get a few details about it. So we can see things like the name, we could add a description. Notice that we could also switch the membership type from assigned to dynamic user or dynamic device. However, I'm going to leave it as it is. If I go to the owners item in the left-hand navigator, I can see on the right that Cody Blackwell is the owner. Of course, I could select Cody Blackwell, remove him as the group owner, and add others. Remember that a group owner controls all aspects of the group, like the membership of the group. If I click on the members item in the left-hand navigator to pull up the members view, we can see currently user Jen Hill is a member. But we could click the Add Members button to add other members to the group at this point in time. Note that groups can be a member of a group, so that if I search, let's say for the word East, I have an existing group called East Admins that I could select and add as a member of this group, in addition to users. So for example, I'll just search up and grab another user that I have in Azure AD. They're listed at the bottom under Selected Items, so I'm going to choose Select to add them as group members. So now our Team 1 group has an existing group, and by extension all of its members, as a member of this group, as well as 2 individual Azure AD users. You can use the Azure CLI to create and manage Azure AD groups. Sometimes doing things from the command line is easier because you're familiar with the command syntax and you're quicker at typing than moving a mouse around the screen. And other times it can lend itself quite nicely to automation by maybe creating a script to perform some kind of a task and maybe even scheduling it to run automatically. Either way, let's take a look at how we can create a group here in the CLI. So I've launched Cloud Shell within the portal. So I'm going to start by running AZ-AD group create -- display -name, and I want this group to be called Team 2. And I also have to specify --mail -nickname, and I'm going to use the same thing for the nickname. It's going to be called Team 2. Now we're going to check our work by running AZ-AD group list. The problem is when I run list, it shows me a lot of extra attributes or properties I might not be so interested in. So instead, I'll just use the up arrow key until we go back to our AZ-AD group list command. I'm going to add to it. What I'm going to do is add -- query, space, open and close square bracket, because we have an array or a collection. We have more than one group that will be returned. And within each one of them, we want to call upon the .display name property. Now, in the CLI, these types of things, the reference to property names, it's case sensitive when you are querying. So display is a lowercase d, name has a capital N. So if we press enter, we'll see only the names of groups, and there's the one we just created, Team 2. The next thing I'm going to do is run the AZ-AD user show command. Now, as opposed to listing, showing gives me the details for a specific object, which I'm specifying here with the --ID parameter. And I've given it the email address of one of my Azure AD users. And I'm running -- query and asking for the object ID property. Again, watch the case here. Object ID has a capital I for ID. We're not using the open and close square brackets here because it's one item. It's not a collection of items that gets returned. When I press enter, we'll see the object ID for that account, which I'm going to copy. The reason I'm doing this is because I want that object ID so that I can add the user to my group, Team 2. To do that, I'm going to run AZ-AD group member add -G. So the group here is going to be Team 2 --member -ID. This is where I'm going to paste in what I've just copied for my user N Flores. And I'm going to go ahead and press enter. Next, I'm going to run AZ-AD group show -G. And in this case, I want to show for group Team 2 some detail. Now, all that does is show me details about the group itself, but not the members. So for that, I'm going to run AZ-AD group member list -G for group, and the name of the group is Team 2. And I'm going to run -- query, space, open and close square bracket, .display name. I want to see the display name attribute for each returned member of Team 2. There's only going to be one here, and in this case, it's our user, Nikki Flores. In this demonstration, I'm going to use PowerShell to create and manage an Azure AD group. So the first thing I'll do to build a new group is I'm going to run new -AZ-AD group -display name, and I'm going to call this new group Team 3. So Team 3 is what I'll put in as a value for that. And I have to also set the mail nickname, so -mail nickname, and I'll use the same thing, Team 3. So it looks like it created the group. We can verify this by running get -AZ-AD group, And I'm going to pipe that to select and ask only, let's say, for the display name property. So pipe select display name. Indeed, we can see Team 3 exists. So the group has been created in PowerShell, but we can do more than just that. So let's say we want to actually add a member to a group. Well, in order to do that, we can use a member object ID, such as the ID of a user, for example, or it could even be the ID of a group, if we wanted to add a group as a member of a group. So I'm going to run get-AZ-AD-user. I'll specify -user principal name, and I'll put in the email address of one of my Azure AD users, and I'll press enter. One of the things that gets returned is the object ID of that account, which I'm going to go ahead and copy. So I'm now going to add that user to my newly created group, Team 3. To do that, I'm going to run add-AZ-AD group member. Now, the first thing I'm going to have to do is specify the member object ID. So I'm going to put in member object ID, so -member object ID, and I'm going to specify the user ID that we just saw up above from our user Nikki Flores. But that's not all. I have to identify the group I want to add that user to with the -target group object ID parameter. And here's where I'm going to paste in the group ID for Team 3. We could retrieve that using PowerShell, or I can just go back here in the portal. There's our Team 3 group right away. From here, I'll be able to see the object ID. I could copy it from here. So whether we do it in PowerShell or through the GUI, we end up with the same result. So I'm going to go ahead and press enter. So to make sure this is working properly, I can check group membership. I can run get-AZ-AD group member, and then I'm going to specify the -group object ID parameter, and I'll just paste in the group ID we specified a moment ago. And we can see user Nikki Flores is now listed as a member of the Team 3 group. We can also verify this, of course, back here in the portal. So here I'm looking at Team 3, so I could just as well have clicked on members over on the left, and on the right, it'll show Nikki Flores has been added. Azure AD allows you to restore deleted Office 365 mail groups for up to 30 days. Let's examine how this behaves. So here in the portal, I've already navigated to my Azure AD tenant, and I'm looking at my groups view, all groups. I've got a group here called East Admins, and if I click on that group to open it up, for example, if I look at licenses, I'll see if any licenses are assigned to the group. There is one assigned. I'll see if there are any members within the group. No members have been defined. Okay, so let's go ahead and delete this group, or rather, let's try to delete the group. I'm going to go to the overview blade, and then I'm going to go ahead and delete the group. We're going to have a problem because there are licenses assigned to the group. So let's go ahead and click delete, and yes, and it still shows up in the list. We refresh, can't get rid of it, open up my notification area, failed to delete group because it's got an active license. So we could remove the license, but I'm not going to do that. Instead, I'm going to go into another group called Team 2. Not even going to go into it. I'm going to select it, and I'm going to delete it and choose OK. Now, if I go to the deleted groups view on the left, I don't see the Team 2 group that I just deleted. That's because it's an Azure AD security group, not an Office 365 mail group. And we're talking about restoring deleted Office 365 mail groups. Let's go back to all groups. Let's create a new group here. Now, the default group type here in the portal is going to be security, but in this case, we're going to create an Office 365 mail group. It's going to be called Group 1 Off 365, and the email address, I'll just leave it as it's generated here. It's automatically got my Azure AD tenant DNS suffix added to the end, and the membership type assigned. That's all fine. I'm just going to go ahead and create the group. There's our group, Group 1 Off 365. So now if I select that one, and if I delete it, I'll choose OK. When I go to the deleted groups view, we're going to see now that we have Group 1 Off 365. And there's a message up at the top that's very clear. 30 days after original deletion, groups are permanently deleted. So to restore that group and all of the members, if there were any added to it, I could select the group and choose Restore Group, and then click Yes. It's that easy. It no longer shows up under deleted groups because now it's showing up as an active group under the All Groups view. There it is. With Azure AD, you can enable device join to allow users to join their devices to the Azure AD tenant. The reason that you might want to do this is it would then allow those users to sign into those devices using their Azure AD credentials and thus have seamless access to things like apps that are available through Azure AD. At the same time, it also allows you to work with conditional access policies for user sign-in to check things like the device type. So to get started here in the portal, I've already navigated to my Azure AD tenant. Now, what we want to do first is verify that users are allowed to join devices to Azure AD. For that, we can go into Devices. When I go into Devices, the next thing I want to do in the left-hand navigation bar is click on Device Settings. Then over on the right, we can determine whether we want all users to have the ability to join devices to Azure AD. These are user accounts that exist in Azure AD. We could choose Selected, and then we could go down and start browsing through which Azure AD credentials should be able to join devices to the domain, or we could choose none. I'm going to leave it on all. Down below that, you have an option to add additional local administrators on Azure AD joined devices. So you can select an Azure AD user account that would have admin rights on joined devices. So for that, I would choose Selected, click down on Selected underneath it, and click the Add button. Let's say I want user Cody Blackwell to have local admin rights on domain joined devices, so I could go ahead and add Cody that way, and then I could click on OK. Further down below, we have other options, such as requiring multi-factor authentication before allowing joining devices to the domain. We can set the maximum number of devices per user that they can join to Azure AD. We can also go down and manage enterprise state roaming, which is for Windows 10 users and their settings, so that the settings are stored in the cloud, and those users would have a consistent experience across their devices in terms of their settings. So I'm okay with what I've configured here. I'm going to go ahead and click on Save. So now on my Windows 10 on-premises device, I've gone into Settings from the Start menu, where I'm then going to search for Work, and then I'll choose Show All Results. And I want to access Work or School, so I'll click on that. So basically, I want to join this Windows 10 station to my Azure AD domain. So for that, I'll click on Connect. Now, the next thing I'm going to have to do is specify the account that I want to use. And this is where I could specify a user account within Azure AD. So after I've specified the email address for my Azure AD user that I want to join this device to Azure AD with, I'll then click Next. We can now see it's in the midst of registering the device, and then before you know it, it'll be done. So I'm going to go ahead and click the Done button. And here in Windows, we can see that we've got a connection to our Azure AD tenant using Lucas Brenner's, or L. Brenner, the user, that person's account. Let's go take a look at Azure AD. Back here in the portal, I'm looking at the Properties navigation bar for my Azure AD tenant. So what I want to do is scroll down and click on Devices. And what we should see is that we've got a Windows 10 laptop computer that has been joined or registered with this Azure AD domain. So we can see the name of the computer, we can see the OS and the version, the join type, and the owner in this case, which is Lucas Brenner. We could go back to our Azure AD tenant, and for conditional access policies that reference that platform type, we could scroll down and choose Security in the navigation bar. We could choose Conditional Access. We could click on the right New Policy up at the top to build a new conditional access policy. I'm not going to fill in anything other than jumping directly down to the Conditions section, which I'll click on. And when that opens the Conditions blade on the right, I'll see Device Platforms. It says Not Configured. I'll click on it. And this can be helpful where I can turn on Configure, yes, and I can select Device Platforms, and this is where I could choose Windows. So once we have devices registered, we can start building conditional access policies to determine how that device is allowed to make a connection to Azure AD. Allowing users to register their devices with Azure AD has numerous benefits, including the fact it allows them to sign into that device using their Azure AD credentials, and also that means then that using that device, they can access resources that Azure AD account has been given access to. The other thing about it that is a benefit also is that you can use that device with conditional access policies. So if you want to limit how iOS devices authenticate to Azure AD versus Android versus Windows 10, and so on. So to get started here in the portal, let's just take a look at Azure AD device settings. So I've navigated to my Azure AD tenant. What I would then do is scroll down in the navigation bar and make sure I select devices. Now the first thing I'll notice is if any devices currently exist in Azure AD. And I can see over on the right that indeed there is one that's already registered. I can see the name of the computer. I can see the OS is Windows 10. I can see the user or the owner that was used to join the device to the domain. And I can also, if I scroll to the far right, see the date and timestamp for registration. Now I can also select that device, and I can even disable it from being used to authenticate to Azure AD. But before any of this can happen, before devices can show up in here, we have to make sure that device settings allow that to occur. So I'm going to click device settings over on the left. You can either turn off the entire option so nobody can register devices with Azure AD. So users may join devices. You could choose none. You could choose all. So all Azure AD users have the ability to join their devices to the domain. Or you could choose selected, and down below, you could start adding which specific groups or users should be allowed to join devices to the Azure AD domain. You can then add specific local administrators to Azure AD joined devices. What you're doing here is selecting Azure AD accounts that should be added as local admins when it comes to privileges. You can also require multi-factor authentication when joining devices, and you can also set the maximum number of devices that users can join. Enterprise state roaming is available over on the left. So assuming I've made changes here I want to keep, I would click Save. Enterprise state roaming is applicable to Windows 10 devices whereby user settings can be stored in the cloud, and when the user switches to different types of devices, they have the same experience. Now that's only true if they're using a multitude of different types of Windows devices. So if you switch from one Windows 10 computer to a different one, your settings would follow you. So enterprise state roaming by default is set to none, but just like with adding devices to the Azure AD domain, we could select all users or specify selected. Once you've joined devices to an Azure AD domain, such as Windows 10 stations, over time you might have a need to disable them, essentially block it from being used to make a connection to Azure AD and access resources, maybe if the device is stolen, for example. So to get started here in the portal, I've navigated to the Azure AD tenant in question, and I'm going to scroll down and click on Devices in the left-hand navigator. Now on the right, I'll see any devices that have been registered with Azure AD, and here I have a laptop that's running the Windows 10 operating system. So what I could do is put a check mark on that device, so to the left of it, and I could click the Disable button up at the top. It asks if I'm sure I want to disable the selected device. I will answer that by clicking Yes. Now we can see under the Enabled column, it currently says no, the device is disabled. Now this can take an hour or so before it actually takes effect. Now if a user has already signed in using their username on that domain joined device, that means they'll have cached credentials on the device. They can still sign into the device and get to the desktop. It's just that after an hour or so, if they start trying to use apps that have given permissions were given to through the Azure AD account, then that will eventually be blocked. But it might take a little while before the user sees this. And what they're going to see is a message to the effect that says your organization has disabled the device. And so this is the type of message that a user would expect once the disablement of that device has taken place. Here we see a message that says something went wrong, your organization has disabled the device. To fix this, contact your system administrator and provide the error code 135011. Azure AD dynamic groups look at the properties of users or devices to determine if the item should be added as a member of a group. So it's automatic user or device group membership. So it's based on user and device attributes. You need to fill in things like department names and so on if you want to create dynamic groups that look at those properties. Now, while you can have a dynamic group for users or devices, that would be in separate groups. You can't have a single group that supports users and devices at the same time. And in order to work with Azure AD Dynamic Groups, you need to make sure that you have at least an Azure AD Premium P1 license. Evaluation for membership, whether it's users or devices, occurs whenever a change happens. So whenever a property changes for, let's say, a user or a device, evaluation occurs to determine whether that user should be added to a group now or even perhaps removed from a group. Resource access, as normal, is granted to groups to allow access to things such as apps. Licenses can also be assigned to groups to allow access to specific features. Let's look at some examples of some of the syntax you might see for rules. First, we've got a dynamic group rule that's looking at users as opposed to devices. And we separate the class of object, the user or the device, from the property with the dot. So here we have user.type equals guest. Notice equals is referenced here with -EQ. So we want to see only guest accounts in this example. We could also have a rule that looks at user.company name, assuming we fill in the company names. In this case, we're looking for company name not equal or -NE null. User.department equals IT. User.account enabled equals true. Then we can get more complicated and test multiple conditions at the same time. So in the first set of parentheses, we're testing user.type equal guest. Now outside of the parentheses, we have -and. So these two conditions must evaluate to being true. And within the second set of parentheses after -and, we have user.company name not equal to null. So in order for a member of this group to show up, the user type must equal guest and the company name property must not equal null. It must be filled in other words. Next example, we have user.city-in, and in square brackets, we've got 3 text strings, each separated with a comma: Halifax, Montreal, and Toronto. So this means that the user city property must be one of these values. Either it's Halifax or Montreal or Toronto. Next, we have user.department-match. And in double quotation marks, I'm looking for IT. Then I have a dot and a star. This is regular expression syntax. The dot meaning any character, the star meaning, or the asterisk meaning any number of those. It's a wildcard. So it's got to match IT followed by something else. We can then look at device properties. Device.os type equals iPhone, or device manufacturer equals Motorola. So we've got a lot of different types of expressions that we might be able to come up with to determine dynamic user or device group membership. An Azure AD dynamic group is one where group membership is determined not by manually adding group members, but rather instead by specifying user or device attributes. When the conditions are met, we have members of the group. In this case, we're going to take a look at how to work with a dynamic group for user membership. To get started here in the portal, I've already navigated to my Azure AD tenant where I want to build the group. So then in the left-hand navigator, I'll begin by clicking Groups. Now, any existing groups will be shown, and I'll see the membership type column. In this case, all the 4 existing groups are of type Assign. So that's the old school method of manually assigning members to a group, which works fine. However, in this case, I'm going to click the New Group button up at the top, and we're going to build a new group that is going to look at the department attribute of users. So first of all, as opposed to an Office 365 mail group, we're going to leave it on the group type of security. For the group name, I'm going to call it Sales Staff. For the membership type, this is where I'm going to change it to Dynamic User. I'm going to click on No Owner Selected, and I will establish a group owner, in this case, Cody Blackwell, and I'll choose Select. But then because it's a dynamic group down below, I have to add a dynamic query by clicking on a link of the same name. So I'll click on that link. Now that's going to open up a new area for me to configure one or more rules that will determine whether somebody is a member of the group. So I'm going to start by going to the property drop-down list and expanding it. Now here, what I want to do is scroll all the way down until I see Department. For the operator drop-down list, I could look for and, any, contains, equals, in, not in. I could do a match, pattern matching, or not equals. However, what I'm going to do here is change it to equals. And for the value, I'm going to type in sales. Now I could add multiple expressions by clicking the Add Expression link down below. Now after I move off of that first expression line, we can see it puts the rule syntax down below. So we end up with, in parentheses, user.department-eq for equals, and in double quotes, sales. Now we don't need a second expression. I could add multiple expressions and I could chain them together using and. I could also chain them together using or, but I don't need that second expression, so I'll click the little trash can over to the far right. So at this point, I'm going to click Save, and then I will click Create. So I've now created a new dynamic group. We can see the membership type here for the sales staff group is listed as dynamic. And if I click on that group to open it up, in the overview blade, we'll get a sense of what it's doing. We could see currently that we have the creation date and timestamp, but we don't even see the membership processing status field populated yet, nor do we see the membership last updated field populated yet. So it's just a matter of waiting until the existing users in Azure AD are evaluated to see if any of them have a department field with a value of sales. After a moment, if I click on something else and come back to the overview blade, we can see the membership processing status now shows evaluating, and the membership last updated field now shows in progress. And after just a few more minutes, I can see now that the membership processing status shows update complete. That's good. So it's evaluated the attributes for users based on the configured expression in my dynamic group rules. And I can also see the membership last dated now reflects a date and a time. So let's go take a look at the members of this group by clicking Members over on the left. Notice here we see there's only one member, user Marcia Lynn. Now if we go back in the breadcrumb trail in the upper left to our Azure AD tenant and switch to the users view, we can manually check Marcia Lynn by clicking to open up her account on the right. And in the profile blade for that user, we'll see if we scroll down under the job info section, indeed, she is in the sales department. You can create two different types of group that deal with dynamic group membership in Azure AD. You can work with user groups that contain dynamic membership or device groups that contain dynamic membership. In this particular case, we're going to take a look at creating a device group that has dynamic membership. Now, you can't have both at the same time. You can't have users and devices dynamically added as members of a single group. You'd have to have multiple groups for that. So let's focus on a device dynamic membership group then. Here in the portal, I'm already looking at my Azure AD tenant. So what I want to do in the navigation bar is go to Groups. I'll see any existing groups, and under the membership type column, I'll see that I've got a collection of both assigned and a dynamic group. So I'm going to click the New Group button up at the top. We're going to add a new security group. It's not going to be an Office 365 mail group. Down below, I'm going to specify the name of the group. This is going to be for Windows devices. That's the name of my group. For the assignment or the membership type, instead of assigned, I'm going to use dynamic device. I'm going to click on No Owners Selected. I want the group to have an owner. So I'll select a user from Azure AD. And then down under Device Members, Dynamic Device Members, I'm going to click Add Dynamic Query. This is going to open up the place where I can build multiple rules that determine who should be a member of this particular group. So currently, under Property, it says Choose a Property. So I'm going to click to open that drop-down list. And I'm interested in the specific OS type. Choose Device OS Type. For the operator, I want to look for equals. I'm going to specify an exact match, and I have to add the value. But what do I put in here? Well, if you've got devices registered with Azure AD already, you can even take a look at some of those existing items and see what the value is for the device OS type property. Now, one way to determine what valid values for that are here in PowerShell. I've launched Cloud Shell in a separate browser tab. I'm going to run get-azure AD device. I'm going to press enter. So here I can see the object ID, the device ID, and the display name, which is apparently a laptop. But what I'm going to do is take that a step further. I'm going to use the up arrow key to bring up that previous command, just so I don't have to type it in again. And I'm going to pipe that to get-member. Get-member allows you to see properties and methods for a given item, like a collection, that's piped to it. Now, methods are verbs, they're actions, whereas properties are attributes or adjectives. So I'm going to run git-member-type property. Now, of the many different properties here, I can see there's one called device OS type. Okay, let's clear the screen. I'm going to use the up arrow key to go back to git-azure AD device, which I will pipe to select, because I want to tell it which fields I want to select or which properties. So I want to select one called device OS type. And when I press enter, we can see Windows. So that's what we're looking for as a value. Now, if I minimize Cloud Shell, I can also open up the actual device from the devices view in my Azure AD tenant, and I can see the OS. It doesn't say specifically that it's device OS type, but in the interface it says the OS is Windows. So we could have used that as well. So having done that, we now know that we can search for a value of Windows in devices. And when I click outside of that line, it adds our rule down to the rule syntax down below. So what we have in parentheses is device.deviceOSType -eq for equals, and in double quotation marks, Windows. That's all I want to add here. So I'm going to go ahead and click Save, and I'll click Create to create that device group. We can see the group shows up here. It says Windows Devices. I'm going to click on it to open it up, because in the Overview blade, I want to track the membership processing status and membership last updated fields. They're currently empty, which tells me it's not even begun evaluating devices to see if they have a device OS type of Windows and therefore should be a member of this group. So I'm just going to wait here for a few moments. And after a minute, if I click on something else, such as in the left-hand navigator, and then come back to Overview, we'll see that the membership processing status now shows Update Complete, and the membership last updated field has a date and timestamp. So let's look at the members of this group. When we go to the Members blade, we can see our laptop is now showing up as a member of this dynamic device group. In this demonstration, we're going to take a look at the association between licenses and Azure AD groups. To get started here in the Azure portal, I've already navigated to my Azure AD tenant and the groups view. So I'm viewing the groups in my Azure AD environment, one of which is called Team 1. So I'm going to click on Team 1 to open it up, and I'm going to click the Members item in the left-hand navigator, and we'll see that this group has two members, Jen Hill and Marcia Lin. Now what I want to do is I want to assign a license to this group. So in the navigation panel on the left, I'm going to go down and click on Licenses. Licenses are used to ensure that specific product features are activated, but the licenses have to have first been added to the Azure AD tenant. So I'm going to go ahead and click the Licenses button over on the right to update license assignments. Here I can see there are two licenses that have been associated with my Azure AD tenant, one for Azure Active Directory Premium P2, and I can look at specific license options if there are any available. Then I've got another one called Enterprise Mobility plus Security E5. I'm going to turn the check mark on for that, which will show me a number of subsidiary features I can uncheck if I don't want them. They're all turned on by default. I want them all turned on. Things like Azure Rights Management, Microsoft Intune, Active Directory Premium in Azure. I want all of that stuff. So I'm going to go ahead and click Save to save this license assignment for the Team 1 group. If we look in our little notification bell icon in the upper right, we'll see that the license assignment succeeded. Okay, perfect. I'm just going to dismiss that, and I'm going to close out of the group. What I want to do now is go to the individual users. So I'm going to click on the breadcrumb link trail in the upper left to go back to my Azure AD tenant, and then in the left-hand navigator, I'll click Users. I want to pick on the users we mentioned. We mentioned users such as Marcia Lin. So if I click on Marcia and we take a look, we'll be able to tell if she's been assigned that license by going to Licenses over on the left. Now don't hit the panic button just because it says no license assignments are found. You can click Refresh, you can click Reprocess, and all of a sudden it shows up Enterprise Mobility plus Security E5. These things take time, especially when you deploy them at the group level and you want it to affect members of the group. We can click our little notification bell icon in the upper right, and now we'll see the user license state has been reprocessed, and it was done initially by assigning the license to the Azure AD group. In this demonstration, I'm going to create a group and set the owner so that we can explore Azure AD group ownership. To get started here in the Azure portal, I've navigated to my Azure AD tenant where I'm going to click on Groups over on the left. Now I'm going to see there are existing groups here, but I want to start fresh. So I'm going to click the new group button up at the top, and it's going to be an Azure AD security group named Project A_group. The membership type will be assigned. I'm going to click on the No Owners Selected link. I'm going to set a user here as the group owner. How about we're going to set, let's see, Lucas Brenner, an existing Azure AD user. We're going to add Lucas as the group owner. Click on him, and then I'll click Select down at the bottom. Then I'm going to add a couple of members to the group. So it says no member selected. I'll click directly on that link. And let's say we're going to add user Marcia. Select Marcia. Let's pick on someone else. How about user Jen? For Jen Hill, we'll add her as well. So we've got 2 users added. I'm going to click Select and then Create. So pretty basic. We've created a new group, and it shows up here, Project A. It's got 2 members, and Lucas Brenner is the owner of the group. Now let's say Lucas Brenner has signed into the Azure portal at portal.azure.com. We can see his credentials listed in the upper right, and he's connected to the Quick 24x7 Azure AD tenant. So let's examine what he can do when it comes to group management at this point. He should only be able to manage the members of groups that he is listed as the group owner for. Let's test it out. So I'm going to click on my navigation icon in the far upper left here, and I'm going to choose Azure Active Directory, and I'm going to go to the Groups view. Let's start by going to the group that we know he is an owner of, and that was the Project A group. If I click on that group, and if we go down and choose Members, we'll see on the right the current members of the group, and notice that the Add Members button is available. Let's just go through the motions to make sure we actually can add a user. And I'm going to add an existing user here, Maria Martinez. So I'm going to select that user account, click Select, and before you know it, if we click Refresh, Maria Martinez is now showing as a member of the group. So it worked, no problem. Let's go to another group. So I'm going to go back to the Groups link in the upper left, in the breadcrumb trail, and I'm going to open up another group that I know Lucas Brenner is not an owner of, like Team 1. When I go to Team 1 and switch over to Members on the left, immediately I know it's working because the Add Member button is not available. The Import Members button at the top is not available. And that's because they're grayed out. He doesn't have the permission to do it. He's not the group owner. The Azure AD Group Self-Service Management option is great because instead of involving help desk tickets or Azure technicians add and remove members to and from groups, instead that can be handled by users. Now, we can set a group owner who can manage the members, but what we're talking about with AD Group Self-Service, we're talking about the ability of users to request membership in a group. Let's take a look at how that works. So first of all, here in the portal, the first thing we have to do is make sure that the related options are enabled. So for that, in the portal, I'm going to navigate to Azure Active Directory, and I'm going to go to Groups. Now, when I click on Groups, that'll open up the Groups navigation panel on the left. And what I want to do is click on General. Now, once I click on General, I'll have a couple of related options on the right that I want to consider. So under Self-Service Group Management, the first option says, owners can manage group membership requests in the Access panel, such as on myapps.microsoft.com. I want that. I want that to be done through the browser, so I'm going to click on Yes to enable it. Below that, we have another option, Restrict Access to Groups in the Access panel. Well, I don't want to restrict access to the Groups app in the Access panel. And again, that's myapps.microsoft.com. So that's going to be left at no. So I'm going to save those settings by clicking Save. Now let's just go back and look at all groups. We have to have a group that we're going to use in this example. And it's going to be an existing group called Project A_group. The first thing we'll do is look at the owner of the group. So I'm going to click Owners on the left. And on the right, I'm going to see that user Lucas Brenner is the owner of the group. And if I look at the members of the group, I can see I currently have 3 members, Jen Hill, Marcia Lynn, and Maria Martinez. But notice that user Cody Blackwell is not listed as a group member. Well, that's the user we're going to test that's going to request to be added as a member of this group. Here in the web browser, user Cody Blackwell of the Quick 24x7 Azure AD tenant is signed in to myapps.microsoft.com. So we can see that we have a Groups app available here. Perfect. I'm going to click to open up Groups. Now what we can see is that Any groups that this user is in are shown under Groups I'm in over on the right. Now, at the same time, on the left, we can see the groups that this user owns. In other words, groups that this user is the owner of, and they're shown down below. There's also an option on the right under Groups I'm in to click Join Group, so this user can request to join a group, and that's what we're going to do. I'm going to click on Join Group, and the group that this user wants to become a member of is the Project A group, which I will select from the list. However, it says on the right, this group is not available to join. What's up with that? Well, to be able to explain that properly, why don't we sign in to the myapps.microsoft.com as the group owner, Lucas Brenner. Okay, so now I'm signed into myapps.microsoft.com as Lucas Brenner, and I can see the Groups app, which I will click on. So we can see that Lucas Brenner owns a group called Project A_group, which I will click on. And I can see down below, for the join policy, it says that only the owner of the group can add members. Well, that explains why Cody Blackwell couldn't request membership, but that'll change in a moment. On the right, we can see the existing members of the group. So on the left, I'm going to click Edit Details. And for the group policy, which is currently set to only the owner of this group can add members, I could choose this group requires owner approval, and also this group is open to join for all users. Well, depending on your needs, will determine which option you select. I'm going to choose this group is open to join for all users, and I'll choose Update. We can see that the join policy change is now reflected on this screen. So let's go ahead and log out as being Lucas Brenner, and let's log in as user Cody Blackwell once again. So as we can see in the upper right, we are signed in as user Cody. Let's click on the Groups app again. We're going to try to join the group again. So I'm going to click the Join Group link. I'm going to select the Project A group. Now, last time it said couldn't do it. Well, this time it doesn't say that. Instead, we have a Join Group button shown on the right-hand side of the screen, which I'm going to click. It asks for a business justification, something to type in. I'm just going to say need access, and I'll click Request. And based on our join policy, our message now comes back and says, your request has been auto-approved. You are now a member of the group, Project A group. Perfect. So we've now enabled users the ability to either request or just blatantly join as a member of a group, depending on what our join policy needs are. There might be times when you need to do a mass import of members into a group. And so instead of doing it individually one by one, you could prepare an import file and use that to add all of your group members in one shot. So to get started here in the portal, I've already navigated to Azure AD and to the All Groups view, where I'm going to begin by creating a brand fresh new group, although it certainly doesn't have to be a new one. So I'm going to click New Group, and I want to call this group Project B_group. So in the group name field, Project B_group. The membership type assigned. I'm going to click No Owners Selected. I'll maybe choose a user, Cody Blackwell, as the owner of the group. There are no members selected, and I don't want any right now. So I'm going to click Create. So we're creating an empty group, basically. And we can see it shown here in the list, Project B_group. So I'm going to click on that group to open it up, and I'm going to go to the Members view. Now, when I'm in the Members view, of course, I could click the Add Members button up at the top. But what we're interested in doing is clicking the Import Members button up at the top. When you do that, the first thing you're prompted to do is download a CSV, comma-separated value file format template. You can download that template and add the user details, which I've already done and prepared. So here in Microsoft Excel, where I've downloaded the CSV template and opened it up, I can see in cell A1, we've got version v1.0. And down below that, the column header, the only thing that's required here is the member object ID or the user principal name, which is the email address. So here I've got two users added here that currently do exist already. We're not creating users here. We're just adding them as members to the group. So once I've done this, I just have to make sure if I've opened this CSV file up in a program like Microsoft Excel that I save it as a CSV and not an Excel spreadsheet format file. So I've already saved this as a CSV. So let's bring this file into Azure and import these members. So back here in the portal, that is step 3, upload your CSV file. So I'm just going to click there to do that. So I've got the file selected. It says file uploaded successfully. Perfect. It likes the format. So I'm going to go ahead and click on submit. It says click here to view the status of each operation. Sure, why not? Let's click and take a look at what's happening. So we can see that our file name is shown with the upload date and timestamp. The completion time says not completed and status is processing. So I can watch this and click refresh until I see that it's completed with no errors. Now, naturally, the more users you have in your import file, the longer this will take. But remember, we're not creating user accounts. We're just adding them as members to the group. Let's take a look at how this turned out. So we're still in project B_group. Let's click on the members item over in the left-hand navigator, and sure enough, there are two users, Jen Hill and Lucas Brenner. Not only can you join Windows 10 devices to an Azure AD domain, but you can also join mobile devices. And in this case, it's going to be an Android mobile phone. Now I'm going to do this so that when it's registered centrally in Azure AD, it can be managed. So as an example, we can build conditional access policies for users sign in and access to apps that might depend on which type of device they're using. So to get started here on my Android phone, I'm already in the phone's settings. So I'm just going to swipe down until I get down under the personal section, and then I'm going to tap on accounts. I'll then click add account, and I'm going to go all the way down to the bottom and choose work account. And then it comes up with the workplace join message. So down below, I'm going to enter in a user email address for my Azure AD tenant. And then I'll click the join button. Naturally, next I'll be prompted for the user's password. So I'm going to go ahead and enter that password. And then we see that it is joining our workplace. I'm then prompted to name the certificate. For use with VPN and apps, I'm just going to tap OK to accept the default. And it says Microsoft Work account is installed and the certificate installation is successful. And we can see it's workplace joined with our account. And here in the Azure portal, if I navigate to my Azure AD tenant and then navigate to the devices view, I should see that I have a new Motorola X-Play Android device that's been added. And we can see here that the owner is listed as Cody Blackwell. So in this course, we've examined how to manage Azure AD groups and devices, join devices to Azure AD, manage settings, and work with licenses and dynamic groups. We did all of this by exploring how to manage Azure AD groups using the portal, CLI, and PowerShell, how to restore deleted Azure AD groups, how to join a Windows 10 computer to an Azure AD domain. We looked at how to manage Azure AD device settings and how to disable a device that is already joined to an Azure AD domain. Then we looked at dynamic group membership and how to assign licenses to a group. We looked at how to specify Azure AD group ownership and enable self-service group membership. We looked at how to add and remove group members using bulk options. And finally, we looked at how to join an Android mobile device to an Azure AD tenant. In our next course, we're going to move on to explore how to deploy and manage web apps and containers in Azure, as well as configuring custom DNS domain names and SSL and TLS configurations.
Azure App Service relates to hosting web applications in the Azure cloud, and there's a lot of factors to consider when planning for the use of Azure App Service. First of all, we've got web apps, and then we've got web app service plans. These are two separate types of Azure resources that you deploy. Now, when you deploy a web app, it will also deploy an app service plan, or you can specify use an existing app service plan. The web app allows you to configure custom DNS domain names if you want to control the FQDN or fully qualified domain name reference to your application. You can also configure deployment slots. You can use deployment slots for staging purposes so that you can always have a website up and running, for example, in one deployment slot, the production deployment slot. But as you make customizations and changes that you are testing, you can have that running in a different deployment slot. And when everything tests successfully, you can then swap that with the production one, so the production slot now has the latest version of the new change to the app that have been successfully tested. You can also configure TLS and SSL settings to add a secure binding to your web application. In other words, to make it accessible over HTTPS instead of HTTP. You can also enable scaling for your web application. Now, you can also enable per app scaling if you choose. This way, you can scale a specific web app independently from the app service plan, because you have multiple web apps in an app service plan. You can also configure web jobs. A web job allows you to run a background script or a program against the web app, maybe for maintenance purposes or perhaps to process any uploaded files that might have been supplied by users, that type of thing. The app service plan we know is a different Azure resource. It determines which resources are available to a web app. So it determines the underlying compute horsepower or sizing. You can also support multiple web apps. You can also view performance metrics at the app service plan level, including CPU utilization, memory usage, traffic in and out. You can also view file system usage per application in the app service plan if you've got one or more. It doesn't make a difference. Then there are pricing tiers for app service plans. The pricing tiers are based on Azure Compute Units or ACUs, which are related to CPU performance to support your app or apps. So you have the Dev Test App Service Plan pricing tier, Production, and also Isolation. Although it's the most expensive, the isolated pricing tier provides the absolute most in terms of performance and storage compared to Dev Test and Production. The Azure App Service supports applications built at the code level, whether you want to run them on Windows or Linux backend instances. But remember, this is a managed service, so therefore the backend VM instances are created automatically. Depending on the language you choose will determine whether you'll be running Windows or Linux in backend. You can also choose to run Docker containerized applications, and again, it can be based on Windows or Linux. So when you're configuring your Azure App Service, such as when you are deploying it initially, you'll have to select a runtime stack, whether it be support for Java or PHP, Node.js, .NET Core, ASP.NET, to name just a few. When it comes to managing your Azure App Service environment, you can use the Azure portal. You can do it via ARM templates. You can use PowerShell commandlets or CLI syntax, or you could use Microsoft Visual Studio. In this demonstration, I'm going to use the Azure portal to deploy a simple web application. Basically, I'm going to use Azure App Services. To get started here in the portal, I'll click Create a Resource, and right away I can see from under the popular listing of deployed components, Web App shows up. I could, of course, also search for App Service. Now, when I do that, I can choose App Service Plan. Now, the App Service Plan, or the ASP, is the resource in which you can run multiple Azure web applications. But we'll get to that in a moment. First of all, I'm going to choose Web App, and we'll start from there. Now, you can choose to create a new app service plan while you're deploying the web app, or if you already have one, it can be a part of that app service plan. So I'm going to deploy this into an existing resource group, and I'm going to give a name to this web app. I'm going to call it Web App AZ-303. It's going to use the .azurewebsites.net default DNS domain suffix. We change that later by creating a custom DNS domain. Down below, I can treat this as a code-based web app where I can select a runtime stack. So if I were to choose, let's say, ASP.NET, then Windows is selected as the underlying operating system. It's going to deploy a VM instance in the background to support my application. I just can't manage it. But if I were to choose something else, let's say we were to choose Java, then the operating system becomes Linux. So depending on your runtime stack selection will determine the type of OS in the underlying instance. So let's say here I'm going to go with ASP.NET version 4.7. So Windows is the selected operating system. In the region selection, I want this deployed, let's say, in Canada East. As I scroll down further, I can then determine the app service plan configuration. So here we can select an existing app service plan, or we can choose to create a new one, which I'm going to do. I'm going to choose Create New. We're going to call this ASP YHC 17. And I'm going to go ahead and click OK. Let's create a new app service plan. The app service plan is where the sizing, so we've got our Azure compute units, our ACUs, the underlying horsepower is determined. I can change the size here, but I'm going to leave it as it is, and I'm going to click Next for monitoring. So here we can determine if we want to enable application insights so we can learn more about requests to web apps, our web app specifically, and look at the performance of it. I'm going to leave that set to on. That's a good idea. I'll click Next. I'm not going to add any tagging information for the web app, so I'll click Next for review and create. It's going to validate my selection, and once that passes, I'm going to go ahead and click Create. After a moment, the deployment of the web app is complete. So let's check it out. I'm going to go ahead and click on the Go to Resource button. In the overview blade for the web app, we can see on the right that the status of the web app is that it is running. And then we can see the URL listed here. It's using https:// the name of the web app followed by the default DNS suffix of .azurewebsites.net. And if we click on it to test it out, it should open up our sample web page. So we know that the web application is working. You'll also notice to the far right some FTP or file transfer protocol items, which would be required if you want to connect over the FTP protocol to upload content to your site. Notice at the top, we'd stop the web app if we didn't want it to be available for a period of time. As we scroll down on the left, we can also see deployment slots, which can be used for staging. You'll always get to have one default slot called production. We can see that listed here with the name of our web app with the status of running. Then if we go to configuration on the left, under application settings on the right, if we scroll down, we'll see we have a number of app settings, including connection strings, which might be used to make connections to backend databases. Up the top, if I click General Settings, I could see things like the runtime stack. Here it's .NET and the .NET Framework version, in this case version 4.7. Also, if I go to Default Documents at the top, we can see the default documents that are called upon, such as for the home page, and there are numerous ones here, such as default.htm, index.htm, index.html, and so on. Continuing down the left-hand navigator, we can also see options for web app backups, custom domains, CLS, SSL settings. We can also scale up. Now, when I click Scale Up, it says in parentheses App Service Plan, because that's part of the App Service Plan. This is where we can see our current total ACUs, or Azure Compute Units, of 100, and memory. This is the sizing that was specified upon creation of the web app, but we can change it here. We could even choose a different pricing tier at the top for dev test. Currently we're on production, or we could choose the isolated tier. We also have the option of scaling out. Scaling out means adding VM instances to support the workload. So it's horizontal scaling. Scaling in would be to remove those added nodes. Scaling up is vertical scaling, which changes the underlying compute power. Continuing to scroll down in the left-hand navigator, I see App Service Plan. If I click App Service Plan, it takes me to that resource. It's a separate resource from the web app itself, where I can monitor things like CPU percentage, utilization, memory utilization, traffic in. And of course, we'll see down on the left, we've got the scale up and scale out options, which are really part of the App Service Plan. We just had an easy way to get to it in the navigation bar for the web app. The App Service Plan in Azure is a separate resource from the web app itself, and we can have multiple web apps connected to a single App Service Plan sharing the underlying compute power. But you can also configure each web app with per site scaling, which means that each web app can have different numbers of workers that can accommodate the workload for that one web app. So to get started here in the portal, I launched Cloud Shell. We're going to use PowerShell to create App Service Plan and then modify it. So I'm going to start by running new-AZ app service plan -resource group name. I want this deployed in a resource group called RG1-name. I'm going to call this ASP for App Service Plan YHC180 -location. I want this to be in quotes in the Canada space East location. And finally, I'll use -tier and specify that I want to use the free tier. So I'm going to go ahead and press enter to create that App Service Plan resource. And it looks like it's been created, and we can verify this by running get-az app service plan. And if I press enter, it'll return all of the app service plans, including the one we just created, ASPYHC180. Now, what I want to do is change the tier of the app service plan. Now, we could have just created it with the correct tier, but remember, initially, if I just scroll up here in Cloud Shell, we created it with the free tier. Let's say I want to use the standard tier so I can start to use additional features. So to do that, I'm going to run the set-az app service plan commandlet. I'll specify -resource group name, specify RG1 is the resource group where the app service plan is, -name, and it's called ASPYHC180. And what I want to do is change the tier. So I'm going to specify -tier, and I'm going to put in standard. Currently it's the free tier. I'll press enter. So that's going to change the tier for my app service plan, which allows me to have additional capabilities. So what I'm going to do now is take a look at one specific capability I'm interested in, per site scaling. So this way, I can have each web app that has a different number of workers to accommodate that specific app's workload. Because remember, you can have multiple web apps within a single app service plan. So the first thing I'm going to do then is take a look at that option. Let's see here. Why don't we run get-az app service plan -name. It's called ASPYHC180. And I'm going to pipe that to select, and I want to see the per site scaling property. Now we can see currently it's set to false. So I'm going to run set-az app service plan -resource group name RG1 -name is ASPYHC180. And I'm going to set the -per site scaling parameter to a value of $true. So I want to turn on per site scaling capabilities. Now, if I use the up arrow key to go back to get-az app service plan, where we were piping to select and telling it we want to see the per site scaling property, we can now see before it was false, but now it's set to true. So you can create and manipulate app service plans using PowerShell commandlets. In this demonstration, I'm going to use Microsoft Visual Studio to deploy an Azure web application. Software developers might use a tool such as Visual Studio on premises to work with their code and then push it up to the cloud. And that's what I'm going to do in this example. So to get started here, I've downloaded and installed Microsoft Visual Studio Community Edition. It's free. To get started, I'm going to go to the Tools menu. And what I want to do is go down to Options, and I want to look at Accounts, because you have to make sure that you link your on-premises Visual Studio installation to your Azure account. Now, I've already done that. If not, I would click the Add button and specify the cloud details. I've already connected to Azure, so that's good. We're good to go in that sense. So now I'm going to go to View, up menu bar, and I'm going to choose Cloud Explorer. Now, that'll show me over on the left any accounts that I've connected to in Azure. Now, to the left of the little person icon for account management, I'm going to click on Resource Types, and then in the Cloud Explorer, I now see resources available in my Azure account. So, for example, if I expand App Service Plans, I can see an App Service Plans created in my Azure subscription. If I go to App Services, I'll see any existing web apps. Here I see one called Web App YHC172. And I can see other items too as we scroll down, things like storage accounts that are available and so on. So we know we've got a valid connection to the Azure cloud. So the next thing we're going to do then is deploy a new web app. To do that in Visual Studio, I'm going to go to the File menu, I'm going to choose New, and I'm going to choose Project. And I'm going to search for Azure Resource Group. Now, if I don't see any search results for anything related to Azure, I can click on the Install More Tools and Features link here in Visual Studio to make sure it's up to date. So I'm going to go ahead and go through that process. And I can see that ASP.NET and Web Development is checked on. So is Azure Development. Perfect. That's what I want. So I'm going to go ahead and click on Close. And I'm going to click on Update. Once again, I'm going to go into File, New, Project. Going to search for Azure Resource Group again, And this time we get all kinds of items returned, which is great. So I'm going to use the Azure Resource Group template, and I'll click Next. I'm going to accept the defaults for the names of the project and the location on my on-premises station. I'll choose Create. And then I can see a list of templates on the left, including Web App, or if I wanted to, I could select Web App plus SQL or Logic App, and many other choices available as we scroll down further, including Docker, Ubuntu Server, Web App plus CDN. It's a content delivery network, so we have plenty of choices. I'm just going to choose plain old Web App, and then I'm going to click OK. Over to the right here in Visual Studio, in the Solution Explorer window, I can see the name of my project. I can see, for example, that we've got a website JSON file. I'm just going to go ahead and double click on that to open it up. We can see it shown here in the center. So we can see we've got the configuration for the web application. We could go through and make changes, such as notice we've got a variable for the website name, which here is going to concatenate the text website with a unique string that's derived from the resource group ID. So we can make changes to that if we so chose. But once I've made the required changes for my web application, I can then right-click on the name of the project in Solution Explorer, choose Deploy, and then New. I want to make a new deployment. In other words, I want to get this web app into Azure. So I can choose my subscription, choose the resource group I want this deployed into. I can see the deployment template it's picking up from my Solutions Explorer. That's the website.json file we were looking at, and then the parameters file. And I'm just going to go ahead and click on Deploy. Now it wants the hosting plan name, so we're going to have to fill in that value. So back here in the portal, I've got an app service plan. That's what it's looking for, called ASP-YHZ17. So I'm just going to copy that name, and we're going to use that one. Okay, so righto, we're back here in Visual Studio. I'm going to paste that into the hosting plan name field, and I'm going to click Save. We can now see at the bottom in the output window here in Visual Studio that the build has succeeded for our project, and it's in the midst of deploying it to Azure. Now, if you happen to get any errors down here, I have an error. It says deploying template using PowerShell script failed. Uh-oh, that's not good. I can see here it's making references, it appears, to PowerShell commandlets that perhaps aren't there. Looks like it's using the older version of PowerShell commandlets, get-azure as opposed to get-az. Okay, well that's coming from our deployment script here. Let's actually double-click and open that up to see what the contents of that script is. Because what we could do here is manually make a change, if we so chose, to any references to PowerShell commandlets that might be out of date. So sometimes you'll run into this when you're using different types of development tools. They may use templates that are a bit out of date. So, for example, let's take a look here. I've copied the code in WordPad here from that JSON file so we could look at it more easily. I'm going to search for new-az. So we have to make sure we change any references to older versions of PowerShell commandlets like new-azure RM resource group is now new-az resource group. So we'd have to go through and make sure we change all of the appropriate references. Now, once you've done that and you save it back in Visual Studio and redeploy it, you'll get this result. So down at the bottom in the output window, I now see that it says it has successfully deployed our template website.json because we changed the references from the outdated PowerShell commandlets to the new ones, and it looks like it's good to go. So let's check Portal to see if we got a new web app there. In the portal here, I've gone to the All Resources view and I've filtered by type. So I'm only looking at app services, and here it is. It's our website. Notice, according to our JSON file, the prefix name for the website begins with website, followed by a unique string that comes from the resource group location. There it is. We've got our application up and running, deployed from Visual Studio. One of the many great things you can do with Azure App Services when you deploy a web app in the cloud is you can work with deployment slots. Let's take a look at that here in the portal. I'm going to start by clicking to open up an existing web application. And I'm going to scroll down in the navigation bar on the left so that we can look at the deployment slots. So I'll click on deployment slots. Now, instead of seeing deployment slot configuration, instead I get a message that says I need to upgrade to a standard or premium plan to add slots. It's not available in this tier. Not a problem. That's part of the app service plan which this web app is associated with. And I can see that affiliation if I scroll down further in the left-hand navigator. I can see app service plan. Well, we're going to change that. So I'm going to go ahead and click on the app service plan so we can change it up a little bit. First of all, I'm going to choose Scale Up over on the left for the app service plan. Currently, we're in the dev test pricing tier. I'm going to choose Production, and I'm going to use the S1 tier with 100 total Azure Compute Units or ACUs. That's what I want, and I'm going to click Apply. Now that change is going to apply to any web apps that use this app service plan. I can see those over on the left here under Settings by clicking on Apps. Here I can see our web app. So I'm going to go ahead and click on the link for our web app there. It's just a quick way to go back to it. And once again, we're going to scroll down so we can look at the deployment slots. This time it looks different because we changed the tier in the app service plan. So we can see that we have our website. It's got a status of running, and notice the default deployment slot is called Production. Perfect. And we can see that 100% of the traffic is going to that deployment slot, of course. I'm going to go ahead and click the Add Slot button at the top. I would do this if I want, for example, to be able to test my application and make changes to it without affecting the online version of the app. The last thing we want users to see is one of those old web pages that says the site is under construction. That's from the 1990s, early 2000s. There's no need for that anymore when you're using Azure. So I'm going to click Add Slot. So for a name for this web slot, I'm going to call it Dev Test. Down below, it's set to not clone settings from the original slot, the production slot, but I'm going to open that drop-down list up and select the name of the web app because I do want to clone settings. What we're talking about cloning here, the new deployment slot dev test that we're creating, we're talking about cloning all of the web app settings, language framework options, HTTP version settings, also things like connection strings. I want all that. So I'm going to go ahead and leave that as it is because I've told it to clone settings from our original web app, and I'm going to go ahead and click Add to add the new slot. And we can see over on the right at the bottom, it says it successfully created our slot. So I'm going to click Close. Sure enough, our slot shows up here, Dev Test, in the list. Now, what I'm going to do here is first point out that notice that we've got 0% traffic being sent to that, although we could click in the box and we could change it up if we wanted to. However, I'm not going to do that. I'm going to click on the link for our dev test slot. Now, when I go to the dev test slot, I'm going to look at the overview blade because I want to take a look at the URL. Notice the URL for this refers to our dev test slot, and I can click on it, and of course, it's going to pull up the web application. We can see the page, and this is where presumably if we were making changes to the web app, we'll be able to connect to the web app URL if it's that type of an app, and be able to test out the changes to make sure everything's working well, and so on. So the URL is different then for each deployment slot. And now that we're in our dev test deployment slot, if we were to scroll down in the navigation bar on the left and click on deployment slots and look at them from this perspective, notice that neither of them is a link. We can't switch back and forth because we are currently in our dev test slot. Well, that's no problem. Let's click the X to close out of that. Now we're back to our original web app. And again, we can see the deployment slots. So notice that what we have as an option up at the top is the ability to swap. I'm going to click on Swap. So in this case, our source in the drop-down list at the top is going to be our dev test. So that's presumably where we've made changes and tested them to make sure everything works. And we want to swap that with our production. Okay, so once we've done that, any changes that might have been picked up, we haven't made any changes, will be seen down below. We can see source to target changes. So if nothing's changed, that's what we get. But let's say we did actually make a change. Just close out of that. Let's say we go into our dev test slot, and let's say one of the things we might have changed is a connection string. So I'm going to scroll down under settings on the left and click configuration. And I'm going to scroll down under application settings to connection strings, and I'm going to click new connection string. I'm going to fill in some sample values for a database connection string, and I do have an option, a checkbox here, that says deployment slot setting. If I want this setting only apply to the deployment slot, I'm not going to check that because if this is a setting that we've tested and it's something that we want to be used in a production app, then I don't want it to be specific to deployment slot. So I'm not going to check that option. I'm going to click OK, and I'll click Save to save that, and I'll choose Continue. So we've made a connection string change to our dev test deployment slot. Okay, let's click the X in the upper right to close that. So back in our original web application, I'm going to click the swap button again up at the top on the right. The source is going to be dev test. The target is our production slot. And notice it picked up our setting down below for the connection string. Perfect. That's in the source, and the target, well, it never was there. So that's fine. Let's go ahead and click swap. Now, after a moment, we see in the bottom right, it has successfully completed the swap. Okay, I'm going to click close. So we are currently in our source web application. So if we were to look at configuration, and in our application settings at the top, just kind of scroll down, notice that we now have a connection string here because we swapped it with the dev test deployment slot. Azure functions are part of Azure serverless computing. Now, there's always a server running in the back end somewhere, but what we're talking about is not having the responsibility of deploying virtual machines to support our code functions. An Azure function is really a self-contained piece of code that performs a specific task, as opposed to using something like Azure Logic apps, which are actually more of a workflow that gets triggered. So here we're talking about a single type of function that has a specific task that gets triggered by something. So triggered events then occur to make the function execute. We'll talk about what those are a little bit later. So many different languages are supported by Azure functions, so you can choose whichever one suits your specific need. For example, JavaScript is supported when you build your Azure function, C#, PowerShell, F#, to name just a few. When you work with Azure functions, you need to consider how cost works. Now, the good news is that it's only applicable when the function is actually executing after it's been triggered. You're paying for the usage of the function while it's running, not while it's being stored. Then there are code packages that you can add to your Azure function for additional functionality. So as a developer, instead of basically redesigning the wheel from scratch, you can call upon existing packages that you want to use within your function. You can do that using NPM. This is the Node Package Manager. This is designed for the JavaScript language and allows you to bring in additional packages that increase the functionality of your code. Or you might use NuGet. This is an open source package manager type of tool that's designed when you're writing code in a Microsoft environment. Now let's talk about those Azure function triggers. What can actually occur to make the function execute? Well, one way to look at this is when we have storage accounts and we're allowing blobs to be uploaded. That is an event that could trigger the execution of an Azure function, or a specific HTTP request, or the presence of a message within Azure storage queue, or a message that appears in IoT Hub, or even just based on a timer event. So basically on a scheduled basis, you could trigger the execution of an Azure function. Pictured on the screen, we see the creation of an Azure function using Microsoft Visual Studio. Now, you can certainly do this directly in the portal, but if you're a developer, you're probably using a tool such as Microsoft Visual Studio, so from it directly, you can work with Azure functions and choose specific types of triggers. We see here there are different types of triggers like Bob triggers, Cosmos DB triggers, Event Hub triggers, HTTP triggers, IoT Hub triggers, the list goes on and on. In the next screenshot, we see a .csx file. This is a Microsoft Visual Studio C# script file format. And we're looking at this here at the trigger level within the Azure portal when we're creating a function. So there's an HTTP trigger that's being created. And of course, at this point, it's up to the software developer to write the appropriate code to make the function do what it was designed to do. When software developers look to automating their code solutions in an Azure environment, they might look to Azure Functions, which are self-contained pieces of code, or something a little bit larger without writing code that allows for workflow management. And that would be where Azure Logic Apps kick in. Just like Azure Functions, it's considered serverless computing, meaning we don't have to deploy and manage the underlying virtual machine servers or instances that support our workflows. But unlike Azure Functions, with Azure Logic Apps, you don't need to write any code. So you can use templates to set up a workflow. And just like Azure Functions, they do use triggers. There are triggers that will determine when the workflow would begin. There are also actions that actually execute. So as opposed to code functions that you would write in Azure Functions, you can specify actions. So really, the trigger is the first step that starts the execution of the workflow for an Azure Logic app. Azure Logic apps use triggers as well as actions. Triggers are used to start the workflow and they're spawned by some kind of an event. That event could be a schedule, so you've scheduled something to occur, a workflow to execute, or it could be new data that's being received through some kind of external connector. You might, for example, have a Twitter connector that looks for a specific text string within a tweet, and that could be the trigger that starts the workflow for your Azure Logic app. Or it could be a record showing up in a database, such as a SQL database. There are many different connectors and therefore many different ways that you could trigger the execution of your Azure Logic app workflow. So data can be passed to Logic app actions. Actions themselves, of course, exist within a workflow. They occur after a trigger. The trigger runs an action. They're used to process some kind of data, whether it's through HTTP connections or through email notifications. Now, there are many different types of connectors. Connectors are a very big part of Azure Logic apps because this is how data is brought into the Azure Logic app workflow, whether it's through Azure App Services or on-premises file system or SQL Server or HTTP or SharePoint Server. These are all different types of connectors that provide triggers and actions, and this way we can have our workflow execute based on the data provided through the connectors. In this demonstration, I'm going to configure a custom DNS domain name for an existing Azure web app. So here in the portal, I've navigated already in the left-hand navigator to the App Services view, and I see I've got one web application whose status is now running. So I'm going to go ahead and click on the name of that to open up the details for that web application. Specifically, what I want to do is scroll down in the left-hand navigator until I see custom domains. Now, over on the right, what I want to do is add custom domain. So I'm going to click Add Custom Domain, and I'm going to add www.lachanceit3.com. So this is what I want this web app to be known as when it comes to its name, its DNS name. Now, when I click Validate, down below, I can select a hostname record type, for example, A record or CNAME, it doesn't matter. But as I go down below, because CNAME is selected, we see the CNAME config. What it's saying is that hostname is available, but I have to prove domain ownership. I have to prove that I have control of this DNS domain, lachanceit3.com, and I do. I have registered through an external DNS registrar, specifically GoDaddy. Now, for proving the domain ownership, what I need to do, create a CNAME record with the values shown here. So in my web browser, I've signed in to the GoDaddy Domain Manager site for my domain. There it is, lachanceit3.com. And down below, I'm going to add the CNAME record by clicking Add. The type is going to be CNAME. Back here in the portal, it says the host value will be www, and then the value here is going to be the current URL of this website. A CNAME record is an alias. It basically points to another DNS record. So I'm going to go ahead and put www in the host record back here in GoDaddy, and then I'll paste in the points to, and I'll click Save. So now we've added the CNAME record in accordance with what we were instructed to do in the Azure portal when we added the custom DNS name. Back here in the portal, under DNS propagation, it says it can take some time for this to work before you can prove domain ownership. You can come back and do it at a time, but it says, you never know, it might even take up to 48 hours. I've never personally seen it take that long, but one never knows. So I'm going to scroll back up to the top and click Validate to see if it'll pick it up yet. So it's checking the hostname availability and the domain ownership as we see at the bottom. And both check out. Well, that's fantastic. Let's click the Add Custom Domain button. And when we go back to the previous view, we'll see that it will have been added. It's a verified domain name. We have proved ownership of it. So it shows up in the list here. Now, it's not secure. There's no SSL, or more correctly, we should state TLS binding that's associated with that. However, let's just go back up here to the overview blade. Notice the URL now reflects our custom domain name. Now it's only HTTP, but http://www.lachanceit3.com. Let's click on it to open it up to see if it works. Hey, it works. Now it's not secure with HTTPS, but that's a separate configuration. At this point, we've at least got a custom DNS domain name working for our Azure web application. In this demonstration, I'm going to enable an SSL or TLS configuration for a web application running in Azure to secure the connection. So the first thing I've done here in the portal is navigated to a key vault. In the key vault, in the left-hand navigator, I'm going to go down to certificates. I currently don't have any certificates, so I'm going to click the Generate Import button up at top. And here I'm going to create some PKI security certificates that I can use to enable an HTTPS binding for my web app. So I'm going to leave the method of creation for the certificate at generate, and I'm going to specify a certificate name. I'm going to call it Azure Web App 1. And for the subject, I'm going to specify CN for common name equals www.lachanceit3.com. Then I'll click on DNS names, and I'm basically going to put the same thing in here, the DNS name, www.lachanceit3.com. That's what I want the certificate to match. And we're going to be creating a custom DNS domain name so that that matches that as well. So I'm going to go ahead and click OK, and then I'll click Create to create the certificates. We can now see that the certificate is in the midst of being created. It's currently pending. So I'll just click refresh. We can now see it's there listed as your web app. We can see the thumbprint. And to the thumbprint, we can see that the status is that it's enabled. So here in the portal, I've navigated to my web application where I'm going to scroll back down to the TLS SSL settings area. Now what I want to do here is go to private certificates. I'll select that over there. And what I want to do is import a private certificate from the Azure Key Vault. So I'm going to choose Import Key Vault Certificate. So I have to choose Key Vault from the list. There's KV172, and within it I'll choose the certificate for Azure Web App 1, and I'll click Select. So we will have added then our private key certificate from the Azure Key Vault. There it is listed down at the bottom now. We added it to our web application. The next thing we need to do is actually add the SSL or TLS binding. So to do that, I'm going to go to the Custom Domains item on the left, and that's going to show me that I've got a custom domain that's verified, www.lachanceit3.com. That has to match the name in the certificate, but it says it's not secure. So let's go ahead and click the Add Binding link on the right of that to make this happen. What I'm going to do is from the private certificate thumbprint dropdowns, because we've just added it, I'll choose www.lachanceit3.com, perfect. And for the TLS SSL type, I'll choose SNI SSL. That's just server name indication. It's used to specify that we're connected to the host name by name. So I'm going to click Add Binding. And after we do that in the background, not only do we have a custom verified DNS domain name, but it's also secured now. So if we kind of scroll up here in the web app navigation bar and go to Overview, we'll see that the URL reflects HTTPS, so secured connection, // and our custom DNS name. So I'm going to go ahead and click on it just to make sure it works. Now, this is expected. It says this site is not secure. In other words, the web browser does not trust the issuer of the certificate. That certificate was created within an Azure Key Vault. That's why. So until we add a trusted root certificate to all of our devices so they trust that certificate issuer, this is to be expected. I'm going to click on Details and say Go on to the web page, and it connects. So we've got an HTTPS connection using our custom DNS name. It's important to ensure that your web applications and the content that goes along with them is backed up. And we can do that very easily in the Azure portal for a web application. I've already navigated in the portal to an existing web app. So in the navigation bar, all I'm going to do is scroll down until I see backups. What we're going to do here is configure how we want this web application backed up. So over on the right under backup, it says backup is not configured. Click here to configure backup for your app. That's exactly what I'm going to do. The first thing I have to do is select a target container within a storage account to store my application backup. It's storage not configured. So let's start by clicking on that. Then I'm going to choose an existing storage account, and I'm going to add a new container here. Let's say it's going to be called Web App 1 Backup. I'm going to leave the public access level to private, no anonymous access, and I will click Create. And I'm going to select that from the list, Web App 1 Backup, and I'll choose the Select button at the bottom. So now we've told it where we want to store backups of our web app. Down below, we can enable scheduled backups. Now that's what I want to do. So I'm going to go ahead and click on, and I'm going to specify the details for the scheduling. So it's set to backup by default once every day, but I could change it to hours. I'm going to leave it once daily. I can specify the starting date and the time, and also the retention days. How long is backup kept? Set to 30 days. I'm okay with that. Keep at least one backup. I'm going to leave that on yes. And down below, if I've got databases that this web app is using, I can also elect to back them up. So I do. I've got a database connection string here for my SQL database. I'm going to turn on the check mark to include it in the backup, and I'll click Save. So at this point, it puts us back on the previous screen where we see that there's a backup in progress. We can click Backup at any time to perform a backup instead of waiting for the schedule. We can also perform a restore from a backup if we have a problem with our web application. And after a moment down below, we can see that the backup succeeded. Of course, notice the size is very tiny because there's almost nothing in this backup, in this web application. So I'm going to go ahead and click Restore button. So should you need to perform a restore, you just have to come into the Backups blade, click Restore. You would choose, of course, App Backup as the restore source. So we can see the backup that we can choose from the list. And down below, we can choose whether we want to overwrite the destination app or build a new app. So I'm just going to leave overwrite. And down below, we have a couple of other settings. Do we want to ignore databases and so on? And so to perform the restore, I would just click OK. The Kudu interface for an Azure web application is kind of a backdoor way to get into examine the web application a little bit, all using a web browser interface. Get started here in the portal. I've navigated to an existing web app. Now, in the overview blade for the web app, if you look at the URL, it has HTTPS, a custom DNS domain name. And if I click on it, it works. Now, it says this site is not secure because the signer of the certificate is not trusted by this computer. But if I were to click details, go onto the web page, it works just fine. However, if you want to go into the Kudu interface, now Kudu is spelled K-U-D-U, then you need to modify the URL to include SCM, where SCM stands for Site Control Manager. So after the www dot that I have for my custom name, I'm going to put in SCM dot and then let it continue on with the URL. But when I press enter, it doesn't work. And the reason is because when you want to use the Site Control Manager, you have to use the original DNS name of the web app. In other words, the one that uses the default .azurewebsites.net DNS suffix. So I'm going to close this web page, and back here in the portal, where I'm looking at the details of my web app, I'm going to scroll down and we're going to look at custom domains. Because there, beside our custom domain, we will also see the original URL to site, which I'm going to highlight and copy. Let's just go ahead and paste that into a browser window to make sure it works. And it does, it works fine. Now, what I'm going to do is change that name so that before .azurewebsites.net, I insert a .sem. When I do that, it may prompt me to log in if I'm not authenticated already. And this is the Kudu interface. Again, Kudu is spelled K-U-D-U, as you can see. So we're looking at our environment. So I can click on environment at the top to go to a page that shows me all of my environment settings in one page. So much easier than navigating through a bunch of different blades in the Azure portal looking for settings. So I can see app settings, connection settings, environment variables, path variable, HTTP header information, server variables, all kinds of stuff that is reported back from the underlying virtual machine or machines supporting this web application. I can also click on the Debug Console menu at the top of this page. I can select from either CMD, a Windows Command Shell, or PowerShell. I want a Windows Command Prompt environment. So when I do that, I can see up at top, I've got a couple of directories, data, log files, and site. I can navigate by clicking them or by using change directory down in the command prompt window below. For example, if I click on site up at the top, down below, it's change directory into site. Conversely, down in the command line, if I were to type change directory www root, it switches up above. And here I can see, for example, my default host start.html web page for this particular web app. And with that file, I could download it. There's a download icon to the left of it. I could click the pencil if I wanted to edit the contents of that file, or I could delete it. So that's pretty cool. We can get to the back-end file system for our web application. I might even go to Tools and choose, for example, Diagnostic Dump, and I could download a Diagnostic Dump file in zip format if I'm having problems with web app and I want to examine the Diagnostic Dump file. Also, if I go to Tools, we can also view a number of other options. We can go to the Web Jobs dashboard. We can look at any webhooks that might be triggered to run code. I can even click on Process Explorer up at the top if I want to see any running processes that are supporting this web application. And I can see that there are two of them here, one of which is for SCM. You can see that there's a little SCM icon. So the true web application is the first instance of the w3wp.exe file. And we can see the PID, the username under which it is running. And if I scroll over even further, I can click Properties, which shows me a lot of the environment settings and details that we saw earlier. But I can also click on Modules and see all of the actual DLLs running in the background with some details for each and every one of them. So that's kind of cool. Also, we can see handles, we can see threads and environment variables. So there's a lot of detail then to be gathered by going to the SCM, the Site Control Manager part of your Azure web application. Normally you would do this if you need to dig deeply into it to look for performance or crashing issues of some type, or if you want to get into the underlying file system using a browser GUI interface. As the name implies, application containers are an isolation boundary for application components that separate it from other applications or the operating system. So pictured in our diagram, at the very bottom, we have the host operating system, whether it's running Windows or Linux, on top of which we would have some kind of a container platform, such as the Docker engine. Docker is a software solution that allows the creation, management, and running of containers on a host operating system, but Docker itself is not an operating system. Now above that, we could then have binaries and libraries that are required by software applications, each running in a container listed at the top of our diagram. We've got containers for app A through to and including app G. So each of those represents a separate application or separate application component. So you can decouple larger applications, the components from one another, by containerizing each component. You might have app A running the components for an application required for authentication, whereas app B might be a container for the same app that deals with uploading, if your web app supports uploading, that type of thing. Now, each of these application containers doesn't have an operating system within it like a virtual machine does. Instead, they rely upon the underlying host OS that's already up and running. So therefore, each of these app containers shows up as a running process from the perspective of the host operating system. Now, in some cases, depending on your needs, you might have specific binaries or libraries stored within an application container to truly make it portable. Application containers are based on container images. So therefore, you could say a container is a runtime instance of an image. Now, the container will contain things such as a file system, the application software and its settings, in some cases, app-specific libraries and a runtime environment. We can also, in Azure, deploy Azure Container Instances, otherwise called ACI. Now, the benefit of this is we don't have to worry about deploying or provisioning a virtual machine and installing the Docker engine. All of that will be taken care of for us. We can specify container image from a private Azure repository, so through Azure Container Registry, ACR, or we might go out and grab a public container image, such as through GitHub or something like that. So the thing about containers is that because they don't contain an operating system, they start up very quickly. Remember, they rely upon the host operating system that's already up and running. Azure supports the Kubernetes Service, or AKS, offering. So this uses a Linux virtual machine cluster to handle your containerized applications on a larger scale. So it manages distributed containers, including the deployment of them, making sure they are resilient so that if we have failure of an application container, Kubernetes has the ability to auto-start a new instance of that. Also, VM scale sets are available, load balancing solutions. So really, you could say that Kubernetes then gives you a framework for running a distributed application. Distributed meaning multiple components, multiple application containers that are distributed across VMs in a Linux cluster. As you might imagine, that can be complex if you're setting up everything yourself from scratch. But with AKS, all of the underlying provisioning is handled for you by Azure. AKS, when it comes to deployment, can be done through the Azure portal, so the GUI, or you could use the AZ-AKS create CLI command, or if you're using PowerShell, you could even deploy it using new-AZ-AKS. You can also manage AKS using Azure Cloud Shell. That means that you could use the kubectl command, KUBECTL. If you're used to working with Kubernetes outside of Azure, you'll be familiar with the kubectl tool. This is a command line tool that you use to manage the Kubernetes cluster. Of course, you'd also use CLI and PowerShell commands to manage your AKS service. A Microsoft Azure Container Registry, otherwise called ACR, is a private repository in the cloud where you can store Docker container images of your choice. So we can build this and manage it using command line tools like the Azure CLI, or I can use GUI tools like the portal, which I'll do here. So here in the portal in the upper left, I'm going to click Create a Resource. And I'm going to search up Container. And I'm going to choose Container Registry, and then I'll choose Create. I'm going to specify a resource group into which this Azure Container Registry resource will be deployed. And I'm going to call this ACR. And I'll add a couple of characters to make it unique while adhering to my organization's naming standards. Notice that the DNS suffix by default for the container registry is .azurecr for container registry.io. I'm going to leave this in the Canada East location, and I'm going to enable the admin user. The admin user is what I can use in terms of a credential set when I want to authenticate to the container registry to push container images to it. I'll leave it on the standard SKU. I don't need any enhancements in performance or scaling. I'll click Next for encryption. So because I'm not using the premium SKU, I don't have the option of using customer managed keys for encryption. I'll click Next for tagging, then Next for review and create. And after the validation has passed, I will click the Create button in the bottom left. And before you know it, it's ready. So I'm going to click the Go to Resource button to jump into the properties of our newly created Azure Container Registry. So now that we're looking at our container registry, if I click on the Quick Start item in the left-hand navigator, it gives me instructions. How do I use this thing? So number one, you need to install Docker because you can use the Docker command line syntax to push container images to the Azure Container Registry or pull them from it when you want to use them. Well, interestingly, Docker is actually built in to Cloud Shell. So for example, if I were to launch the Cloud Shell here by clicking the Cloud Shell button at the top of the portal and simply type in Docker, I could see the next level of commands that come back. So I could start working with this right within Cloud Shell. I don't need to install Docker in any way. So we are interested, or we will be interested primarily when we start using the container registry in Docker pull and Docker push to respectively pull an image or a repository from a registry or push an image or repository to a registry. Anyway, I'm going to minimize Cloud Shell. So it starts talking about how to do that. Now, in order to authenticate, I'm just going to scroll down here in the Quick Start page. You're going to use Docker login, and then you're going to give the name of your Azure Container Registry, including the .azurecr.io default DNS suffix. Now, that means you're going to be prompted for some credentials. And so when you click the access keys right over here on the left, this is where you'll be able to find what you need to authenticate. There's the registry name. There's the login server URL. The admin user is enabled because we enabled it on creation. So we can see the username. And also, we've got 2 passwords. You only need one at a time. You can use any one of those passwords to authenticate. There are 2, similar to how there are 2 access keys for Azure stored accounts. Now, why is that so? Well, you have 2 of them so that you can continue using one while you refresh the other one with the regenerate icon listed on the far right here, because you should be changing these passwords periodically to enhance security. In this demonstration, I'm going to use the Docker CLI to publish a container image to an Azure Container Registry, otherwise called an ACR. So I'm going to use the Docker CLI, not the Azure CLI. What I've done is I've deployed an Azure virtual machine. I searched from the Azure Marketplace for Docker and deployed an Ubuntu Linux-based VM that has Docker installed, and I've logged into it here. So if I were to run docker-h, for instance, for help, I can see that the Docker command line tool is installed because we see the help listing of the next level commands that would be available. So the first thing I'm going to do is clear the screen with clear, and I'm going to run sudo. I'm doing this because I want to run the command with elevated privileges, sudo docker run -it hello-world. Now what's going to happen by default is it will try to pull that from Docker Hub out on the internet, given that this VM has internet connectivity. So I'm going to clear the screen, and I'm going to run sudo docker. Well, actually, let's see what happens if I don't put in sudo. Let's say I run docker ps. In other words, I want to list all of the containers -a. So it could be something about an error loading a config file and permission denied and so forth. Well, if I use the up arrow key to bring back the previous command and then prefix it with sudo and a space and press enter, no problem, it loves it. So we can see that we've got 2 container images here, the Hello World container image that was pulled down twice from Docker Hub, which is a public registry out on the internet. Now what I want to do is log in to my Azure Container Registry using the Docker CLI. In order to do that, I need to know some details. So let's flip over to the portal and get those details. Here in the portal, I've navigated to an existing container registry. What I'm interested in doing is going down to access keys in the navigation panel on the left. And the first thing I want over on the right is the login server URL. So I can just click the copy to clipboard icon to copy to the clipboard. Now, while I'm here, I can also take note of the username, and one of the 2 passwords doesn't make a difference which one. I'm going to need all of these things to perform a login using the Docker CLI. So back here in Linux, I'm going to run sudo docker login, and I'm going to put in the server name that I just acquired from the Azure portal. I'll press enter. Now, because I was already authenticated, I don't get prompted for the username or password, but you can also get those from the portal as we just saw, and you might have to enter those. At this point, you've logged into your Azure Container Registry. So the next thing that we're going to do, just once again run sudo docker ps-a, is we're going to take one of these container images and we're going to tag it a little bit because we want to make sure it matches the name of our Azure Container Registry, and then we're going to push it to it. Back here in the portal, when you go to the Quick Start blade in your Azure Container Registry, you're going to get all the instructions for how to do this. And it's customized for your specific environment, meaning it's got your specific Azure Container Registry name in all the examples. So for example, in step 4, push to your registry, they're using Docker tag to tag, essentially rename the container image to prefix your container registry name. And it needs to be done before it can be pushed up there. So I'm just going to go ahead and copy that command. And I'm going to paste it by right-clicking it here in my SSH session. I'm using PuTTY for my SSH session to my Docker VM. However, I am going to go to the beginning of that command line. I'll press home to do that. And I'm going to prefix this with sudo so it runs with elevated privileges. Then back in the portal in the quick start area, step number 4, I'm going to copy the Docker push command. Again, this is tailored to my specific environment. So I'm running Docker push. I've got the name of that image. Of course, the prefix part of the name tells it which registry that it should be pushed into. So I'm going to go ahead and copy that. I'll paste that back here in my SSH session with my Docker host. Go to the beginning of the line and prefix it with sudo and press enter. We can see it pushing it over the network to our Azure Container Registry. Back here in the portal, step 5 in the Quick Start blade talks about how you can then pull that from the registry using Docker pull. So as an example, I'm just going to go ahead and copy that, and we're going to run that. And I'm going to prefix that with sudo. Okay, so this way we know now how we can acquire container images such as from Docker Hub, public repository on the internet. We know how we can get that container image into our own private registry. Normally, you would only do that once you've customized it to suit your own personal needs for containerized applications. We also know how to pull from our Azure Container Registry. Azure Kubernetes Service is really a container orchestration type of framework where it allows you to scale and also ensure that your application is resilient. Your application containers are resilient by restarting any failed containers. So I'm going to go ahead and deploy Azure Kubernetes Service here in the portal. I'll start by clicking on Create a Resource. I'll search for KUB and then I'll choose the Kubernetes Service. And then after that, I'll click Create. I'm going to specify the resource group where I want this service deployed, and I'm going to give this a name. I'm going to call it AKSYHC172. And I'll deploy this in a region that makes sense, ideally one that's near me physically, so I'll choose Canada Central. I'm going to leave the Kubernetes version to its default version. And notice that down below, we can change the node size, because we're talking about here having a cluster of Linux virtual machines that support your containerized applications. That's really what Kubernetes Service is about. So here I can specify the underlying horsepower, the sizing, and the node count, which is set to 3. I'm going to leave those as they are by default. I'll click Next for scaling. I'm going to leave VM scale sets enabled, and I'm going to leave virtual nodes disabled. That's for extra bursting capabilities if you want to be able to have containers pop up on additional nodes. I'm not going to do that. I'll click Next for authentication. I'll accept the defaults. Next thing I have to do is deploy this into a network giving a DNS name prefix. So it's already got the default DNS name prefix, which I will leave as it is. I don't want this to be a private cluster, so I'll leave that on disabled. And I'm going to click Next for monitoring, and Next for tags. I'm accepting the defaults. Next for review and create. And after it passes the final validation, I will click Create. After a few moments, the deployment will be complete. So I'm going to click on Go to Resource so we can check out our Azure Kubernetes Service deployment. In the Overview blade, I can see the API server address that's required by any code. And over on the left, if I open up node pools, we'll just wait for that to pop up, we can see that we've got a node pool here. And if I click the context or the 3-dot menu over on the far right, I can choose Scale. Now, when I'm in here, I also will have the option of turning on auto scaling. Currently, the node count is set to 2, but we could configure auto scaling by turning it on and then clicking Apply, which I will do here. Next, I can go to the Deployment Center blade by clicking that in the left-hand navigator over on the left, where it takes me through all of the steps for me to launch a Docker application in Azure Kubernetes. Now, if you've already got an on-premises configuration, then you would just need the Kubernetes manifest file. It's a .yaml file, YAML, that you could use to bring an app into AKS if you've already got a containerized app. So for example, I could choose GitHub as a source to pull a container image from. I could click on Next. In this case with GitHub, I would click Authorize and specify my credentials to log into my GitHub account if I have one. After I've signed in, I'll click the Authorize Azure GitHub Actions button at the bottom. Now back here in the portal, I can then select from my own custom repository, or I can choose all repositories. So I'm going to choose an existing repository that's got a Docker-based app, and I'll click Next. This is a basic Hello World type of container application, so you can see the Docker file and the details. I'm just going to go ahead and click on Next. And I'm going to use an existing container registry. There's the name of my existing container registry here in Azure that I've created previously, and I'll click Done. So we can now see the deployment listed. And if I go to Overview, we'll start to see that there indeed is a little bit of activity if we were to start clicking Monitor Containers. Azure Container Instances, otherwise called ACIs, are a managed service. And so this means, of course, that we can easily deploy a container without the fuss of dealing with the underlying virtual machine and installing the Docker engine to support that containerized application. So to get started here in the portal, I'm going to click Create a Resource, and I'm going to search for Container Instance. And I'll choose Container Instances from the resultant list. And then I'll click on Create. Next, I'll specify the resource group into which I want this Azure Container Instance deployed, and I'll give a name to this container. I'm going to call it AppCont1, and I'm going to deploy this into a specific region, in this case, Canada Central. Now notice that the list of regions might appear a bit smaller than you might be used to when deploying things like virtual machines and storage accounts. This is changing all the time, but yes, it is a bit of a smaller list for the location selection. For the image source, I can choose Quick Start Images. So down below, I've got a couple of samples I can use, whether running on Windows or running on Linux. I can also point to an Azure Container Registry, and I can also point to Docker Hub or some other registry. If I go to Azure Container Registry, it knows I already have one with an image in it, and I want the latest version of that image. So it's just a sample Hello World application. And I also have the size for the underlying VM that will support this. So I'm not going to change the size. 1 vCPU and 1.5 gig of RAM should suffice for the Hello World application. Then I'm going to click Next for networking. I'm going to leave this on the default of public. If, for example, I need this containerized application or application component reachable from public networks, in this case over port 80, so I'll click Next for advanced, Next for tags, and then Next for review and create. And then I'll click the Create button to create this container instance. After a moment, the deployment is complete, so I'm going to go and click Go to Resource. That's going to take me into the properties or the details for my Azure Container Instance. What I want to do here is go to Containers over on the left. We can see that we've got one container here. We see the name of AppCont1, and we can also see the image from which that stems. Down below under Events, I can see the date and timestamps of starting the container and after having pulled the image. Now, if I go to Properties, I can also see the specific tag name for that image on port 80. If I click on Logs, I can even see the result of running that container. Now, in this case, all it does is say hello from Docker. But at this point, we have successfully deployed an Azure Container Instance with minimal hassle. Okay, so in this course, we've examined Azure Web App Management, as well as Web App Backups, custom DNS domain names, and the Azure Kubernetes Service, AKS, and Azure Container Instances, ACI. We did this by exploring the Azure App Service for hosting web apps, how to deploy a web app. We looked at how to manage an Azure App Service plan, deploy a web app, and use Azure deployment slots to configure web app staging. We looked at how software developers can work with functions in the cloud and also when they can use logic apps for workflows. We looked at how to configure a custom DNS domain name for a web app and how to configure SSL and TLS configurations. We then looked at how to enable web app backup and connect to an Azure Web App Kudu interface. We looked at how to use the Azure Kubernetes Service, AKS, and Azure Container Instances, ACI. We looked at how to create a container image repository in Azure and how to publish container images to it. And finally, we looked at how to manage both AKS and ACI. In our next course, we're going to move on to explore methods for improving the performance, security, and availability of Azure web apps, including the use of Azure Load Balancer, Azure Application Gateway, Azure Web Application Firewall, and Azure Front Door Service.
One way to improve the performance and reliability of an app is to put it behind a load balancer. The Azure Load Balancer takes incoming app traffic, so these would be requests for the app or the component, and they send it to back-end servers that can handle that workload. So the more back-end servers you have during peak busy times, the better the overall performance. You can configure in Azure a public load balancer, and as the name suggests, the load balancer has a public-facing IP address that DNS names would have to resolve to for traffic to go through the load balancer. Or you can have an internal load balancer that you might use for a line of business application used by employees. Pictured on the screen, we can see an example of a public load balancer where the name www.quick24x7.com in DNS needs to resolve to the public IP address of the load balancer, not to the back-end servers. And so part of the load balancer configuration includes having back-end server pools. So back-end virtual machines in the end that are hosting a web app, whether you specify individual VMs when you configure the back-end pool in the load balancer, or whether you reference a virtual machine scale set that's already been configured, in the end, the result is the same. So the back-end pool could be individual VMs, an availability set, or a VM scale set. You also then have to configure load balancer rules within the load balancer configuration. The rules control the traffic distribution, such as where we're sending it to the internal backend hosts. It might not always be sent to port 80 or 443 for HTTPS or HTTP respectively, depending on what the nature of the app is. You can also configure settings such as session IP affinity. This one can be important from a client perspective in that if the nature of the app requires a user session to be maintained, then we might want to keep a user connected to the same backend server in the backend pool for the duration of the session. You can also configure with a load balancer inbound NAT rules, NAT standing for Network Address Translation. So this is essentially port forwarding, where you have the load balancer IP address and a front-end configured port that it listens on that allow connectivity to back-end instances. We're talking to allow remote virtual machine management through the load balancer. So there would be a back-end port, for example, port 22 for Linux hosts, and the front-end configured port might be the same or it might be different, depending on how you want the configuration to work. So inbound NAT rules then are used to allow remote management of back-end VMs through the load balancer. Load balancers can improve application performance, and at the same time, they can also provide resiliency against failure of individual back-end VMs. To get started here in the Azure portal, I'm going to go to the All Resources view because I already have a virtual machine scale set ready to be used with the load balancer. So we're just going to check out the virtual machine scale set first. So to do that, I'm going to click Type up at the top. I want to filter everything out except virtual machine scale sets. So I will deselect Select All. It'll scroll down in the list, and I'll choose Virtual Machine Scale Set, and I'll click outside of the list to activate or put that filter into effect. We can see, indeed, we have a virtual machine scale set listed here called VMSS1. So if I click on that virtual machine scale set to open up its properties, we can learn more about it, such as going to the Instances view. So if I open up the Instances blade, I'll see on the right a list of any instances that are up and running and available as part of that VM scale set. We can see here that we have 2 of them. Okay, so having done that, I'm going to click on Home in the upper left of the portal, and then I'm going to click Create a Resource. I want to create a load balancer, so I'm going to search for load, and that should be enough. Immediately, I can select load balancer from the list, and then I'll click Create. So the first thing I'll do is specify the resource group I want the load balancer deployed into. Then I'm going to go down and give it a name. I'm going to call it LB1 for load balancer 1. For the region here, I'm going to put it somewhere near where I am or where the application and its users will be. So in this particular case, I think I'll use Canada Central as the location. Now I can make either a public-facing load balancer, that's the default configuration, or we might define an internal load balancer if we want to load balance an app that's used only internally, such as a line of business app used only by employees within the organization. But here it's going to be a public-facing app, so I'll leave it on public. I'm going to leave the SKU on basic. Now, if this is a very busy workload that we're supporting through the load balancer and we need hundreds and hundreds and hundreds, maybe even thousands of backend instances, then we could choose standard for more scaling options. But in this case, basic will suit it just fine. Public IP address. Well, I'm going to call it LB1 for load balancer 1 pub IP. So that's the public IP address resource that'll be created as a result of this configuration. And a dynamic IP is fine. No IPv6 support is required, so I'll leave that on no, and I'll click Next for tags. I'm not going to tag the load balancer, so I'm just going to go ahead and proceed by clicking Next, Review and Create. After the validation has passed, I'll click Create. But we're not finished, because what we really need to do is go into the properties of the load balancer, and we need to add a backend pool. It's not even linked to any backend VMs that support an app, and then we have to create a health probe and a load balancing rule. So we're going to go ahead and do that once it's ready. After a moment, the deployment is complete, so I'm going to click the Go to Resource button that's presented. That's going to take us into our load balancer, where the first thing we're going to do is concern ourselves with the backend pool. So scrolling down in the left-hand navigator, we already have a front-end IP configuration. We defined this as a public load balancer when we were creating it, and so we can see the IP address resource for that. However, I'm going to click Backend Pools on the left. Now, we haven't defined this yet, and so we need some backend VMs that actually do the work, that serve up an app or an app component. So to do that, I'm going to click Add up at the top to add a backend pool, and I'm going to call this BE Pool 1, Backend Pool 1. Then for the virtual network, I'm going to choose the VNet where I know my virtual machine scale set has been deployed, and it's IP version 4. So for the associated to drop-down list, I can leave it unassociated, tie it to a virtual machine, or in this case, tie it to a virtual machine scale set. When I do that, down below, I'll have to select that scale set from the list. So I'm going to open the list and choose VMSS1. And then for the IP address dropdown, I'll choose the IP configuration for the VM scale set, and I'll click Add. Now, presumably, that VM scale set will have been built with a VM image that contains our app files and any custom configurations that are required. So we now see our backend pool shown in the list. The next thing we're going to do is create a health probe configuration. The load balancer needs to periodically reach out to the backend VMs to make sure they're responsive and healthy. Otherwise, if it doesn't get a response from one that is part of the config, then it won't route any requests to it. So we don't have a health probe yet, so I'll click the Add button up the top. And the first thing I'll have to do is give it a name. So I'll call it HP1 for Health Probe 1, and I'm going to have it use TCP port 80. It's going to talk to port 80 for the backend of VMs. The interval is going to be every 5 seconds, and after 2 consecutive failures, that's the default listed here, that VM will be deemed as unhealthy. So I'm going to go ahead and click OK to create that health probe. Last thing we need to do here is build a load balancing rule so that we could take in or accept traffic destined for the load balancer and have it routed to backend instances, in this case in our backend pool, BE Pool 1. So I'm going to click Add up at the top to add a load balancer rule, and I'm going to call it LB Rule 1. And down below, I'm going to specify the protocol for the front end. It's going to be TCP port 80. Well, what's going to happen in the back end? Are those back-end VMs also listening on port 80? They may or may not be. Let's assume they are. So the back-end port, then, I'm going to leave as port 80. So this is a mapping from the front end of the load balancer to the listening port on the back-end VMs. The back-end pool is associated with this load balancing rule. Our health probe is. We can enable options like session persistence if we need users to be tied to the same back-end host, depending on the nature of the app. I don't need that for this, so I'm just going to go ahead and click OK. to create the load balancing rule. The last thing you would have to consider is configuring DNS records to point to the public IP address of the load balancer. Azure load balancers can be deployed using ARM templates, and there are many ways that you can initiate that process, one of which is actually through the portal. So here in the portal, I'm going to go ahead and click Create a Resource, and what we're going to create is a template deployment for an ARM template. We're going to select a load balancer template. So I'm going to search for template, and I'll choose Template Deployment, and then I'll click on Create. So from the list down below, I'm going to go to the Load a GitHub Quick Start Template section where there's a drop-down list, and I'm going to go ahead and click on it so that it shows me a list of templates available online. I could also go directly to GitHub to get this list of templates and click a button to launch it here in the portal, but I can do it from this direction, which I will continue with. So as I scroll through this, if I start typing in some filtering text, in this case I've typed in the word load because I'm searching for load balancers, I can see that we've got a number of load balancer options. For example, in this case, I'm going to choose 101 Internal Load Balancer Create. So I'm going to select that. Down below, there's a little description. It says it creates a load balancer with an inbound NAT rule. Perfect. I'm going to choose the Select Template button. Now, depending on the template will determine what it is that you need to fill in when you create the resource. In this case, I have to specify the resource group. The location is set in this case to Canada East. I can see the VNet and subnet that it's going to create for this. This template will create that. And the location here for the VNet is going to be set to the resource group location. Perfect. So down below, I'm going to turn on the check mark to agree to the terms and conditions stated above, and then I'm going to click Purchase. Now notice one of the things it did not ask was for the name of the load balancer. Some templates will, some will not. You can edit templates before you deploy resources from them, or you can just run them as is. And after a moment, if we go to our bell notification icon in the upper right of the portal, we'll see that the deployment succeeded. So having done that, let's go to the All Resources view and let's check it out. What I want to do is filter out the list of resources so that we're only looking at load balancers. So I'm going to click on Type, which is currently set to All. I will uncheck Select All, and down in the L's, I'm going to select Load Balancer, and I'll click outside of the list to put that filter into effect. And we can see that we've got a load balancer here. Now, I already have one created called LB1, but we've got one here created called Load Balancer 1. So we can see in the overview blade of the load balancer that it's got a private IP address because this was configured as an internal load balancer as per the ARM template. Also, if we click on the backend pools item in the left-hand navigator, we'll see that it will have configured a backend pool automatically. So I'm going to click on it to open up its details. The template in this particular example is associating the backend pool with the virtual machine. And so virtual machines in the same location as the load balancer that have the same SKU, basic or standard, as the load balancer would be selected. Now, it says there are no virtual machines that meet those conditions. This template doesn't build those VMs. So to complete the config, we would have to build VMs in that location that matches the criteria. Also, if we go to health probes, we'll see that a health probe has been created. If we go to load balancing rules, we'll also see that there's a load balancing rule that's been created. So some templates might create everything for you, whereas others might require a little bit of extra work, as in this case, such as creating VMs that meet the appropriate conditions. One of the things that you need to consider when you deploy an Azure load balancer are the back-end VMs running your application workload. How will you connect to them to manage them remotely? One option is to do that directly through the load balancer. And for that to work, essentially you need to configure port forwarding in the form of an inbound NAT rule. So to get started here in the portal, I'm going to open up an existing load balancer. And in the properties, the navigation bar for it, I'm going to scroll down and select inbound NAT rules. Now, I don't have any currently, but I'm going to add one by clicking the add button up at the top. And the first thing I have to do is give some kind of a name to the inbound NAT rule. So I'm just going to call it NAT Rule 1. it already has my front-end IP address affiliation here. Now remember, essentially we're port forwarding, so we have to make sure we have the appropriate front-end IP address and port number that gets port forwarded to an internal VM on either the same or perhaps a different port number. So the service here says custom, and the protocol is TCP. And down below, I can enter the port number. Now, from the service drop-down list, I can choose common services, and it will populate the port number for me. So, for example, if I chose RDP, it puts in 3389. Now, down below, as we go further, we can then associate this with, for example, a single virtual machine in the back end that we want to allow management to. So maybe I'll select from the target virtual machine list and add an item there. So I've added a VM, and then I can choose the appropriate network IP configuration. Now, presumably, we're going to use the default mapping. However, if I click Custom, we can select the backend listening port. Maybe, for instance, RDP is configured to use another listening port on the backend VM. I'm going to leave it on 3389, but on the front-end port, 3389, I'm going to change that to some other value. Now, why would I do this? Well, because RDP is a common magnet for malicious users. They'll run port scans looking for port 3389. So we just want to add one more layer of difficulty in preventing that from showing up as an RDP port that might be in the interest of malicious users. You don't have to do this. It's just a suggestion. I'm going to do it. So I'm going to go ahead and click OK to add my rule. So at this point, I've created an inbound NAT rule which would allow me to come in through the public IP address and port number that I specified in the inbound NAT rule to connect to the RDP port on the backend VM, so I can remotely manage it. And from there, I could even use that VM as a launching pad, sort of a jump box, to further remotely manage other backend VMs using their private IP address. The Microsoft Azure Application Gateway is a web app load balancer. Now you might wonder, how is that different from a standard Azure load balancer? Well, there are differences, one being that the Application Gateway has the ability to make a routing decision based on the HTTP request. So when a user makes an HTTP request, the App Gateway can examine it, and depending on what's in that request, it can route that request to a specific backend server or pool of servers. So because it's looking at more than just the packet headers, which would include things like IP addresses and port numbers, like the Azure load balancer is limited to, because it can look further, such as into the HTTP request, we say then that the Application Gateway applies to layer 7 of the OSI model, layer 7 being the application layer, whereas a standard Azure load balancer is said to apply to OSI layer 4, the transport layer, because it can deal with things like IP addresses and port numbers. So the App Gateway takes that further. The Azure Application Gateway supports end-to-end SSL TLS encryption. You really should be disabling SSL on client devices and on web server stacks, since it's deprecated and known to have plenty of vulnerabilities. Either way, we're talking about an HTTPS connection from the client all the way to the individual back-end VM that the App Gateway has connected them to. That's end-to-end encryption. Now, as opposed to that, what we might consider enabling is TLS gateway termination at the App Gateway. So from the client device to the gateway, we would have an HTTPS encrypted session, but after it reaches the App Gateway would decrypt that transaction or that message and then send it to back-end servers. The benefit being we are offloading the processing work of decryption from those back-end VMs. App Gateway also supports auto-scaling to scale out, to add additional VM nodes when things get busy, or to remove them, scale in when things quiet down to save on costs. User session affinity is also supported. This means that depending on the nature of the app, a user might need to keep a connection to the same backend server behind the App Gateway for the duration of a session. You can also have up to 100 websites associated with the single Azure Application Gateway instance. Now, another neat part of the Application Gateway, when you create it, is you can opt to use a Web Application Firewall, or WAF, a WAF. So this is part of the App Gateway, and the WAF is based on OWASP rule sets. OWASP stands for Open Web Application Security Project. The purpose of OWASP is to harden web applications. So OWASP rule sets are designed to protect against common web app exploits like cross-site scripting, injection problems, directory traversal attacks, to name just a few. So pictured in the diagram, we can see we've got a client mobile device that's trying to connect to an app by connecting to the name www.quick24x7.com. So that needs to be resolved through DNS to the app gateway public IP address, if it's a public-facing app that we're trying to support. Now, if the HTTP request, let's say, requests something in /media, we see that listed in the bottom left, then the app gateway can send those requests to backend VMs that are configured, for example, to be optimized for uploading media or downloading it, whatever the case might be. Whereas if the client incoming request references /uploads in the URL, we can direct it to a different set of backend hosts. And this is the HTTP URL-based routing option we talked about that distinguishes Application Gateway from Azure Load Balancer. The Azure Application Gateway is an OSI Layer 7 type of load balancing solution. Now, the reason I say OSI Layer 7 is instead of just looking at what normal load balancers would look at, Layer 4 load balancers, where they look at packet headers and look at IP addresses and port numbers, beyond that, the Application Gateway has the ability to actually look at things like HTTP URLs in requests and make routing decisions to backend pools based on that. So to get started here in the portal to create an Application Gateway, I'm going to start by clicking Create a Resource. And I'm going to search, of course, for Application Gateway. And then I'm going to go ahead and select that item from the list, and I'll choose Create. So I'll specify the resource group I want the Application Gateway deployed into, and I'm going to give it a name. I'm going to call it AppGW1 for App Gateway 1. Now, if I don't have a unique name, it will tell me, and I'll have to give it some other name that is unique, while adhering to organizational naming standards, of course. So from the region drop-down list, in this particular case, I'm going to deploy this, let's see, into Canada Central. Now the tier here, I'm going to leave as standard v2, although depending on what you want to do, such as if you want to use a web application firewall or a WAF, then you could select that tier, depending on what your needs are. In this case, I'm just going to leave it on standard v2. I'm going to leave it on enable auto-scaling yes. We'll start with 0 scale units. Now, don't worry about that, because if you look at the helper icon for minimum scale units, it says 0 signifies purely auto-scaling. Okay, that's what we want. So I'm going to leave the minimum and maximum scale units as they are. And down below, I have to put this into a virtual network. Well, let's say I were to choose, I'll choose a VM scale set, VMSS VNet that I've created, because ultimately the backend pool for this Application Gateway is going to be a virtual machine scale set. Now, if I choose that virtual network, I then have to select a subnet within it. Now, it automatically selected subnet 1, but there's an error message below. It says subnet must only have Application Gateway. In other words, you need a dedicated subnet for this. Aha. So that's why I'm going to select subnet 2 within that same VNet. And there's no error message now because I don't have anything deployed in it. It's solely to be used by the App Gateway. Perfect. I'm going to click the Next Front Ends button at the bottom. Now, the front ends here are similar to what you would deal with a standard Azure Load Balancer. So do we want a public-facing Application Gateway to load balance an app, or private-facing, or both? I'm going to leave it on public. And I can either choose an existing public IP address that's not been consumed. Now, all of the ones that I have in this list are already being consumed, so I'm going to have to create a new one. I'm going to click Add New. I'm going to call it App GW1YHC Pub IP. So it likes the name. Notice it's going to be standard for SKU, and the assignment is going to be a static IP address. And I can't change those things. That's okay. I'm going to click the OK button then to confirm that, and I'll click the Next Back Ends button down at the bottom. So for the backend pool, I'm going to click Add a Backend Pool. And in this case, I already have a virtual machine scale set ready for this. So I'm going to call this BE Pool 1. And for the target type, it could be an IP address or a fully qualified domain name. specific virtual machine, app services, or a VMSS, a virtual machine scale set, which is what I want to use here, because I already have one. And then from the target list, I'll choose the name of my virtual machine scale set, and then I'll click Add. So we've got the front end taken care of for the app gateway as well as the back end pool. So I'm going to click Next Configuration down at the bottom. So we might have the front end taken care of in the back end, but remember, App Gateway allows us to use routing rules to make routing decisions on where certain types of traffic should go to back-end VMs. So I'm going to click the Add a Routing Rule link in the center of the screen. The rule will be called Routing Rule 1. The listener, I'm going to create a listener for this, it's going to be called Listener 1. And the front-end IP I'll select from the drop-down list here is public. It's the only one we have. And I can select either HTTP or HTTPS. So presumably we'd be using HTTPS, which normally uses port 443. So I'll leave that port number in there. Now, if I'm going to use HTTPS, I either have to upload a PKI certificate or choose one from a vault if I have a key vault. Well, in this case, I'm going to go back to HTTP because I don't have a vault or a certificate, but it's just as easy to enable that if we need to. The listener type is set to basic, error page URL is set to no. Well, if I go to back-end targets up at the top, I can select the back-end pool, and then I have to either create or select HTTP settings. I don't have any, so I'm going to have to click Add New for HTTP settings. Just scroll back up here. I'm going to call this HTTP Settings 1. It's for HTTP. And then I have to specify the backend port number. Well, let's assume that the backend servers in the backend pool are listening on port 80 because we've elected to use HTTP. So then I have other options. Do we want to use cookie-based affinity settings? That option will be a consideration if the nature of your app and the connecting client are such that the client needs to be connected to the same backend server in the pool for the duration of a session. If we enable connection draining, then what we're really specifying is that what we want to start doing is removing backend VM instances, say for updates, and making sure that the app gateway knows that they are essentially out of service so that requests don't get routed to them. We can also specify the drain timeout in seconds, the default of which is 60. So I'm not going to change that. I'm actually going to go back to disable that option. And that's pretty much it. So I'm going to go ahead and click Add to add these new HTTP settings. Now that we've got that, we need a path-based rule for path-based routing. So I'm going to click on the link down at the bottom that says Add multiple targets to create a path-based rule. So this is going to go to a backend pool as opposed to being redirected elsewhere. So let's say I want to take the path of /vids/*. So that's what I am looking for in the HTTP URL. And maybe the target name I'll specify here is target 1. I have to create a name for this. And for HTTP settings, I'll choose from the drop-down list what we've just created. And for the backend target, again, I'll choose backend pool 1. So I'm going to go ahead and click Add. And then I'll click Add once again. So we could add multiple routing rules so that based on certain strings in the URL, we could send that traffic to specific backend pools that are designed to handle, for example, uploads or videos or anything like that. So now that we've got the front end, the back end, and the routing rule configured, I'm going to continue by clicking Next Tags at the bottom. I'm not going to add any tags to this app gateway config, so I'll just click Next, Review, and Create. It's going to run a final validation, which is now passed. So I'm going to go ahead and create this app gateway by clicking Create. The Azure Traffic Manager service allows you to distribute application traffic across different regions. So for example, you could have web applications in different geographical locations and load balance it based on a number of different criteria, which we'll examine in a moment. So let's start here in the portal by taking a look at some existing app services or web apps that have already deployed and are up and running. So notice we have two of them. One's called East App 1. It's in the East US region. And the second is called West App 1, and it's in the West US region. Let's just click on the East App 1 web application. Let's just test that it's working and take a look at the homepage. I've customized the homepage. So if I click on the URL here in the overview page on the right, we can see when it opens up, it says East Web App. Okay, that makes sense. And if we were to do the same type of thing, if we were to navigate to West App 1, go to the overview blade, and on the right, we want to click the URL because we want to test that web page too. So if I click on it, notice it says West Web App. Now the idea is that we're going to configure the traffic manager with what's called a performance routing type. So the idea is that if we've got people that are in the East region, they're going to be connecting to the East version of that app. So in other words, it should pop up the East Web App page. If people are in the West region and that's closer to them, then they'll be pulling up the West version of that app. West Web App is what the page says. Now, realistically, the web app should be exactly the same in both locations. But in this case, we can easily identify which one we're connecting to. So how do we make this happen? With a traffic manager profile. So if I go back to the portal, I'm just going to go home here, click home, and I'll click create a resource. And I'm just going to go ahead and search for traffic, and I'm going to choose traffic manager profile. That's what we're building here. So I'm going to click create. I'm going to call this TM172, TM for traffic manager. And notice it's going to append the default .trafficmanager.net DNS suffix. You can use your own custom names if you want to configure CNAME alias records in DNS. But we're just going to stick with this for our test. Then we've got the routing method, which is set to performance here by default. And what this one means, as in our case, we've got a web app in East, we've got a web app in West. So people that are in the Eastern region coming in from that location geographically will be pointed to the East app. Likewise for the West app. However, you can also choose weighted. Now, weighted means that we assign a priority value to each endpoint, and based on that value determines how the traffic is distributed to them. So let's say we've got East and West, and we assign them both a priority weight value of 1. Well, then they each get an equal amount of traffic. Or if you want one to have twice as much traffic, double the weight value. We could also use priority. Now, when you use priority, what you're really doing is you're setting one of your endpoints as the primary connection for the app, and if it's unavailable, then the other ones would be used as backups. Then you've got geographic. Now, that might sound a lot like performance, but it's different because what it's doing is it's looking at where the DNS query originates from, not where the IP address of the original client device is, but rather where the DNS query came from. Because you can sometimes have configurations whereby you might be in the South, but when you issue a DNS query, it might go through headquarters, which is in the East. So that would be seen as originating from the East region and not South. We've got multi-value. This one is used when you have backend endpoints that are using IPv4 and IPv6 addresses. And then finally, you have subnet as the last routing method. What this does is let you look at the end user connecting IP address range and then map that to a backend endpoint. So in this case, I'm going to leave it on performance and I'm going to deploy it into an existing resource group. And I'm just going to go ahead and click create. So we're creating the traffic manager profile. But once that's done, we have to add the endpoints to it. Okay, so after a moment, in our notification bell icon in the upper right, we can see the deployment succeeded. So I'm just going to click Go to Resource to open up our Traffic Manager profile. I'm interested in going down to endpoints. When I go down to endpoints, this is where I'm going to add the 2 web app endpoints. So I'm going to click the Add button. And for the type, it can be an Azure-based endpoint, which ours will be because it's an Azure app service, or it might be outside of Azure, so an external endpoint. Or it could be a nested endpoint where you can actually combine routing methods for the benefits of multiple routing method types. However, in this case, I'm going to choose Azure endpoint. I'm going to call this East, and the target resource type will be an app service. I'll click on the target resource, and it's going to be East App 1, and no custom header information. That's it. I'm just going to click OK, and I'm going to click Add, and I'm going to do the same thing for the West app. So the type is Azure endpoint. The name, let's say, is West. Target resource type app service, and I've already got that West App 1 set up. No custom header, and I'm going to click OK. So we're just going to give it a moment here. I'm going to click refresh. So they're both showing up, but the monitoring status is checking endpoint. So it's going to be checking that it can make a connection to them, a valid connection. So I'm going to click refresh until such point that the monitoring status shows that they are both online. So we can now see that both of our app service endpoints have a monitoring status of online. Now, if we go to the configuration blade, we'll see here that besides being able to change the routing method, but we're going to leave it on performance, down below, we can see how it's monitoring those endpoints. It's using HTTP, it's trying to hit port 80, and it's going to the root of the path to make sure that those hosts are online and healthy. Probing interval is every 30 seconds. It'll tolerate a maximum of 3 failures after 10-second timeouts. So 3 consecutive 10-second timeouts. So at this point, what we're going to do is go to the overview blade. Here we're going to see the default name. It's using the .trafficmanager.net DNS suffix, and it's called TM172. So I'm going to go ahead and copy that full DNS name. Now, of course, you could go to your external DNS registrar if you have a different domain name that you want to use and create a CNAME or an alias record that points to this. But in our example, I'm just going to test it using the DNS name provided here. So we can see that if we go to the tm172.trafficmanager.net URL and we're closest to the East region, it'll pull up the East web app page. Now, we could either test this by deploying a virtual machine in the West region and attempting to connect to that same URL, but what I'm going to do here is scroll down to my endpoints back here in the Traffic Manager profile, and I'm going to click on East to open it up, and I'm going to temporarily disable it. So under Status, I'll click Disabled, and I'll click Save. So what should happen is because it's not there, the West endpoint will be used. So I've opened up a different web browser here because you want to make sure you're not viewing cached information in the web browser. So you could clear the cache and restart it and try the URL. I've just tried a different web browser here. It's the same URL up at the top, but it's now pulling up the West web app page. A web application firewall is a specialized type of firewall that's designed, as the name implies, to protect a web app from common HTTP-based exploits. Now, we can work with the web application firewall through the application gateway in Azure. Let's take a look at that. So here in the Azure portal, I'm going to start by going to the All Resources view. And our goal here is going to be to take a look at an existing application gateway resource. So to do that, I'm going to filter the type, which is currently set to all. I'm going to deselect, select all, and I'm going to select application gateway, and I'll click outside of it to put that filter into effect. Here's our application gateway. It's called www.sqad. I'm going to click to open up the properties of the application gateway, and I'm going to click Configuration in the navigation bar. Now, the idea is that when you deploy an application gateway, you can select the tier upon initial deployment. You can change it after too, as we're going to see here. See, the tier here is selected as WAF v2, Web Application Firewall v2. The default is standard. So whether it's been done during deployment or after the fact, either way, it needs to be set to a Web Application Firewall tier to work with the Web Application Firewall. So luckily here, it's already been set that way in the application gateway. So what we can do then is click the Web Application Firewall item here in the navigation panel to open up the settings related to that. So we can see under the Configure tab at the top that the tier is set to WAF v2. The firewall status is enabled. So of course it can be disabled if you want to do that. The firewall mode defaults here to detection. So the detection of HTTP exploits and then the logging of those, but you can also enable prevention mode. What this will do is when it detects that there's an intrusion, it will actually block that attempt. Now this is based on what the rules are configured to look for. We'll look at rules in a moment. And what the user would get on their end is a 403 unauthorized access error message. So having done that, down below, we can specify a field that we want to look in for exclusions. We can look in the request header name, request cookie name, or the request attribute name. And when we select any of those, we can select the appropriate operator. So it starts with, ends with, equals a certain value, contains, and so on. However, I'll click the little trash can to the right. I don't want to add any of those exclusions. It's set down below to inspect the request body, so more than just the packet headers, which is important. So that's important. Now, if we scroll back up at the top, we can go under the Rules tab to see what rules we were referring to are taking effect. From the Rule Set drop-down list, we've got OWASP 3.0 selected. OWASP is the Open Web Application Security Project, and OWASP is an international consortium of experts that have compiled the most common web app exploits and how to mitigate against them. And that's part of what the OWASP rule set is about. So we're using the most recent version of that if we select OWASP 3.1, which I'm going to select here. Now, if we want to turn off some rules yet leave some of them on, we could choose enabled for advanced rule configuration, and the rules then show up down below. They're all selected, and we could see that it's looking for different types of attacks like XSS, cross-site scripting attacks. I could even expand that a little bit further to get some details or deselect it if I didn't want to protect against that. However, I do want those settings, so I'm just going to go ahead and click on Save. We've updated the OWASP rule set. Now I'm going to go back home here in the portal, because the other way you can approach the web application firewall instead of jumping directly into the application gateway is you can make it its own separate configuration and associate it with the application gateway. What I mean by that is I'm going to create a resource here in the portal, but I'm not going to search for application gateway because we've already got one. So what I'm going to look for is web app, and I'm looking for web application firewall, WAF. And then I'll choose Create. So the Policy 4 drop-down list will let me determine if I want this to be associated with Azure Front Door Service, so Global WAF, or Application Gateways as a Regional WAF, or Azure Content Delivery Network. I'm going to choose Regional WAF, Application Gateway, and I'm going to make sure I specify Resource Group 1, RG1. And I have to give this policy name. I'm going to call it Policy 1. I'll select the appropriate location where I know the application gateway is deployed, which in my case happens to be Canada Central. And I'm going to click Next for Policy Settings. Now, a lot of what we're going to see here is what we just saw by going directly into the application gateway. So you don't have to do both of these. You can do either one. So the mode here, it can be set to prevention or detection, as we know. We can also have exclusions that match content within a request header or a cookie or arguments in the request, HTTP request. Now that's fine. I'm not going to change any of that. I'll click Next for Managed Rules. Here's where we can determine the rule set. So OWASP 3.0 is selected. Probably better off selecting the newest OWASP rule set, so OWASP 3.1. I can also click Next for Custom Rules if I want to add custom rules. And when I click Next for Association, this is where I link this WAF policy to an existing application gateway. I click Associate an Application Gateway, and then I simply select it from the list. Now, there's only one in that region, so it's automatically selected. Great. I just click Add. I can also associate a listener, because you could have multiple listeners within your application gateway. So when I click Associate Listeners, it'll allow me to choose the listener, in this case, Listener 1, that's been configured within the application gateway previously. So I'm going to select Listener 1, going to click Add, and I'll click Next Tags. I'm not going to add any tagging information here to this WAF policy, so I'll click Next, Review, and Create. And it's running the validation for it. I'm just going to go ahead and click Create. And after a moment, we can see our WAF policy deployment is complete, so I'm going to click Go to Resource. We can see here, Policy 1 is showing up here, and we're in the properties of it. So I can click Policy Settings in the left-hand navigator, and here I'll see the settings we specified upon creation of this policy. I see Managed Rules, Custom Rules. I can even click on the left and see the associated application gateways with this specific policy. Note that the great thing about doing it this way by creating a separate policy and associating it with an app gateway is that you can associate multiple app gateways given that they have the same policy requirements. You could describe Azure Front Door as being a service that's used for global HTTP load balancing, as well as some security options, some firewalling. Now, you have to remember that there are other Azure solutions that sound similar to this. What comes to mind immediately is the Azure Traffic Manager. One of the differences is that Traffic Manager has the ability to route HTTP traffic, HTTPS, TCP, UDP, and so on. Whereas with Front Door, it's designed specifically for HTTP and HTTPS. It's also designed as an accelerator. And what this means is that it will determine the nearest point of presence, the nearest Microsoft point of presence for Azure to make a connection to a back-end web application pool. So it's designed for web applications specifically. The other thing to bear in mind is that Azure Front Door also, because it's designed for HTTP-based applications, supports TLS protocol termination, which means that instead of the backend VMs having to deal with TLS for decryption, for example, we can remove that from them, thus giving them more compute power to focus on the workload itself, and that can be handled by Azure Front Door. It's also considered application layer similar to the Azure Application Gateway in that it can take a look at the HTTP request and it can actually route different types of requests based on URL paths to a different backend. So to get started then with the Azure Front Door service, I'm going to click Create a Resource here in the portal. I'm going to search for Front, and I'm going to choose Front Door, and then I'm going to choose Create. Okay, so I'm going to go ahead and specify a resource group to deploy the Front Door service into, and I'll click Next for configuration. So what we need to do is we need to have the front-end domain configuration done. We need to have a back-end pool or pools. In this case, we're going to have only one, and it's going to contain 2 web applications I've already deployed in Azure, or app services. And then we also need routing rules. The routing rules are used to send traffic from the front-end host to the back-end pool. So we need to have that. Let's get started here. So for front-end/domains, I'm going to click the plus sign. So for the host name, I'm going to use FE172, and it's going to add the .azurefd for front door .net DNS suffix to the end of it. Of course, we can customize this just through some DNS work, such as using CNAME or alias record configurations. I'm going to leave session affinity disabled and the web application firewall disabled. I'm going to click Add. So we've now taken care of the front end domain. So now we have to go into step 2, the backend pools, where I'll click the plus sign for that. And I'll click Add a backend pool. I'm going to name this BE Pool 1, Backend Pool 1, and I'm going to click Add a Backend in the middle. For the host type, I'm going to choose App Service, and it automatically selected a backend host name for an application, eastapp1.azurewebsites.net. That's one of my web apps. And it's on port 80 and HTTPS port 443. That's all standard, and that's great. I'm not going to change the priority or weight values here. You only worry about the priority when you want your traffic to go to one copy of the application, so maybe this app service, and if it's not available, then you'll have other lower priority numbers, so higher numeric values, that the traffic would then be sent to if this one's not there. Then you can have a weight value if you want to control the distribution of traffic across your multiple backends. I don't want to do that. I'm just going to leave the defaults, and I'm going to click Add. And I'm going to click Add a backend again. That's only one backend app service. So I'm going to add another one. It's going to be an app service. By the way, notice from the list, it could be the older legacy cloud service. It could be storage. It could be an application gateway, API management, public IP address, even as your traffic manager. But I'm going to leave this on app service. And for this one, I'm going to choose my second app service I've previously created here called WestApp1. And I'm going to leave the port numbers and the priority and the weight values and all that stuff to the default settings. So I'm going to go ahead and click Add. So I've got 2 backends added. Now the next thing we can do, of course, is go down and configure the health probes. So how often, the default is a 30-second interval, it's going to make a connection. So the path here on those hosts, it can be HTTP or HTTPS, whichever you choose. Down below, the latency sensitivity field under load balancing is set to 0. We're going to leave it that way. We want requests to always be sent to the fastest responding backend component, or app service in this case. So I'm going to go ahead and click Add to add the backend pool. So that's done. Step 3 is to add a routing rule. And remember, the routing rule is used to define how the traffic gets from the front end to the back end pool. So I'm going to go ahead and click Add to add a routing rule. I'm going to call this Rule 1, and it's going to be for HTTP and HTTPS, but you could choose one or the other if you wanted to. And remember, this is one of the ways that the Azure Front Door service differs from Azure Traffic Manager, because Front Door service is specifically for HTTP or HTTPS. That's it. Whereas Traffic Manager can be for basically anything that gets sent over TCP or UDP. So I'm going to leave it on HTTP and HTTPS. I can see I'm associating the front end domain here, and down below I'm not matching any paths or anything like that. And then down below, we are forwarding to backend pool 1. And we can select whether that happens over HTTPS or HTTP only, or it can match the initial request. I'm going to choose HTTP as I don't have HTTPS enabled. And then I'm going to click Add. So I've done the 3 required configuration tasks: the front-end domain, the back-end pool, and the routing rule. So I'm going to click the Next Tags button down at the bottom. I'm not going to add any tag value pairs. I'll click Next, Review, and Create. It's running a final validation, which is passed. Excellent. So let's deploy our front door by clicking the Create button in the bottom left. And after a moment, the deployment is complete. So I'm going to click Go to Resource to open up our front door configuration. Now, we didn't enable the web application firewall, but remember that front door, besides being used as a global web application load balancer, also has firewall components enabled that we could go through. So to do that, I would have to select the front end and then click Apply Policy. And I have to have already created a web application firewall or a WAF policy. That's just another resource you could create in Azure and then associate it here. However, I'm not going to do that. And if I go to the front door designer over on the left, we'll see our initial configuration. And we could make changes if we felt we needed to the front end domain, the back end pools, and the routing rules. So now I'm going to go to the overview blade where I'll see the default DNS name, the default URL for the front end host. So that's over in the overview blade on the far right at the top. So I'm going to go ahead and copy that, or I could just click on it and we can launch it to see what we get. What it's doing is it's connecting literally to the East web application because I am physically or geographically in the Eastern region. If I were to come into that URL from an area elsewhere, such as the West, then it would open up the West web app page. Let me explain that just a little bit. Back here in the portal, if I go home and if I look at my app services, the 2 back-end app services that our front door service is using are East App 1 and West App 1. And if I click on East App 1, and if we take a look in its overview blade at the default URL, and if we click on it, I've customized the web page to say East Web App. And if we test that also back here in the portal for West, our West App 1, same thing. We're going to go to the overview blade, and on the right, I'm going to click on the URL for that app. I've customized the page for that too, and it says West Web App. Realistically, they should be the same thing, but just for testing purposes, this is how I could check when I connected to the URL for my front door service, as opposed to the URL for the app, it redirected me to the East Web App because that's the region I'm in and it's the closest one. So in this course, we've examined a number of tools and services available in Azure for managing and improving web app performance, availability, and security. We did this by exploring the role of Azure load balancers and their implementation. We looked at how to deploy a load balancer using the portal, as well as using an ARM template. We looked at how to use inbound NAT rules to enable inbound backend server management. We then looked at the difference between Azure Application Gateway and the Azure Load Balancer, as well as how to use the portal to deploy Azure Application Gateway. Finally, we looked at how to configure Azure Traffic Manager, Azure Web Application Firewall, and Azure Front Door. In our next course, we'll move on to explore how to automate administration tasks using Azure automation tools such as ARM templates and Azure Automation Runbooks. Azure Resource Manager, or ARM templates, are one way to enable automation within the Microsoft Azure cloud. ARM templates use JSON syntax, so really it's just a text file that uses a specific type of syntax within it. We can use ARM templates to deploy new Azure resources, but you can also use ARM templates to manage the configuration of existing Azure resources. Now, when we say Azure resources, what are we really talking about? We're talking about pretty much anything you can deploy in the Azure ecosystem, whether it's a web application. Now, when you think about a web app, it might consist of multiple resources, such as a virtual machine, which also has a network interface and perhaps a network security group and perhaps a public IP address. Also, a web app might contain a backend database. You might have a backend database deployment. You might have a load balancer sitting between users and the application. So there are plenty of resources that might be involved with a web app. And you could build a template to deploy all of those related resources in an automated fashion. You could also use templates to deploy or manage databases, storage accounts, virtual machines, and so on. Now, normally, when you have a single application like a web application, you would deploy those resources into one resource group. The resource group being a way to group related items together, hence resource group as being what it's called. And that means that if we were to manage something for the resource group, such as delete the resource group, let's say, it would delete all of the resources within that resource group. Now, an ARM template uses JSON syntax, but an ARM template can also accept parameters. You don't have to hardwire values for things like storage account or VM names. Instead, you could parameterize your template so you could reuse them over and over using different names for VMs or storage accounts or whatever the case might be. So in this case, we've got a parameter for virtual machine name, and we're setting a default value here to my VM where the data type is string. That's just the default value. Of course, it can be changed to something else. Moving on, in the template, we can also specify a location like Canada East. We can specify properties for the specific type of object being created or managed. In this case, for a VM, we might specify the hardware profile details such as the VM size, which is the underlying compute horsepower. So that's kind of what it would look like within an ARM template. Notice we're using open and close curly braces and things are in quotes, and there are colons between things like a default value and the actual value itself. Now, the next thing is creating items in the portal. In this example, we have a screenshot of a user that's creating a virtual machine in the portal. It doesn't have to be a VM, though. The point is that you always have an option in the portal when you're deploying a resource at the end to download a template for automation. So you're downloading an ARM template that uses JSON syntax that you could then tweak to suit your needs if you wanted to deploy additional resources or manage them. In the next screenshot, we see in the portal a template deployment has been created. When you create a template deployment in the portal, this is what you're going to see. So at the top, you could build your own template in the GUI editor. You have to know the syntax, though. Of course, you could import a file as well, if you already have one. Then there are some common quick start templates to create things like Linux and Windows VMs, or a web app or a SQL database. And notice at the bottom, you can also query GitHub out on the internet for a quick start template that you want to use to make a deployment here in Azure. Now, you can also deploy ARM templates using the CLI. Here we can see we are creating a group called Resource Group 1 or RG1 in a location of Canada Central. And the next thing we're doing is we're using AZ Group Deployment Create. We're creating an ARM template deployment called Deployment 1 into Resource Group RG1, and we're specifying the template file, which in this example is simply called vmtemplate.json. You can also specify the full path of the location of that file. We're also specifying a parameter here using -- parameters. In this case, we're supplying a value of VM1. So if the template is written to accept parameter value for the name, then we can go ahead and specify this on the command line when we deploy that template. We can also use PowerShell to deploy an ARM template. So in this example, the first line, we've got a variable we're creating called $RG, which is simply going to store the text string RG1. The $location variable will store the text string Canada space East. We're using new -AZ resource group to build the resource group using -name and then passing the $RG variable. We're using -location and then specifying the $location variable. So that creates the resource group. You might already have a resource group, so you might not have to do those steps if you're deploying an ARM template using PowerShell. Next thing we're doing in PowerShell is running the new -AZ resource group deployment commandlet to actually deploy the ARM template. So we specify -resource group name, specify the resource group we want to deploy into, -template file, where we can specify the path and name of our template file. So there are many ways to take advantage of using ARM templates for automation in Microsoft Azure. Using the Azure portal, you have the option of downloading a template for an existing resource. Now, you can do that while you're in the midst of creating a new resource or for an existing one. Let's take a look at both options. So here in the portal, let's say I was going to deploy a virtual machine. So I'll click the Create a Resource option here in the portal, and I'll just choose any of the most popular virtual machines, such as Windows Server 2016 Data Center. It doesn't really matter what I select because I'm not going to actually create it. However, I want to go through the motions. Now, once you are creating or deploying a resource using the portal, once you get to the end of the wizard is when you'll see the option to save that as a template. So right away, if I go to Review and Create, if I click on that link at the top, I'll see I have an option in the bottom right to download a template for automation. Of course, because I didn't fill in anything on the other previous tabs, we can see they're shown here at the top with the red circle, and the validation has failed because required information is missing or not valid. It's only because I didn't fill out everything, and I don't want to. I just wanted to jump to the end where you could download an ARM template for automation. But you can also, as we said, do that for existing resources. So why don't we just, for the fun of it, go back home here in the portal and open up our virtual machines view. Doesn't have to be a virtual machine, could be anything. I'm just choosing that to be consistent with the first part of our discussion. And so I'm going to open up an existing virtual machine by clicking on it. Now in the navigation bar, what we want to do is scroll all the way down. And that would be down under Settings. At the bottom of the Settings section, you'll see that there is an Export Template option. So if I click that on the left, then on the right, we can actually see the JSON syntax here that was used to deploy this specific Azure resource. So we can scroll through and read it and maybe even download it and make changes. Now, notice that you'll be able to click the download button to download this JSON file, and then you can use it in any way you see fit, such as tweaking values within it and using it perhaps to deploy additional virtual machines. Notice that we are looking at the template, and in the left-hand area under template, we can expand parameters to see if any defined parameters are within this template. And there are. There's one for the virtual machine name, and if I select that, it takes me to that section within the JSON file listed on the right. I can see it's got a parameter for the OS disk. Again, if I click it, it shows me that line on the right. Same with the network interface. If I click on the parameters tab up at the top, I can actually see the parameters that might be filled in. Although notice, in this case, the values are all null, which means we're going to be prompted for them. Also, we can see that we've got scripts up here. It says you can use PowerShell or CLI to manage your templates. In other words, to create a template deployment. So we then have links where we could view more about that. So for instance, under the Azure CLI, if I were to click the Start link, it would open up another web browser window with documentation to help me learn about using Azure Resource Manager templates through the CLI. An important part of working with ARM templates in Azure is understanding how to make required changes to a template. There are plenty of sources where you can get templates, but often you might have to tweak them or make some changes. And so it's important to have that skill. So here in the Azure portal, I'm going to start by clicking Create a Resource, and I'm going to search for template, and I'm going to choose Template Deployment and then Create. That's going to take me into the custom deployment screen. Now I've got some common templates I can select down below, or I could go to GitHub. And after I load one of those up, for example, if I were to choose Create a Linux Virtual Machine, it's going to take me where I fill in the blanks, so the details as required by that template, but I can also edit the template up at the top. And then it takes that template, loads it into the editor, along with its variables, which I can expand and see in the left-hand navigator, and I can work with it and make changes, and then I could even download it. I could save it, or I could just save the change here in the portal and deploy the resources based on my changes. However, I'm going to click Discard, and I'm going to go back to the new template deployment screen up at the top by clicking the breadcrumb trail link. Now it says your unsaved edits will be discarded. That's fine. I'll click OK. And I'll go back and click Create. So back to where we started. So we could select one of these common templates or GitHub and edit it. But I'm just going to start right away by clicking Build Your Own Template in the editor. Now here we have the basic skeletal JSON structure for working with a template. We've got the open and close curly braces, We've got the schema definition for working with this, the content version, and we've even got parameters and resources listed here. Now, what you could do is you could click Add a Resource in the upper left, and when you do that, you have a drop-down list of Azure resources that you can add to your JSON syntax in your template. So, for example, I could choose SQL Server, give it a name, let's call it My Server 1, click OK, and it will have now added that over here on the right. So we can see that we've got a parameter called My Server 1 admin login string minimum length of 1. It did that for us. And we could scroll down here. We can see under resources now, it's added the type for Microsoft.SQL/servers. The display name is My Server 1 and so on. So we can work with that from here. However, what I'm going to do is I'm going to click discard to discard that, go back to build your own template in the editor, because what I can also do is upload a file. I can choose load file if I already have a JSON file. And I can also bring in a quick start template, which is what I'm going to do. So then from the drop-down list, I can choose anything I want. So maybe I'll search for Bastion. What I want to do is select the template for 101 Azure Bastion. A Bastion host in this context is used in Azure for management as a jump box. So it's got a public-facing IP and private, and after connecting through Bastion, I can connect to VMs that only have a private IP address, so we don't expose them to the internet. So I'm going to go ahead and select that and click OK. Let's say that's what I want to deploy. So it loads the JSON text into the editor as expected, and I can scroll through and take a look at it. So what do we have here? About 127 lines, or exactly 127 lines. Over on the left, I can expand parameters, and I see that there are a number of parameters in this quick start template. I can also expand variables. There are a couple of variables, and I can see the resources it's working with. So here we can make changes. So for example, it wants to create a VNet name with the default value of that is VNet1. I'm going to call it VNet-Bastion. So I'm making changes to this template. Okay, and it's got the IP address prefix down here, which is fine. So as we go further down here, it's also going to create a subnet, and it's got the prefix for that, the subnet prefix as required for that. It needs to be a 27-bit one to use Azure Bastion. And that's fine. As we go further down, we can also look at the details for the name of the Bastion host. We can also see the location for it. It's going to pick up the resource group, .location property for that. So we could make changes as required. All I've done here really is changed the VNet name. So having done that, what we can then do is save the change directly here, but we can also download this as a file. We can save this as an on-prem file, or we could load it into a storage account, whatever we want to do with it. In this particular case, what I want to do is I'm going to click save that change. And now we're presented with anything that needs to be filled in based on the parameter values that weren't hardwired into the template. So the resource group, so maybe I'll just choose RG1. We can see the VNet name was picked up from the change we made in that template. I could change it here again. The only thing I'm going to specify here is the Bastion host name. I'll call it Bastion 172, and I'm going to click purchase. So down below, I have to first scroll down and choose I agree to the terms and conditions, then I'll click purchase. So we're now deploying a resource that we brought in from a quick start template in the editor in the portal, made a change to and saved, and now we're going to end up with our Bastion configuration. You can deploy ARM templates using the Azure portal. Here in the portal, I'm going to start by clicking Create a Resource. What I want to search for here is Template, and I'm going to choose Template Deployment. Then I'll click on Create. Now this is the screen you get when you choose to create a new template deployment. So you could build your own template within the editor. To do that, you either need an existing file to import, or you have to understand the internal JSON syntax for templates. There are common templates where you can create a Linux VM, a Windows VM, a web application, a SQL database, or you could also, down below, go through and start filtering the list of templates available online from the GitHub website. I've opened up another web browser window where I've navigated to azure.microsoft.com/en-us/resources/templates. So there are collections or libraries of ARM templates available out there on the web from a variety of sources, including Microsoft. So from here, if I scroll down, I can see some examples of the most popular templates to deploy. For example, simple Ubuntu Linux VM, or a template that joins an existing Windows VM to an Active Directory domain. And as we scroll through, we'll see many variations of what the template offerings are. I could also search. So for example, let's say I want to deploy a LAMP stack for a Linux-based web application. Well, when I search for LAMP, I then have some templates that match my filter, such as deploying a LAMP app. So let's say we wanted to deploy that. So I could click directly on the link to do that, and I could actually choose deploying to Azure. Now, what that's going to do is take me to my Azure installation. I might be prompted to authenticate. So I'm directly in my Azure environment. We can see that. It's evidenced by the username and the Azure AD tenant shown in the upper right. It's waiting for me to fill in the blanks. Now, based on the parameters that are in the template will determine what you see here in terms of what you need to specify. Some ARM templates might be hardwired with everything. You don't have to specify anything, so there's almost nothing to do here. But in this case, we can see that this ARM template requires us to specify things like a resource group, the location, storage account name prefix, an admin username, password, and so on and so forth. Now, once we do specify these items, we would then choose I agree to the terms and conditions stated above, and we would click Purchase. At that point, it would deploy the resource or resources as specified within the ARM template. You can use the Azure CLI to deploy ARM templates. Not every ARM template is used to create new Azure resources. In our example, we're simply going to be making a config change to an existing resource, specifically a resource group. We're going to enable read-only locking for everything in a particular resource group. ARM templates use JSON syntax. So we can see we have at the very top here of a sample template, we have an opening curly brace, and at the very bottom, we've got the matching closing brace. Now, towards the top of the template, we have the schema declaration and the content version. This is a very simple template, so there are no parameters for reusability. There are no variables. And in the resources section, the provider type we're looking at here is Microsoft.authorization/locks. And I'm going to create a lock with the name of RG1 lock, and it will be done with the following properties. It's going to be set to read only, that's the type of lock. And for notes, we can have it say here whatever we want. How about lock RG1? And there are no outputs. So it's a very basic ARM template. So let's deploy this or apply it now using CLI syntax. To do that, here in the portal, I've launched Cloud Shell, and I'm going to run AZ deployment group create -- resource - group. I want this applied to a resource group called RG1 that already exists in Azure. Then I'm going to use the -- template - because I've uploaded that file using the upload and download button here into the portal, into the shell, more specifically Cloud Shell. And then I'm going to give it the name of that file that we were just looking at. It's got a JSON file extension. So I'm going to go ahead and press Enter to apply the lock. We can see after a moment the provisioning state is showing as succeeded. So let's just minimize the Cloud Shell here. And in the portal in the background, in the left-hand side, I'm going to open the navigator and I'm going to choose resource groups. Let's go check out RG1. We should see that there's a lock with the settings specified from our ARM template. So I'm going to go ahead and click on RG1 to open it up. And when it pops up, I'm interested in looking at the locks for it. So I'm going to click Locks in the navigator. And sure enough, over on the right, I can see RG1 lock. That's the name of it. It's read only. And I can see the notes here say lock RG1. In this demonstration, I'm going to use PowerShell to create an ARM template deployment. Before we get into the nitty-gritty, we first have to determine, by doing a bit of discovery, what the name of the commandlet is that will allow us to accomplish this. So I've launched Cloud Shell from the Cloud Shell button at the top of the Azure portal, and I'm in PowerShell, as we can see over here on the left in the bar. So I'm going to start by running get-command, and I'm going to put in an asterisk, the word deploy, guessing that the word deploy is in the name of the commandlet since we are deploying an ARM template. And boy, oh boy, we get a lot of them, but I'm starting to see some references to deployment template. Okay, well, let's start doing that. Let's clear the screen and take it a little bit further. So what I'm going to do is search for deployment. I'm going to use the up arrow key to bring up my get command statement from before, but instead of the word deploy, let's put in deployment. All right, looks like the list might be getting a little bit smaller. Well, we know we want to make a new deployment, so let's take that a step further. Clear the screen, use the up arrow key again to bring up our get command statement. And why don't we change our wildcard configuration here to be wildcard or asterisk new asterisk deployment asterisk. Okay, so let's see what we're getting. This is getting better already. So what I can see is we have a couple of options such as new-AZ resource group deployment. If we want to do a deployment to a resource group from an ARM template, that's actually what we're going to do. Here in WordPad, I've opened up the template file that we're going to use. It's called resource_lock_Azure_ARM_template. It's got a JSON file extension because it's a JSON file. It's using JSON syntax. In the end, what we're doing here is setting the type of item that we want to, in this case, modify in Azure to Microsoft.authorization/locks. And the name here of the lock is going to be RG1 lock. And in the properties section for that, we're setting the level to a read-only lock. And the notes or description is lock RG1. Notice in here, we've not yet specified which resource group we're going to apply the lock to. We'll do that at the command line in PowerShell. So back here in PowerShell, I'm going to use new-AZ resource group deployment. Resource group name in this case is RG1. That's where I want to apply that ARM template. I want to lock RG1 or the resources within it. I'm going to specify -template file, and here's I'm going to specify the name of my JSON file, and then I'll just press enter. Now note that instead of simply pointing to a template file locally, you could also specify a URI out on the network somewhere to grab it from that location. Looks like the provisioning state here is succeeded. So let's minimize this and let's go back here in the portal. I'm already looking at the locks for RG1, the resource group. It says this resource has no locks on the right. Well, that's because the screen just hasn't been refreshed since it was just created. So I'm going to click the refresh button. And sure enough, there it is, our lock, RG1 lock. It's read-only, and we can see the notes reflect lock RG1. That's what we had in our ARM template. Microsoft Azure provides some common or standard ARM templates that can be used to deploy common elements like virtual machines or web apps or databases. To get started here in the portal, I'm going to click Create a Resource. And I'm going to search for template, and I want to choose template deployment. So that's what I'm creating. And I'll click on the Create button. Now, in the middle of the screen, we're going to see an area labeled as Common Templates, where we see 4 items. The first is Create a Linux virtual machine. Next, we have Create a Windows virtual machine, then Create a web app, and then Create a SQL database. In this case, I'm going to choose Create a web app. Depending on the nature of how that template was built will determine how many things you must fill out on the next page here in the portal. So if the template hardwires the names for everything, then you won't really be presented with anything that you have to specify other than to accept the license agreement and then continue on to purchase it. So in this case, I have to specify a resource group. So I'm going to choose a resource group. After I've done that, I have to specify the location, although it's filled in. It's set to read the resource group .location property. So the location above for my resource group is Canada East. That's where the web app will be going. So it says at the top, it's going to create a CDN profile, content delivery network, a CDN endpoint, and a web app. And that's it. Well, what about the names of the web app and things like that? No, not required. So I just have to agree to the terms and conditions stated above and then click Purchase. And if I look at my notification bell icon in the upper right, we can see the deployment from that template is currently in progress. And before you know it, it will have completed. So at this point, I'm going to go ahead and take a look at this application. So to do that, I'm going to go to the All Resources view. And right away, I can see that we have a CDN profile generically named CDN Profile 1. We didn't get a chance to name that in the template. We could have edited the template if we wanted to. So let's filter out this view to make it even easier to look at. So I'm going to click on Type at the top. And all I really want to look at here is CDN Profile. And I want to look at App Service Plan, because that's what's required for a web application. Let's just click outside to run that filter. We can also see that we've got a name that was generated for our app service, our website, web app. And also we can see our app service plan is called Server Farm 1. So again, that specific template didn't allow us to name a lot of these things, but that's how quick and easy it can be to get things up and running when you use ARM templates. And that's why ARM templates are considered a tool for automating the deployment and the management of Azure resources. Azure lets you work with ARM templates that specify VHD or virtual hard disk files that you can use to build a new VM. So what this really means is that you're using the ARM template to create a virtual machine where you've already got a custom VHD or virtual hard disk file for that virtual machine. Now to get started, I'm going to go into the portal and I'm going to create a resource because I need to start this procedure by creating a template deployment. Okay, so I'm going to search for template. I'm going to choose template deployment and I'll choose create. Now at this point, I'm going to go down to load a GitHub quick start template and I'll just click that twice so I can pull up the list and I'm going to filter it for VHD. I'm interested in a template here from GitHub. So template 201-VM specialized VHD, new or existing VNet. So I'm going to go ahead and select that template and I'm going to scroll down and then I'll choose the select template button. Now that's going to take me into the next screen where I can see the parameter values I need to supply based on what's in that template, like the resource group. I'll just go ahead and specify a resource group. The new virtual machine name. Let's call this created from template, just so we can easily identify it. It's Windows. Now, at this point, a lot of the other stuff we're going to leave as the default settings, like the VM size, the VNet information and the subnet, the location, DNS name. That's all already being figured out based on how the template was created. However, down below, I've got to specify the OS disk VHD URI. That's why I have this other tab open at the top. I've got an existing storage account here in Azure, and if I scroll down in the navigation bar for that storage account and go to Blob Service Containers, you'll notice that I have a container here called VHDs, where I've already uploaded a VHD file, in this case for Linux, in which case we have to go back to our template, switch that over from Windows to Linux. So back to our VHD list. What I need is the URI for that VHDX file. So I'm going to click on it. That'll open up the properties here. And what I want to do is copy the URL. So I'm going to go ahead and copy that to my clipboard. And then I'm going to go back to where we were working with our template deployment. I'm going to paste that into the OS disk VHD URI field. So I'm pointing to a VHDX file that I've uploaded to a storage account. So basically I'm reusing a virtual hard disk that I might have been using on premises in the cloud. A customized VM is what is going to be the result. So I'm going to scroll all the way down here and I will agree to the terms and conditions. So I'll turn on the check mark for that box and I'm going to click purchase. In Azure, ARM templates are really just text files. They do use JSON syntax in terms of the formatting within the file, but they're just text files. And as a result, when you know how to manipulate the syntax, you can then start customizing them and build up a collection of templates that you use to deploy or configure Azure resources. You can also import those templates, such as into the portal editor. So to get started here in the portal, I'm going to click Create a Resource, and I'm going to search for template, and we're going to create a template deployment. So I'll click create on that. Now, when we're in the custom deployment screen, I'm going to click build your own template in the editor. Now from here, I want to click load file because I want to upload or bring in an existing ARM template file that I already have. Here in WordPad, I've opened up my on-premises template. It's called New Linux VM ARM template, and it's a JSON file, as we can see. And as we scroll through, we can see the contents of that ARM template, and we could tweak it as we needed to. However, I'm just going to bring it in to the Azure editor. Okay, so after loading the file in, we can see that it's loaded it here inside of the editor. Now, if you have some kind of error, so let's say I delete a comma here and a square bracket. Notice that on the far right, there's a red indicator that there's a syntactical type of problem in that area of the file. Of course, if we correct it by putting in our square bracket and comma, the red disappears, so we know we're in good shape. Now, when you load up a file here, an existing file into the editor here in the portal, you'll see on the left that it will automatically look at that and determine parameters. So it's simply looked at your file to determine what should show up for parameters in the left-hand navigator. And you can click on any one of them over on the left, and it will take you to that within the JSON ARM template file. We also can see any variables listed over the left. For example, we've got OS disk type in this case, so I can click on that, and it takes me to that over on the right. So it's a quick, easy way not only to view parameters and variables, and also resources that are defined, Azure resources defined in here, but it lets me quickly navigate to them. So under resources, we can see there's a network interface, a network security group, a virtual network, and so on. So we've got a number of items here, and again, when we click on them on the left, it takes us to that item over on the right. So once you've brought in a file here and you've made the appropriate changes, you can go ahead and click Save to save those changes, and that'll take you to the custom deployment screen where, depending on how that template was defined, will determine what you need to fill out here. So at this point, I would fill in the details to deploy a Linux virtual machine. So for example, I could choose in this case the resource group, specify a name. I'm going to call this Linux 1, specify the admin username and whether we want to use password or SSH public key authentication, along with all of the other items. So at this point, we would just deploy this as we would normally deploy any ARM template by filling in the required values to, in this case, create the resources for a Linux VM. ARM templates in Azure are a great way to automate the creation, but also the management of existing resources. And there are many different places from which you can source ARM templates, one of which is GitHub Online. GitHub is a centralized community for developers around the world where they can post their code. It's a code repository, among other types of things such as ARM templates. So here in my browser, I've gone to github.com/Azure/Azure-quickstart-templates. And here we have quite a big list of ARM templates that we could launch, depending on what we want, such as using Azure Application Gateway, Azure Bastion Jumpbox hosts, Azure Firewall, Azure Policy, Backup. The list just goes on and on and on. And so if I click on one of these ARM templates here in GitHub, it starts giving me further details when I scroll down about it, but I also have the option of clicking Deploy to Azure. That's one way I could get into my Azure environment in the GUI to create this template deployment. Or if I am in the Azure portal, I could choose Create a Resource. I'll search for template because I want to create a template deployment. So there it is. And then I'll click on Create, because I can also come in from this angle to get the same list of GitHub templates. We see that at the very bottom, load a GitHub Quick Start template. So I can click on the list to basically query the same list of ARM templates that we were just looking at directly on GitHub. So for example, what I'll do here is select one of these templates. So let's say here I'll use 101 Web App Linux Node. So I'm going to go ahead and click on that. Now down below, I can see the author. I can see when it was last updated. So I'm going to go ahead and click on Select Template. When I do that, it flips me over to the template page where I need to fill out some details based on which items are required, what values are required within that template. If the template had everything hardwired, then we wouldn't have much to do here other than to agree to the license terms and purchase it. So here I'm going to specify a resource group Or I could create a new one. How about we create a new one here? I'm going to call this ARM_web app. That's the name of my new resource group I'm going to create. The location here, Canada East, we'll leave that. Look what it's using down below to determine the name of the web app. It's concatenating node dash and then using the unique string function against the resource group name and then doing a UTC conversion. So of course we could specify whatever we want there. So I could change whatever that is. So maybe I'll call this web app YHC 567. So the resource group location is being used, the location property of resource group for the location of the web app. That's fine. That comes from the template. And that's it. So notice as well, actually, at the top, we could choose to edit the template or edit parameters. Let's actually go into edit template. This will actually let me see the actual JSON syntax in the template itself. And I could edit it directly if I really wanted to. However, I'm going to go ahead and choose discard. So back here on the template screen where we've specified the values, I'm going to go ahead at the bottom and turn the check mark on for I agree to the terms and conditions stated above, and I'm going to click Purchase. Well, it looks like we have a problem. At the bottom, I have a message that says there were validation errors. Well, that's okay. Let's use this as an opportunity to troubleshoot and solve the issue, because you're going to run into this from time to time. It's not always a perfect world from A to Z. Okay, let's find out what's going on. There were validation errors. Let's click on that link down below to find out what the problem is. Okay, it says validation failed for a resource, and okay, it looks like it's a problem because we have the free tier that's trying to be used as per the template. Okay. That's fine. Let's close out of that. Why don't we click Edit Template at the top? This is a great opportunity to use this to solve an issue. And maybe I'll click inside the JSON code here and Control F and for find. And what I want to search for, let's say, is SKU. Yeah, notice here the SKU is set to free. Why don't we change that to standard? And why don't we click the Save button in the bottom left? Okay, so we've just made a change to the actual template. Let's try once again to deploy this template. So I'm going to agree to the terms and conditions stated above. And once again, for a second time, let's click the purchase button in the bottom left and see what happens. And in our notification area in the upper right, we can see the deployment is currently in progress. After a moment, the deployment succeeded. So I'm going to click Go to Resource Group since we chose to deploy that template into its own brand new resource group. So I'm in the ARM_web app resource group, and I can see under the overview blade, if I look over on the right, that there are two resources that were deployed from that template. One is an app service plan, and then the other is the application itself, app service, our web app called web app YHZ-567. One important aspect of working with Microsoft Azure is automation. Automation accounts are resources you can create within Azure. Their purpose is that you can create runbooks within them. And runbooks allow you to automate repetitive tasks, ideally that don't require any user interaction. And those tasks would be related to anything involved with the management of Azure resources. So to get started here in the portal, I'm going to click Create a Resource. And what I'm going to search for is automation, because what we're going to create is an automation account. So I'm going to choose automation, and then I'm going to click create. This is the first step. Think of this as a centralized storage location to store PowerShell automation scripts, whether you write the code for that or whether you use graphical PowerShell runbooks. So for the name, I'm going to call it Automation 1. I'm going to deploy this into an existing resource group. The location I'll leave as East US. I have an option here of creating an Azure Run As account. By having this set to yes, it's going to create a service principal in Azure Active Directory that you can use when you're using your PowerShell commandlets for Azure to make a connection, an authenticated connection to resources. So I'm going to leave that set to yes. And I'm going to click Create to create the automation account. And after a moment, it will have created the account. So if we click on notification icon in the upper right, we'll see the new Azure Run As account service principal was created, and it also succeeded with the deployment of our automation account. I could click Go to Resource here, but I'm just going to go to the All Resources view. Just to be different here, we're going to filter out the list of resources such that we only see automation accounts. So I'm going to click the Type filter at the top. uncheck select all and check automation account, and I'll click outside of that. And we'll see we've only got one. It's called Automation 1. It's the automation account that we just created. So I'm going to click to open up its properties. Now, automation accounts can be used for more than just writing PowerShell scripts or runbooks, as they're really called in an automation account. You'll see as you scroll down through the navigation bar that you have some inventory, change tracking, desired state configuration options for configuration management centralized in the cloud, even update management. But as we go further down under process automation, which is really the focal point for us, we'll see runbooks. Think of a runbook as really being a PowerShell script. However, when you go to runbooks, you'll have the option of working with the existing tutorial ones that are listed here, or you can create a runbook, or you can import it if you already have a runbook file, or you can browse the gallery. Now, the gallery lets you essentially bring in runbooks that were already created. You can tweak them or use them as they are. You can also go down under shared resources and configure items that can be used across multiple runbooks, like a schedule if you want this to run on a recurring schedule, or credential sets, or connections, or PKI certificates, or maybe a variable to store your subscription ID in Azure. And these can be referred to by multiple runbooks. So at this point, all we've done is created the automation account, which is really a container to store our automation configuration in Azure. In this demonstration, I'm going to create a PowerShell runbook within an automation account. So to get started here in the portal, I've already got an automation account called Automation 1. So to get started with the procedure, I'll click to open up that automation account. And I'm going to scroll down in the navigation bar until I get to the process automation section, and then I'll click on Runbooks. So I'll see any existing runbooks that were created already, and I've got a couple of standard default tutorial runbooks created by Microsoft Azure. So they're listed here automatically. However, what I want to do is create a brand new one. So I'm going to click Create a Runbook up at the top, and I'm going to call this RB1 for Runbook 1. Now for the runbook type, it can be either PowerShell, so you're writing PowerShell code, it could be Python 2, or it could be graphical, where you can drag items onto a canvas and click and drag to link them together to set the sequence. So it's kind of like the graphical equivalent of writing code, where you can set properties and parameter values. We could also get more involved with PowerShell workflow or graphical PowerShell workflow. You use workflows when you have more complex, long-running sequence of steps that you need to fire off, and maybe even have a couple of them run in parallel or at the same time. That's not the case here. I just need a simple PowerShell runbook type, so I'm going to select that, and I'll click Create. Now that takes me directly into the PowerShell runbook editor, where on the right, I can see I've got line 1, where I can start typing in code for PowerShell. And on the left, I've got a library selection of items where I can expand commandlets. So if I expand commandlets, I can see they're organized by module. So for instance, if I'm interested in storage commandlets, I can drill down under Azure rm.storage, and I could see a number of commandlets listed there. And of course, I could click the 3 dots, the context button there to the right of anything listed in the library on the left, and I could choose Add to Canvas, and it will write it over on the right. Or if you just know what to type in naturally, you can go ahead and do that too, or you might copy and paste it from elsewhere. So those are commandlets. We also have runbooks, where we'll see any other runbooks that might be available within the automation account, and we can refer to them here. We also have a list of assets. These are shared assets available in the automation account. You create them and they can be used amongst one or more runbooks in that automation account, like variables. You might have a variable that stores your Azure subscription ID, or connections, or credentials, or PKI certificates if needed to authenticate and be authorized to access other resources. So I'm going to start here by doing something very basic. I'll use the write-output commandlet, and we'll do the standard hello world example to start with. So hello world. So I'm going to go ahead and save this. So the runbook has been saved within the automation account. Now I can test it, see what's going to happen, or to tweak it if I've got any errors. So I can click Test Pane at the top, which opens up another window, or I can click the Start button at the top to start the test. We can see it's queued. Streams will display when the test completes. So we'll see the output down below the white line on the right. After a moment, we can see at the top it says completed, and down below we see our output, Hello World. So I'm just going to click the X in the upper right to get out of there. Now let's actually work with something a little more meaningful here in our runbook, something that is related not to displaying text messages, but rather to doing something useful in Azure. So I'm going to get rid of that code, and I'm just going to paste in some code I've already got ready here. What I'm doing here in line 1 is I'm using the get-automation connection commandlet, and I'm specifying a name as Azure Run As Connection so that I can have an authenticated type of connection made to Azure from within my runbook. Now, down below, I'm looking at number 4, line 4, where I'm creating a variable called $null, only because I want to suppress the output of the result of using the add-Azure RM account commandlet. And I'm specifying a lot of built-in variable and properties here to authenticate to Azure. Now, once I've done those things, starting in line 8, I can actually get to the core of what it is I really want to do. All I'm doing here is simply running get-Azure RMVM, and I'm piping that to select name. So I only want to see the name property for Azure virtual machines. Let's go ahead and save this. We're going to go ahead and test it out. So I'm going to go to the test pane, and once again, I'm just going to click the start button. We can see that the job has been queued here, the test job, so we'll just wait a moment. And after a moment, we can see it's returned the fact that we have one VM called DC1 back to the output screen. So I'm going to click the X again to close out of that runbook. The next thing I want to do is actually publish it. Publishing it makes it available so it can actually be used in a production type of environment. So I'm going to click the Publish button. It says it's going to publish this version and override any previously published versions, which don't exist yet. It's the first time I've done this. Do you want to proceed? I'm going to click Yes. Now that kicks me back to the properties of my runbook RB1. I can see in the navigation panel down on the left, any jobs. Now the job would be the result of actually starting the runbook here, not testing it, but starting it here, and any schedules it might be linked with, and so on. So I can go back and edit this runbook at any time. When I'm looking at the overview blade here, notice I've got an edit button up at the top, and if I click that, it'll take me back in, and I'm where we started, where we put the code in and where we ran our tests and ultimately published it. To actually start this runbook manually, we would click the Start button here in the overview blade up at the top. So I'm going to click Start. Are you sure that you want to start it? Yes. So I'll click the Yes button. That's going to open up a new panel where I can see the status is that the job has been queued. And down below, once the job is completed, I'm going to want to take a look to see if there are any errors, warnings, or at any output that might result from running this. After a moment, we'll see it's completed. If I look at errors, there are 0 errors, 0 warnings. Well, that's good. If I go to exception, no exceptions. Really, there's not much I can see here under all logs. Well, really, I can just go to output and see the resultant output of my runbook. All it does is display the name of our virtual machine, DC1. Azure automation accounts can contain shared resources. Let's open up an existing automation account here in the portal to take a peek at what that means. So when I look at the navigation bar for an automation account, if I scroll down, if I go down under the shared resources section, you'll see what I mean. We've got schedules, which is what our focal point will be so that we can have a recurrence for PowerShell runbooks in this automation account. We want to run them on a schedule. I can set credentials that might be required by some runbooks to authenticate to Azure. We've got certificates, connections, even variables. We might have a variable to store our subscription ID that might be required by a runbook. So in this case, I'm going to go under schedules and build a new schedule, and then I'll associate it or link it to an existing runbook. So I'm going to click Add a Schedule. That's one of the powers of using Azure automation accounts with runbooks, is running things on a recurrent basis, such as the management of VMs to shut them down or to perform some kind of maintenance to them. I'm going to call this Schedule 1, and I can set a start date and time, and I can then select the time zone. I can also select recurring, and I can determine what the recurrence is. Is it once every hour, which is the default? I'm going to select it to be once a week. Then when I do that, I can specify the days. Maybe I want this to happen on Saturday when there's less activity for our Azure resources within the Azure cloud. I can also set an expiration of how long I want this to go on. So I'm going to choose yes for expiration, and I'm going to select maybe a few months down the road as an expiration date, and I can specify the time I want that to expire as well. I'm going to go ahead and click Create. So what we've just done is created a schedule called Schedule 1. It's a shared resource within our automation account. Now what we want to do is use that with an existing runbook. So I'm going to scroll back up until I see under the Process Automation section on the left, Runbooks. And I've got a runbook in here called RB1. So I'm going to click RB1. When I'm looking at the overview blade for my runbook, I have a button at the top called Link to Schedule. That's exactly what we need. I'm going to click it. At this point, it's just a matter of navigating to and choosing Schedule 1. So I'm going to click the Schedule portion here to link my schedule to a runbook. I see Schedule 1 shown on the right, so I'm going to go ahead and choose that. I'm not going to modify any of the parameters or run settings that go along with that. So I'm going to leave that as it is, and I'm going to click OK. And we can now see in the overview blade that we've got a quick message that popped up. It disappeared rather quickly. That said that our schedule was linked to this runbook. Now we can check this out here in the runbook properties in the navigation bar on the left. If I click Schedules, we'll see that, yes, indeed, our runbook RB1 is associated with Schedule 1. So in this course, we've examined automating administrative tasks in Azure using Azure Resource Manager or ARM templates and automation runbooks. We did this by exploring ARM templates and how they relate to automation. We looked at how to save a template from an existing resource and create a template using the editor in the portal. We also looked at how to use the portal, CLI, and PowerShell to deploy an ARM template. We learned how to deploy Azure resources from a quick start template and deploy VMs using VHD templates. We looked at how to import an on-premises template file and deploy Azure resources from a GitHub ARM template. Next, we learned how to use the portal to create an automation account, followed by how to create a PowerShell runbook and then schedule the runbook. In our next course, we'll move on to explore Azure solutions for recovering from disruptions of service or disaster, including the use of recovery services faults, Azure backup, VM failover, and update management. A crucial aspect of planning your use of Azure cloud resources is disaster recovery planning. What do we do when there's some kind of unanticipated disruption? So it's better to have plans for this ahead of time instead of reacting at the time of disruption. So there's some terminology we need to be aware of, including the recovery time objective, or the RTO, and the recovery point objective, or the RPO. Let's start with the RTO. The RTO is all about the maximum tolerance for downtime. So whether that involves a software component that writes messages to a message queue being unable to do so, or whether it refers to a web app being unavailable, or a virtual machine not being reachable, all of this is applicable. So we're talking about how long it will take to bring a system or a service back online to a functional state. It also can relate to how long it takes to recover data, perhaps from backup in the Azure cloud, or the amount of time it takes to move operations to an alternate site. So one thing you can look at in Azure is the service level agreement, or the SLA, for each Azure service to see what the guaranteed uptime is. So for a mission-critical web application, we might have a recovery time objective, or RTO, of 60 minutes. That's how important it is to have it up and running and functional within an hour. Otherwise, the organization might suffer more severe consequences. The recovery point objective, or RPO, is all about the maximum tolerance for data loss. So therefore, it affects how often backups should be taken, whether we're talking about backup for a virtual machine or an on-premises host to the Azure cloud, or maybe how often we take backups of a web application in Azure. We have to think about the RPO and how it applies to different types of services or systems we have in the cloud. For example, finance servers versus file servers that might only contain documentation. In this case, the recovery point objective, or the maximum tolerance for data loss for finance servers, might be 2 hours, whereas the RPO for file servers might be 72 hours. The other thing to think about is a disaster recovery plan, or DRP, document. Now, this has to state the recovery objective, such as which server or service it might apply to, the scope, so it might apply to storage accounts within a region, for example. Then we have to think about the disaster recovery plan team members and their responsibilities. People have to know how to respond to an incident and what their roles and responsibilities are in containing that incident. So there needs to be contact information in the DRP document in case we have to escalate the issue to a higher level. So it would contain things like escalation details. Then you also have the Incident Response Plan, or the IRP. This needs to be set up before we have negative incidents or security breaches. Now, the effects of having an inadequate incident response plan would include financial loss to the organization, reputation loss, loss of business partnerships or contracts, and so there should be an annual review that keeps up with the ever-changing threat landscape. Now, the other aspect of disaster recovery and planning in Azure deals with availability zones, or AZs, which are contained within a region. An availability zone contains one or more data centers. Now, why is this relevant? Well, it can be relevant because what you can do is, if you have two availability zones, here we see AZ1 on the left and AZ2 on the right, the implication with the diagram on the right is that you've got 3 copies of data replicated throughout an availability zone. So what we can do then is we can spread out our Azure services across availability zones to increase availability. So an availability zone then is physically separated by distance. However, when you have, let's say, 3 availability zones, while they're each separated by distance, they still reside within a single Azure region, such as East US. Now remember that each data center doesn't necessarily map to a single availability zone. But also on the availability side, each data center that Microsoft uses for Azure has its own power, networking, and HVAC that is separate from other data centers and is available even in the event of a power outage. You could even replicate data between availability zones. So imagine that you're going to deploy a load-balanced solution that uses 4 or 5 backend VMs. You might even have a couple of those VMs in the backend pool for the load balancer in AZ1, while other VMs are in AZ2 to further increase the resiliency against failure. So Azure Availability Zones provide high availability. It's 1 or more data centers, and it also includes fault domains. Now, the idea with a fault domain is that when we have multiple VMs, let's say in a VM scale set, we can ensure that they are spread out across equipment racks in a data center so that the failure of one piece of equipment, like a network switch, physically won't necessarily make sure that all VMs are unreachable. Then there are update domains. So when Microsoft makes updates to the underlying infrastructure, it's kind of done in a fashion where one set of hardware is updated, and after it's completed, the next set of hardware is. So by spreading things like virtual machines, when you have multiple VMs working together across update domains, it means that you are always assured that you'll have a VM that is reachable. Azure Site Recovery is all about business continuity and disaster recovery, keeping things running smoothly, making sure data and critical IT systems are available when they are needed. So essentially making sure that we can adhere to the recovery time objective and recovery point objective for various systems within the organization. Azure Site Recovery is considered to be Disaster Recovery as a Service, or DRaaS. It supports failover and failback. This can happen between on-premises physical as well as virtual servers to Azure, and it also allows for replication between primary and secondary sites. In other words, replicating virtual machines between Azure regions. Failover means failing over to a secondary copy of something when the primary one is unavailable, and failing back means going from the secondary that was failed over to back to the original, so hence fail back. Application snapshots are also available for web apps. They store information related to the app's state, like memory, contents, transactions, and also disk files related to that. Alternate recovery sites are important for business continuity. Now, without cloud computing, it means having an alternate physical facility that you either lease or purchase and populate with equipment, people, and data. However, in the cloud, we can use cloud computing itself as an alternate network location for IT services. So it's all about planning for the inevitable failure or disruptions that will occur over time. Now, there are a number of different server types that are supported with Azure Site Recovery to enable protection. They can be on-premises physical servers. You can enable site recovery for Azure virtual machines, VMware virtual machines that are on-premises, Microsoft Hyper-V virtual machines that are on-premises. Now, some limitations to keep in mind are things such as the fact that an on-premises physical server can fail over to an Azure virtual machine, but you won't be able to fail back to a physical on-premises machine after the fact. If you want to use site recovery in Azure to protect backed up data and to protect critical running workloads, then you need a recovery services vault. And that can be created using command line tools like PowerShell, as well as here in the portal. So here in the portal, let's create a recovery services vault. I'm going to click the Create a Resource button, and I'm going to search for recovery. And I'm going to choose Backup and Site Recovery from the list, and then I'm going to choose Create. So that places me on the Create Recovery Services Vault page. So I'm going to specify a resource group I want to deploy this Recovery Services Vault into, and I'm going to give this a name. I'm going to call it Vault YHC 567. And I'm going to put this one in the Canada Central region, only because I know that's where most of my resources are that I want to protect, and it's geographically near where, as an Azure administrator, I currently reside. So I'm going to go ahead and click Next for tags. I'm not going to add tag values. I'm going to click the Review and Create button, and I'm going to click the Create button. So what we're doing is deploying the Recovery Services Vault. Now, there's a lot of additional configuration depending on which types of workloads you want to protect with the vault, but we'll go poke around and take a look at some of the settings here once it's created. So we can see now it says the deployment is complete, so it doesn't take very long to build the vault. Let's go ahead and click Go to Resource. So in the vault, if I scroll down here over on the left, under Getting Started, I see Backup. So this is how I can start determining which types of workloads I want to back up and where they're sourced from, whether it be on premises or in the cloud. So it says, where's your workload running? And it's set to Azure, and the second drop-down list then is filtered based on that. It says, what do you want to back up? You can back up a virtual machine, Azure File Share, SQL Server, SAP, HANA in an Azure VM, a lot of options. I can also choose Azure Stack, or I can choose on-premises. When I choose on-premises, I can then determine if I want to back up files and folders into the Azure cloud from on-prem, Hyper-V or VMware virtual machines, SQL Server, SharePoint, Exchange Server, if I want to back up the system state of a host on-prem, or do a bare metal recovery. The thing about bare metal is that depending on the amount of information, because you're backing up the operating system and data, to dump that into the cloud, and then if a machine won't start, for example, on premises, you want to restore it using bare metal restore from the cloud, that could require a lot of bandwidth. So you want to think carefully about that one. But that's where we would go to configure those items. I could also click on Site Recovery in the left-hand navigator, where I see that the first thing I would need to do is prepare my infrastructure. So I would do this if I want to protect a critical running workload. It says, where are your machines located? Azure. where do you want to replicate them to Azure. Or we could select for the source on premises, and then we could determine that we want to replicate them to Azure to a recovery site. And down below, I have to determine if I'm performing migration, yes or no. If I choose yes, then we are ready to put a check mark in I understand, but I would like to continue with Azure Site Recovery and click OK. But if we were to set the are you performing a migration to no, then we get a host of other options. For example, it says, are your machines virtualized? Yes, with VMware, vSphere hypervisor, or yes with Hyper-V, or not virtualized, or other. So if I were to choose yes with Hyper-V, then I'm asked if I'm using System Center Virtual Machine Manager, or VMM, to manage the hosts. I could choose yes or no, and continue on with the configuration for protecting those items. So I'm going to click the X, and I'll click OK when it informs me that I'll lose my settings. So I'm going to back out of the Prepare Infrastructure. So from here, I could then, on the right, click on Step 1 to replicate the application and start making a selection for virtual machines that are hosting the important workloads that I want to protect with Site Recovery. I'm going to close out of that. After all of this has been done, I'll be able to go into Protected Items, and I'll see any backed up items. So we can see they're all categorized here. So SQL and Azure VM versus Azure Backup Agent, Azure Virtual Machine, they're all set to a value of 0. I can also click on Replicated Items to see if anything's been replicated here into Azure. And finally, if I go down in the left-hand navigator, I can also click on Backup Policies. You'll see that you've got a default policy here, an hourly log backup for SQL Server running in Azure VMs. And you've also got a default policy for Azure Virtual Machines. And if I click to open up that default policy, we can see the backup frequency. So it's daily at 12:30 a.m., so pretty much late at night or early in the morning, depending on how you look at it. And we can see the retention of daily backup points is for 30 days. So there are a number of items then that we would configure to fully enable protection for workloads using the Site Recovery Vault. But at this point, we've created the vault itself. In order to protect your workloads and virtual machines and hosts from disruption, you can work with the Recovery Services Vault and configure things like backup. So we can use PowerShell then to create and manage recovery services. So to do that, I've launched the Cloud Shell from the Cloud Shell icon at the top of the toolbar here in the portal. And what I'm going to start with here is using the new -AZ Recovery Services Vault commandlet. I'll use -name to give it a name. In this case, I'm calling it Recovery Vault 192 -resource group. I want to deploy this in a resource group called RG1. And -location, I'm going to use Canada Central. So I'm going to go ahead and press Enter to build that Recovery Services Vault. And it looks like it's good. Now we can verify this by running get-az Recovery Services Vault, and maybe I'll pipe that to select and tell it I only want to select the name property. We can see we have a number of vaults here, including the one we just created, Recovery Vault 192. So the next thing that I want to do is I want to actually enable backup for a virtual machine, and I want that backup to be associated with this Recovery Services Vault. I want all subsequent commands to be in the context of working with my newly created vault, Recovery Vault 192. So to do that, I'm going to run get-az Recovery Services Vault -name Recovery Vault 192, and I'm going to pipe the result of that to the set-az Recovery Services Vault context, and I'm going to go ahead and press Enter. You have a couple of warnings saying that in the future, the functionality may be changed for this commandlet, but for now, that's fine. I'm just going to ignore it. So I'm going to type in CLS to clear the screen. The next thing I'm going to do is store a policy from the Recovery Services Vault for backup purposes in a variable that I'm going to use later when I enable backup for a VM. So I'm going to create a variable called $policy in which will be stored the result of running get-az Recovery Services Backup Protection Policy, and I'll give it a name. I'm going to refer to it by name rather, -name default policy. Every Recovery Services Vault will have a default policy and possibly additional policies if you've created them. So you refer to it by name, and that's what I'm doing here. So if I just check my work here by typing $policy, we can see it's storing the information for the default policy from that recovery services vault. The next thing I'm going to do is enable backup for a specific virtual machine running in Azure. To do that, I'll use the enable-AZ recovery services backup protection commandlet, -resource group name, I'll specify RG1, and for -name, I'll specify the name of the virtual machine that I want to enable backup for. So I've already got this VM in existence. It's called WinServe 2016-1. And here's where I'm going to use -policy and pass it our $policy variable that we've established up above. So I'm going to go ahead and press enter. We can see the operation completed successfully. So it's configured for backup, our virtual machine. Ultimately, I'm going to force backup of a VM here in PowerShell, but first I'm going to set up a few variables to do that. One of which I'm going to call $container. It's going to store the result of running git-az recovery services backup container. -container type, I'm setting to Azure VM, that's a keyword. -friendly name, I'm going to use the same name for the virtual machine, so WinServe 2016-1. We're going to go ahead, press enter, and just type $container to make sure that we've got something stored in that variable. So the name, the -friendly name parameter needs to map to the name of the VM. Next thing I'm going to do is create a second variable, and this second variable, I'll just put the code in here, it's going to be called $item. It's going to store the result of running git-az recovery services backup item -container. I'll use our $container variable. -workload type is Azure VM. So we're telling it that we want to back up an Azure VM. We just haven't told it to do it yet. Now, to actually make that happen, we're going to use a different commandlet. We're going to use the backup-az recovery services backup item, and we're going to tell it -item, and we're going to pass it the $item variable. Now, there's more than just Azure VMs that we can back up, which is why we had to set up those variables correctly firsthand. So I'm going to go ahead and press enter to begin that backup. And just like that, we can see the status is in progress. So what we can now do is check that out. We can monitor it, so to speak, by running git-az recovery services, type that incorrectly, services backup job. And we can see here that it's configured backup. That's completed. We can see the date and timestamp for our virtual machine, WinServe 2016-1, and we can see it's currently in progress of backing it up. Microsoft Azure Backup requires a recovery services vault where you have the configuration and where you can view protected items that have been backed up to the cloud. We can back up on-premises files and folders, or on-premises Hyper-V and VMware virtual machines, or SQL, Exchange, and Microsoft SharePoint server installations. We can also back up system state. On a machine like a domain controller, system state would include things like the Active Directory database and the registry and so on. Bare metal recovery is also supported if you need to capture essentially a backup of all of the operating system files as well as data disks, so that in the event that you've got a machine that won't even start, you can recover using a bare metal technique. Now, in order to use Microsoft Azure Backup, the Microsoft Azure Recovery Services Agent, or the MARS agent, needs to be running on the host that you want to protect, such as an on-premises file server. And that MARS agent is what authenticates and communicates with the Azure cloud. So once we do that, then we can schedule backups on-premises into the cloud and then do a restore when needed. So in Azure, you can back up virtual machines, Azure SQL database, and Azure file share contents. To configure Windows Server Backup in Azure, as we know, the first thing we have to do is create a recovery services vault if there isn't one already present. Next thing we need to do is download and install the MARS agent on the servers that would be protected, and then finally register the MARS agent with the recovery vault. That's part of installing the MARS agent. The tail end of it is going to be registering with it, which authenticates and establishes a level of trust between that host that's going to be protected and the Azure Recovery Services Vault. Enabling backup for an Azure virtual machine requires first that you've created a recovery services vault, unless you're using a third-party backup solution, of course. Here we're going to use Azure Backup. So to do this, in the portal, I've already navigated to the properties of an existing virtual machine. So what I want to do from here is in the navigation bar, I'm going to scroll down on the left under Operations, and I'm going to choose Backup. Now from here, what I need to do is make an association between this Azure VM and a recovery services vault. So I can select an existing vault from the drop-down list, or I could choose Create New. I'm going to choose an existing vault from the list. And within that vault, the next thing to do is to select a backup policy. Every vault is going to have at least a default policy. You can choose from the list to see if there's anything else. And the policy will define things like when backups are to be taken and how long they should be retained for. So I'm going to leave the default policy selection there. And when I do, I can see the policy details down below. So I'm going to go ahead and click Enable Backup to turn that on for this VM. So after a moment, if we click on something else and come back to the backup blade, we'll now see that we've got some stats. We've got alerts for backup jobs for the last 24 hours. We can see backup status. So we've got the backup pre-check that has passed, but we haven't yet done an initial backup. So it says warning, initial backup pending. We can see the association with the recovery services vault and the policy. And we'll see any restore points after we've got some backups. So I'm going to force a backup immediately by clicking the Backup Now button up at the top. And I'm going to leave the backup retention date as it is, and I'll click OK. And if we go to the View All Jobs link, then we can see that the configuration of the backup has occurred for our server, WinServe 2016-2, and that it's currently in the midst of performing the backup. In this demonstration, I'm going to configure it such that we can back up an on-premises virtual machine into the Azure cloud. First thing I've already done is I've created a recovery services vault. It's called Recovery Vault 192, and here in the portal, I'm viewing its properties. So to get started, I'm going to scroll down in the navigation bar, and under Getting Started, I'll click on Backup. Over on the far right, where it asks in the drop-down list, where is your workload running? Instead of Azure, I'm going to choose on-premises. In the drop-down list below that, where it states, what do you want to back up? I'm going to open that list. We can see there are many things here. We can back up files and folders, virtual machines on-premises, or a variety of Microsoft server types like SQL, SharePoint, Exchange, and so on. I'm going to choose Files and Folders. Then down below, I'm going to click the Prepare Infrastructure button. That opens up a new screen where the first thing I need to do is download the Recovery Services Agent, the Microsoft Azure Recovery Services Agent, otherwise called Mars Agent. Now that needs to be downloaded and installed on the on-premises server that you want to back up to the Azure cloud. So the next thing I'll do on the host where I'm going to install the Mars installer is I'm going to go to a command prompt, just type host name, and we can see the server here is returned as being WinServe 2016-2. So I've got the Mars Agent installer here. Just going to right-click on it and choose Run as Administrator to begin the installation process. On the installation settings part of the wizard, I'll accept the default installation folder and cache location. I'll click Next. And I don't have to go through a proxy server to get out to the internet, so I'm not going to configure any proxy settings. I'll click Next. I'm going to tell it I want to use Microsoft Update when I check for updates, just to make sure that we can run the latest version of the Recovery Services Agent. So I'll go ahead and click Next, and I'll click Install. And when that's complete, I'm going to click the Proceed to Registration button. Now, the last part of this Mars Agent installation is for me to identify an authorization for this on-premises server to be able to talk to Azure and to backdate up into it. And so what we need is a Vault Credentials file. So for that, we're going to have to go back to the Azure portal. So here in the portal, we left off in step 1 where we downloaded the agent, the Mars Agent, and installed it. That's been done. So I'm going to choose the check mark under step 2, already downloaded, and I'm going to click Download to download a Vault Credentials file, which is only good, as it says here, for 2 days. Well, I'm going to use it right away, so that's more than enough time. So I'm going to click on Download. Okay, so I've got that file, the Recovery Vault credentials file downloaded. So now I'm going to specify that for Vault credentials as part of the Mars agent registration. So I'm going to click the Browse button. I'm going to go to my local downloads folder. There it is. I'm going to select the file. It knows the name of it, the region, the subscription, and so on. Just going to go ahead and click Next. Now, the next thing we need to do is specify a passphrase that's going to be used for encrypting backup. So I'm going to choose Generate Passphrase. Now, in that case, we're going to have to enter a location to save the passphrase. So I'm going to click Browse to go and do that. After a moment, our server has been registered. We have a little warning because we're storing the passphrase in a local file. That's fine, assuming that host will be backed up. And it's set to launch the Microsoft Azure Recovery Services agent. That's great. I'm going to leave that checked on, and I'm going to click Close. So basically, it will take me into Windows Backup on this machine. And I'm going to go ahead and click Next. And I'm going to click Add Items. What I want to do is take a look at Drive C on this host. Specifically, what I want to do is back up some sample files that are available here. So I'm going to navigate in the file system down to a sample files folder that I've got. I could expand that further and select individual files, but I want everything in and under the sample files folder I've got here. And I'm going to click OK. Then I'm going to click Next. I can schedule the backup daily or weekly. I'm going to leave it daily at 5:30 in the morning. I could also have up to 2 additional backups per day for a maximum of 3 per day. I'll click Next, and I will accept the default for the weekly, monthly, and yearly backup retention settings. I'll click Next. Transfer over the network is selected. It's an online type of backup to the cloud. So I'll click Next, and then I'll click Finish. After a moment, it says we've successfully created a backup schedule. So I'm going to go ahead and click Close. Now, at any point in time, we could also back up now if we want to start an initial backup instead of waiting for the next iteration of our schedule. So I'll click Backup Now. Files and folders is selected. I'll click Next. I'll just go through and accept the defaults, and I'm going to choose Backup. And after a moment, we can see that the job has completed. So I'm going to go ahead and click on Close. Now, we can see in the Jobs tab here in Microsoft Azure Backup that we've got a date and timestamp for the backup, and it says the job has completed. It also shows up down under the last backup option. Okay, after you've configured backup for either Azure virtual machines or perhaps on-premises physical hosts or virtual machines, how do you get the data restored? Well, here in the Azure portal, I'm looking at an existing virtual machine called WinServe 2016-2. And if I scroll all the way down in the left-hand navigator under Operations and choose Backup, I'll be able to see the association over on the far right here with the Recovery Services Vault, in this case, Recovery Vault 192. I can also see that I've got restore points available down below. Now, what we could also do is take a look at the same thing, but from the perspective of the Recovery Services Vault. So I've gone to another tab here in the portal for Recovery Vault 192, and I've already gone down under Protected Items and clicked Backed Up Items. So we can see we have an item here listed on the right for Azure Backup Agent. We've got a backup item count of 1. So we've got 1 Azure Backup Agent. That's the Mars agent, the Microsoft Azure Recovery Services agent that was installed into a host to back up its file system. So if I click on that item, we can see here that the backup, in this case for something on drive C, on that protected server, succeeded. We can see the last backup says success. And I can click on it to read more details about the recovery points listed down below. Now, what we can also do is look at it from the perspective of the Azure virtual machine. Here I've got 2 of them under backup item count, one of which is the same one for Azure Backup Agent. So if I click on that, I can see, for example, WinServe 2016-2 listed here, and I can click on it. I can choose to back up now. Well, that's not what we're here for. We're really here to talk about restoration. We can either restore the VM or perform file recovery on files within the VM that were backed up. So if I choose Restore VM, then I have to determine what is it I want to do. I want to back up to a new VM or overwrite the existing one. So first things first, in step 1, restore point, I would choose a restore point on the right, click OK, and in step 2 is where I determine if I want to create a new virtual machine or replace an existing one. But I'm not going to do either of those. I'm going to close out of these by clicking the respective X's. If I click the File Recovery button up at the top, from here I have to choose the appropriate recovery point. And down below, I would download an executable. So I'm going to have a script here that will mount it so that I can browse the file system and select what I want to restore. So I'm going to choose Download Executable. Now we have a message that says it's generating the script and password, and we can see down below the password to run the script is being generated currently. So it's going to mount this on my machine so that I have the ability to browse the backed up file system. So then we're at the point where it says your script file is ready to download, and we can see that a password to run the script is available to be copied down below. So I'm going to click the download button to download the script that will mount the backup. So I'm going to go ahead and choose Save As and save this on my machine. And then I'll choose Open Folder. So I can see I've got a little executable here. I'm going to right-click on it, and I'm going to choose Run as Administrator. And I'll choose Yes when I'm asked if I want to allow it to run. Here it wants me to enter the password from the portal. So back here in the portal, for the password to run the script field, I'm going to click the Copy button to the right of it. And I'm going to go ahead and paste that in the script and press Enter. We can see it starts PowerShell, and it's asking me to enter Y to proceed. All right, so I want to go ahead and make sure I've got a connection here. If you've got any older connections, you'll get some messages about that. So it's telling us to open Explorer to browse for files, and we can see the 2 recovery volumes that are attached. So from there, we would just browse to those locations, copy the files we wanted, and then when we're finished, we would unmount. That would be step 3 of the portal. So back here in the portal, I would just scroll down under step 3 and choose Unmount Disks. Replication presents one option to increase high availability, whether you're replicating data, for example, from on-premises to the cloud, or in our case, replicating an Azure virtual machine from one region to a different region. To get started with doing this, here in the portal, I've already navigated to the virtual machines view. So I'm going to click on one of my existing virtual machines, in this case, DC1. And in the navigation bar on the left, to get to the replication portion, I need to scroll all the way down under Operations, and I need to then click Disaster Recovery. Now, the first thing you'll see is the suggested target region in a drop-down list to create the secondary VM replica in. But you can open that drop-down list and choose something else. You also have a visual representation on the map. If I scroll down, according to the legend, the source region is shown in blue, and I've got a dashed line indicating the selected target region. And then we've got the available regions. Well, I'm going to go ahead with the default selection. My source region is Canada Central. It's selected the secondary target region as being East US, so still on the Eastern Seaboard. That makes sense, so I'm going to leave that. I'm going to click the Next Advanced Settings button down at the bottom. So on the Advanced Settings part of the wizard, you've got a source column. That's the source region where the VM resides currently. And you've got the target. So you can select the target subscription, specify a target VM resource group. It's automatically going to create a new one. And it's basically going to be the same name as the source resource group in this case, which is RG1, except it's got a dash ASR at the end, where ASR stands for Azure Site Recovery. The same goes for the source and target virtual networks. And for availability, I'm going to leave it on single instance as opposed to availability set or availability zone. Down below, we've then got storage settings that we can show the details for by clicking the Show Details link. So we can see the cache storage account it's going to make and the replica managed disk for each disk in the source VM. Same goes for replication settings. We can click Show Details next to it, and we can determine the Recovery Services Vault, for example. We can select Recovery Services Vault for the association. We can specify the replication policy. And finally, for extension settings, I can show details if there are any extensions that need to be configured. So I'm going to go ahead and click the Next Review and Start Replication button in the bottom right, and I'm going to choose Start Replication. Now you have to monitor this. It can take a bit of time for this to happen depending on the size of each VM disk and how many disks the VM actually has associated with it. The other thing to bear in mind is that once this is completed, if you want to, you can then start running VM recovery drills. In other words, you can force a failover and test out the functionality. Back in the portal, if I open up my Bell notification icon in the upper right, I can see it's enabling replication for the VM and how long it's been going. So I might want to monitor this so I can track once it's completed. Okay, so I'm going to go back into my virtual machine, and in the navigation bar, I'm going to scroll back down under Operations and choose Disaster Recovery. But this time it's going to look different because the virtual machine has replicated to the target region. So it's taken us into the Replicated Items menu, and I'm in the Overview blade, where we can see on the right the replication health is listed as being healthy, the status of the VM is that it's protected, and the RPO, or the recovery point objective, is listed here as being 1 minute. Now the RPO, or the recovery point objective, lists the maximum amount of tolerable data loss. We can also see that we have a failover and a test failover button available up here at the top. So we can test the failover to make sure that we can essentially switch to the secondary copy of the VM when needed, or we could initiate a real failover. If I were to click Compute and Network over on the left, we would be able to see not only the source details about the virtual machine, the source settings as it's shown here, but we would also see the target settings column. So the target virtual machine name, target resource group, target size information, the target virtual network, and so on. The same type of thing is true for the disks. So we can see that we've got a replica disk name. We can see the target disk name, in this case only for the operating system. But what's key here is that the status column shows that the disk is protected. So it's been completely replicated to the secondary region. After you've enabled replication for an Azure virtual machine to a secondary region, you'll then be able to conduct a failover test. Here in the portal, I'm looking at the properties of an existing recovery services vault where I've scrolled down under protected items and selected replicated items. And on the right, I see that there's a virtual machine that's replicated and its name is DC1. Currently, the replication health is listed as being healthy. So if I click on that entry to open it up, it takes me into the details where I can perform a real failover or first conduct a test failover. Now that's the same thing I can do if I flip to another browser tab here. That's the exact same thing that I will see if I go into a virtual machine's properties. So let's just go back one step here. And if I go into disaster recovery within that virtual machine, I'm going to see the exact same options. So I'll see that I have the option on the overview blade at the top to run a failover or a test failover. Now, running a test failover is recommended before you run a real failover, just to make sure that everything is running correctly. It's called a recovery drill. We want to make sure that we'll be able to switch everything over to the secondary copy of the VM in the event that we had a problem with the primary one. So this screen for testing failover shows the source region, Canada Central, the target where the VM's been replicated to already, East US, and we can select a recovery point. We could also go to custom to get a list of all of the recovery points that we want to choose from down below from the recovery point list. And then we can also select the Azure virtual network that we want to fail over to. Now, if I just close out of that for a second and I'll click OK, you get the same type of thing if you click the failover button to actually perform a failover. First thing you'll see is it says there's no failover test that's been performed in the last 180 days. That's okay in this example. I'm going to turn on the checkbox for the I understand message. And then we see the same type of options that we saw in the failover testing. So we can see the source or the from and the to for regions, the recovery point selection. Here it wants us to shut down the virtual machine before beginning failover. It's turned on to do that. It's checked on automatically. So we're going to run an actual failover test. So I'm going to go back to test failover. We'll do this again. So I'm going to leave it on the recovery point that's selected, the latest. I'm going to choose the target virtual network in the target region, and I'm going to click OK. In the notification bell icon in the upper right of the portal, we can see it's starting the test failover of our virtual machine, DC1. We can see next to the status when we're looking at the replicated items section of our virtual machine that the status reports completing test failover. And that's actually a link, so I can click on it to check it out. So we can see here it's done the prerequisite check for the test failover, created the test VM and prepared it and started it. Those are all listed as being successful. If I go over to the right a bit more, I can see the target VNet name and the target virtual machine name, which will be the same as the original virtual machine name DC1, but it will be suffixed with -test. If I open up another tab in my browser and view my virtual machines, we can see indeed there is a new virtual machine shown here called DC1-test. We can see the resource group association, and we can also see that the status is that it's running. So when you're testing failover, what you're making sure is that this gets to this point, so the VM is running, and that you can actually connect to it. So whether you're connecting to it through RDP or through some other means, make sure it is working and it's valid. Now, back where we're reviewing the status of going through the test failover, there's a message at the top that says it's completed. To delete the virtual machine after you've tested its connectivity, use the cleanup test failover option. Okay, so I'm going to close by clicking the X. Then you might have to click on something else and come back to the overview blade of your virtual machine for replicated items. But once you've done that, you'll see that the Clean Up Test Failover button has become available. Now notice some of the other buttons are grayed out. If you do a real failover, you can commit to it so that it's the active and the primary configuration for the VM, and you can even resynchronize it to reprotect it back to the source or primary location. So we've got a couple of options here for commit, resynchronize, and reprotect up at the top. Here, I'm just going to click Clean Up Test Failover. I don't have to enter any notes here. I'm going to choose Testing is Complete, Delete Test Failover Virtual Machines, and I'll click OK. We can track the status of Cleanup Test Failover Pending. It's a link by clicking on it to view the details. There are times when you may want to disable replication of an Azure VM to a secondary region. Now, initially, you would set that up to achieve high availability in case there was a disruption in the primary active region. However, maybe if the virtual machine is going to be decommissioned, you might want to go ahead and disable replication. So to get started here in the portal, I'm looking at the properties of an existing virtual machine named DC1. And if I scroll down in the navigation bar to the operations section, I'll see disaster recovery. Now, this is where you would normally set up VM replication to a secondary region. Because it's already set up, we're going to see some statistics about that replication. So we can see it's healthy, the status is protected, and so on. So one of the things we could do here at the very top is click the context menu, the More menu. It looks like 3 dots. And I have the option here of disabling replication for this VM. You can do it from here, but you can also do the same thing from the perspective of the Recovery Services Vault where the VM is protected. So I've got that open already here in another web browser tab. I've navigated to a Recovery Services Vault where this VM has been registered for protection. And if I scroll down in the navigation bar and go to Replicated Items within the vault, on the right, I can see we've got our virtual machine DC1, and it's listed as healthy, it's protected, and so on. Well, if I go to the right of that listing for that virtual machine and click the context menu, from here I can also disable replication, which I will do. I'm going to go ahead and choose Disable Replication. Now we're going to have to select a reason as to why we're doing this. I'm only going to turn the check mark on for the first one. I'm doing a proof of concept or trial with Azure Site Recovery. And it asks, are you likely to use Azure Site Recovery in the future? Oh, yes. I'm going to choose yes. And then I'm going to go ahead and click on OK. And we can see in our notification icon in the upper right, it's removing the replicated item from the vault. We could also use PowerShell if we so chose. So for example, I'm going to launch the Cloud Shell here within the Azure portal. So what I could do is run get-command, and then I'll use a wildcard asterisk. Actually, I'll start with the word remove. I'm guessing that the verb part of the PowerShell commandlet starts with remove, asterisk, and I'm just going to search for a protected item. Again, I'm making a few guesses here. And you'll notice here that we do have a commandlet named remove-AZ Recovery Services ASR replicated protected item. The name of the commandlet is so long, it's difficult to see, but we can get help on it. So for example, if I were to run get help on remove-AZ recovery, it's a long one, recovery services ASR, that's Azure Site Recovery, replication, protected item. That's a mouthful. So we can see that we've got a help screen for it where we can see the syntax. And if we really wanted to, actually, let's clear the screen. And I'll use the up arrow key to bring up that command, the get help command. We could also ask for details. So -detail, and I'll pipe that to more to stop after the first screen full. Now we've got some detail about each and every individual command line parameter and what it should be expecting in terms of data. We can also see we've got an example of actually how to work with this. And in the upper right, if I just minimize the Cloud Shell and go back in our notifications, we can see that it removed the replicated item. So it successfully completed the operation. So here in the recovery vault, let's just go ahead and refresh the list of replicated items, and now it says no replicated items found. In order to use the Azure VM Update Management feature, you need an automation account, and that automation account needs to be linked to a log analytic workspace. So here in the portal, I've filtered my All Resources view to show me objects of type automation account. And I've got one here called Automation 173. I'm just going to go ahead and open that up. And I'm going to scroll down in the navigation bar for it until I get down to Update Management. I'm going to click on Update Management. I'm going to have to configure this. At this point, I can see it's going to select the Log Analytics Workspace location, and it's grayed out. That's the region in which this automation account was deployed, Canada Central. Then we have to select a Log Analytics Workspace subscription. Well, I only have one subscription here. And then we can either select an existing Log Analytics Workspace or create a new one. Now, if you select an existing one and it's already tied to an automation account, it will tell you as much. So in this case, I'm going to go ahead and click Create New Workspace. And then I'm going to choose the Enable button at the bottom. After a moment, it's done, and we have a message at the top that states that the update management solution was enabled, and that we should reselect the menu item to open the solution. So on the left, I'll just click on something else here, like Run Books. I'll choose OK, and then I'm going to go back and click on Update Management. Now this time, we see something different because we've linked the automation account to a Log Analytics Workspace. So what we need to do here is add machines. We don't have any machines here, so therefore we can't proceed with applying missing updates and creating deployment schedules and so on. So at the top, we can either add Azure VMs or add non-Azure machines. I'm going to choose Add Azure VMs. So the next thing we would do is scroll down and select a virtual machine that's ready for this, one that's up and running. We've got some that are stopped, so they can't be enabled. And if you already have some that are already enabled, perhaps linked with Update Management to a different automation account, they'll show up as already enabled. Otherwise, you put a check mark by the virtual machine or virtual machines that you want to add, and then you click the Enable button. Okay, so now that we've got our Azure Virtual Machine added for Update Management, it shows up in the list here under Machines. We can also go to the Missing Updates link here and get a sense of any missing updates that might apply. So we have two updates listed here. We see the classification. One is updates, one is definition updates for Windows Defender antivirus. And we can see that machines missing updates, we've got a 1 in that column. So if I click on either one of those to open it up in further detail, what it's going to do is take me directly into a query in a Log Analytics Workspace. Remember that when you enable Update Management in the automation account, you've got to make sure that you link the automation account to a Log Analytics Workspace. At any rate, it's added this query at the top for me, which is good. I wouldn't want to type that out myself. And down below, I can see the result of having run that query. So I can see the DC1 computer here that we have added, the virtual machine. And as we scroll over, we can see the update listed here. And under the update state, it's currently listed as needed. So I'm going to go ahead and close out of this Log Analytics Workspace query by clicking the X in the upper right. That'll put us back here under Missing Updates. Now, if I go to Deployment Schedules, we don't have one. So the next thing that we could do is schedule the deployment of updates to any added VMs that need them. So to do that, I would click the Schedule Update Deployment button up at the top. And then fill out a couple of details. I'm going to call this Deploy 1. It's going to be for Windows. And I can specify down below the groups that I want to update. So I'll click on that. Now, these would be groups of VMs, or instead of groups to update, I could click on machines to update if I want to go through and add them individually, which I'm going to do here. Down below, I'm going to click Machines to Update, and when I click on that, in the blade that pops up on the right, I'll choose the Microsoft default computer group, and I'll click OK. Next thing I have to do in this update deployment is determine the update classifications I want included. They're all selected by default: critical updates, security updates, update roll-ups, feature packs, definition updates for Windows Defender antivirus, and so on. I want them all selected. Although I could include or exclude specific updates. We do have that option. I'm going to click on Schedule Settings down below that. So here I can specify the date, time, and time zone, whether it's a one-time update or whether it should be recurring. I'm going to accept all the defaults, including the fact that it's a one-time recurrence. Then I'll click OK. And I don't have any pre or post scripts I want to configure. I'm not going to set a maintenance window time limit. And for reboot options, I'm going to leave it on the default of reboot if required. If you've worked a lot with update management, you'll know that there are some cases where updates that have been applied require a system reboot. So we're going to leave that as it is, and I'll click Create to create the deployment schedule. We can see it shows up here under Deployment Schedules when we're on the Update Management blade. It's shown down below, and we can see the recurrence is one time. In this case, it knows that the scope is for one virtual machine that would have been that default group called DC1. Now we can see that for missing updates, we've gone from 2 to only 1. And we can see which update is still missing. We can also take a look at the history area here by clicking History. We can see that we still have some time left in the maintenance window for this update deployment to complete. And we can see the start, date, and time for it. Of course, if we go to Deployment Schedules, that was our Deploy 1 deployment schedule. So therefore, we can use Azure and the automation account with the update management feature to manage updates for Azure VMs. There could be times when you have a need to move a virtual machine to a different subnet or a VNet for disaster recovery purposes. Let's examine this first in the portal by opening up an existing virtual machine. Now, when you open up a virtual machine, you then have the option of going down to the networking section. And in the networking section, what we're primarily interested in is the network interface for the virtual machine. So I can see it's a link over on the right-hand side. I'm going to click on it. When you look at a network interface, you can then click on IP configurations in the left-hand navigator. And notice on the right, you can change the subnet in which that network interface belongs. Now, but that's still going to be in the same virtual network shown up above. What do you do if you need to move really this virtual machine to a whole other VNet? Well, the only thing you can really do, other than recreating everything completely from scratch, is deleting the virtual machine, which keeps the OS disk, and then you could build a new virtual machine in the VNet using that existing OS disk. So we're going to go ahead and examine that. So let's close out of our IP configuration. We're back in the virtual machine's details, where if I click on disks, I'll see the OS and data disks. Now, we don't have any data disks, but we do have an OS disk that starts with the prefix of WinServe 2016-2, disk 1, and so on. So having said that, let's scroll up to the overview blade for this VM, because what we're going to do is delete it. Now, we would do this because we're okay with deleting the Azure virtual machine configuration, knowing we can recreate a new VM using the OS disk. So I'm going to click Delete, and I'm going to choose Yes. After a moment, in the notification area in the upper right of the portal, we can see it successfully deleted the virtual machine. So I'm going to go to the Home link in the upper left here in the portal, and I'm going to go open up the navigator on the left and choose All Resources. I'm going to go to the All Resources view so we can check out only disks that are left over. So I'm going to uncheck Select All, and what I'm interested in looking at here are disks. So I'm going to select Disk, I'll click outside of that to put it in effect, and notice we still have our WinServe 2016-2 disk 1. We still have that disk. So I'm going to go ahead and click on that disk. Now in the Overview blade, we will have the option of creating a VM. There's a button at the top labeled as such. So I'm going to click the Create VM button. So creating a VM using this as the OS disk. So I'm going to go ahead and tie this to a resource group, and I'll scroll down and give this a name. Just going to call this server 2. And notice for the image, it's already got my Windows Server disk listed here. So it knows which disk image to use because of how we've begun the creation of this VM. So I'm going to go down. I can select the size. So I'm going to go ahead and select the size that will support my workload in the VM. So let's say one that has 4 vCPUs and about 16 gig of RAM. So I'm just going to go ahead and select that. Going to click Next Disks down at the bottom. So we've already got our disk set up. I don't need to attach any additional data disks. So I'll just click Next Networking at the bottom. Now, this is the whole purpose of our discussion is at this point, we get to determine which VNet we want this placed in. So I'm going to choose, let's see, VNet 2, subnet 1. We'll let it build a new server IP, public IP, and I'll accept all of the other defaults. And really, there's nothing else I'm going to change here. So I'm just going to go ahead and click Review and Create in the bottom left, and we'll let it make sure it passes the validation. In the upper left, we've got validation passed. So in the bottom left, I'm going to click the Create button. And before you know it, the deployment is complete. Let's click Go to Resource to check out our newly created VM. So it's called Server 2, and we are now looking at the properties of it, the navigation bar for it. And if we scroll down and go to Disks, we can check out the disk layout for this VM. Sure enough, it is using our old virtual machine disk. And if we click on the networking link on the left, we'll be able to check out the network association for the VM. And we see here on the right that it is in VNet 2, subnet 1. In this demonstration, I'm going to enable Hyper-V Virtual Machine Backup using an Azure Recovery Services Vault. So to get started, here on my Hyper-V host, I'm just going to go to the Start menu, go to Windows Administrative Tools, and I'm going to fire up the Hyper-V Manager just to see what we've got to work with. So we've got one virtual machine named Sample VM. It's currently off. We could turn it on if we wanted to by right-clicking and choosing Start. So we've got a single VM running on a Hyper-V host that we want protected by backing it up to Azure through a Recovery Services Vault. So here in the portal, I've opened up the properties of an existing Recovery Services Vault. So in the navigation bar on the left, I'm going to scroll down under the Getting Started section, and I'm going to choose Backup. From here, where it says, where is your workload running? From that drop-down list, I'm going to choose On Premises. And for what do you want to back up? From that drop-down list, I'm going to go down and choose Hyper-V Virtual Machines. Then I'm going to click Prepare Infrastructure. Now, the first thing it's going to prompt me with is downloading the Microsoft Azure Backup Server program, because we're talking about an on-prem server. Whereas if we had selected files and folders on-prem that we wanted to back up, instead we'd have to download and install the Microsoft Azure Recovery Services agent. But in this case, it's the Microsoft Azure Backup Service. I'm going to go ahead and download that agent. And on the page that opens up, I'll click the Download button. So I'm going to turn a check mark on at the very top next to file name, which selects all of the required installation files here. So it's about 4 gig in size. Then I'm going to go ahead and click Next and download these files. Once the files are downloaded, I'm going to right-click on the installer and Run as administrator. And then I'm going to go through the wizard. I'll start by clicking Next. I accept the agreement, and I'll click Next again. I'm going to accept all of the defaults, and then I'll click the Extract button. And before you know it, it's ready to go. So I'm going to click the Finish button to complete that part of the installation of the Azure Backup Server. Next, I'll navigate on drive C to the default folder location where the extracted setup files now exist. I'm going to go into that, go into the folder structure until I can locate the setup exe. So I'm just going to right-click on that, and I'm going to go ahead and choose to run that as administrator. So at this point, we're at the Microsoft Azure Backup Server installation screen. So I'm going to choose to install Microsoft Azure Backup Server. So that'll start the Azure Backup Server setup wizard. So I'm going to go ahead and click Next on the first part of that installation. And I'm going to click the check button to check for prerequisites. It then says the computer meets the software and hardware requirements. Perfect. Click Next to continue, so I'll do that. So I'm going to have to install a new instance of SQL Server with this setup because Azure Backup Server uses a SQL database. So I'm going to click Check and Install. So it says the computer meets the software and hardware requirements. Now, what that includes is making sure the .NET framework is installed and that this server is joined to an Active Directory domain, which it is. So I'm going to go ahead and click on the Next button. Then we're on the SQL settings page where we have some directory paths, and we also have the space requirements listed. I'm all good with that, so I'm going to click Next. And then it wants me to specify and confirm a password for the backup server. Once I've specified that, I'll click Next. I'll tell it I want to use Microsoft Update for updates. I'll click Next, and I'll click the Install button. So the Microsoft Azure Backup Server is on its way. And on the final screen, I will click Install. After that completes, I will click Next because I need to proceed with registering this host with a vault. So I need a vault credentials file. Back here in the portal where we started off with downloading the Azure Backup Server files, in step 2, I'm going to turn on the check mark, already downloaded or using the latest Azure Backup Server installation. So we've done that. And I'm going to click Download to download the vault credentials file. And I'm just going to make sure I save this file where it can be accessed by my backup server. Back here on my backup server, I'm going to browse for that file by clicking the Browse button. And we can see it knows the details about the Recovery Services Vault. So I'm going to go ahead and click Next. We'll let it generate a passphrase, and I'll specify a location to save the passphrase file. The passphrase is going to be used to encrypt backups. And we can now see it's in the midst of registering the server with Azure Backup in the cloud. After a little while, we'll see it will have installed the SQL Server components and the Azure Backup Server. So we can see that the Data Protection Manager installation succeeded. So I'm going to go ahead and click on Close. So it says it's been installed, but you need to restart the computer to complete the installation. Okay, no problemo. So I'm going to go ahead and restart. After I log back in, I've got two icons on my desktop that are a result of the installation. The first one is to run the Backup Server Management Shell for Azure, and the second icon is just to run Microsoft Azure Backup Server, the GUI. So I'm going to go ahead and double click on it. Now, if you've got experience already using products like Data Protection Manager or DPM, then you'll be familiar with the interface. In order to work with this tool, if we look at the Management tab, which is selected down at the bottom, we can see on the right it says there are no computers with agents installed. To install agents, click Install. Well, what I'm going to do up here is I'm going to click the Add button. And from here, I'm going to add Windows servers, so I'll click Next. I'm going to choose Install Agents, I'll choose Next. And I'm going to choose a server here within my Active Directory domain. And I'm going to select that, and I'll click Next, and I'll specify the credentials. After entering the credentials, I'll choose Yes, restart the selected computers to install the protection agent if required, and then I'll choose Next to continue, then I'll choose Install. And we can see now that the results are showing that the installation of the protection agent on that server, DC1, succeeded. So I'm going to go ahead and click Close. We can see DC1 is now shown here in our Microsoft Azure Backup Server GUI under the Management tab. Once you've got the Microsoft Azure Backup Server installed and linked or registered with your Recovery Services Vault, the next thing to do is to make sure it's got some disk storage space for backup of items, whether it be files or virtual machines, SQL databases, whatever it is. So to get started here, I'm going to go and double click on the Microsoft Azure Backup Server icon. Here what I want to do is add some disk space that's available on the server. So if I don't have any disk space available, I'd have to acquire it either over the network or plug disks in, whatever the case might be. So to add the disk space, here in the Management tab, which I've selected in the bottom left, I need to click Disk Storage in the left-hand navigator. I'm going to click on that, and then I'll click the Add button up at the top, where I've got a drive letter E here with some free space. I'm going to click Add to add it to a storage pool. It says Data Protection Manager or DPM will format it. That's normal. I'm going to choose yes. And I'm going to call it Backup Vol1 for the friendly name, Backup Vol1. And after I've done that, then I'm going to go ahead and click on OK. Even though you're going to be backing up to Azure, as in an online backup, you still need some local backup storage space as well. So now I'm going to click on Protection in the bottom left area, so open up that tab, and then I'm going to click the New button up in the toolbar up at the top to build a new protection group and to go through the wizard. So I'm going to go ahead and click Next. I'll leave it on Servers, and I'll click Next. We're then presented with a list of servers that are joined to the Active Directory domain that this Azure Backup server is a member of. And I can drill down by expanding each server to see what's available on it to be backed up or protected. Whether it's shared folders, or in this case, I've got all SQL servers because I've got a SQL server running on a host. And if I drill down under that, I can see databases. If I've got Hyper-V running on this host, which I do, I can also see that it will show me the virtual machines that are available, or I can back up the host component for Hyper-V. So all of that stuff is available on the host that we drilled down under. We can also see the shared folders. We can also go under System Protection, and we can do a bare metal protection for bare metal recovery or system state to the Azure cloud. I'm going to expand all volumes on one of the servers in the domain. And let's say, drill down under Drive C. Maybe I'll just select the perf logs folder to back it up. So I'll choose Next. It wants to call this protection group 1. That's fine. We are going to have short-term protection using disk. So that's on premises in our server, but we also want online protection. Now, I can uncheck that, but it's checked on by default. That means we also want to back it up to Azure. So I'm going to go ahead and click Next. I'll accept the default retention range. I'll click Next. It's calculated the amount of space needed and the target storage, at least locally, that's the on-prem storage, a volume here called Backup Vol1. I'll go ahead and click Next for that. I'll keep continuing through the wizard until I get to the Choose Replica Creation Method screen that asks me to select the data source for online. So I'm going to select that I want to back up the perflogs folder on Drive C. I'll put a check mark by that, and I'll click Next. And then we're going to schedule this backup, let's say every day. We can do it a maximum of twice a day, but I'll leave the default of once at 9 p.m. I'll click Next. I'll accept the defaults for the weekly, monthly, and yearly retention policies. I want to back this up over the network to the Azure cloud as opposed to an offline backup. So I'm going to go ahead and click Next. And finally, I'll click the Create Group button. We can see under the results column, all of the tasks are currently in progress. Creating the protection group, allocating a replica for Drive C, and updating the online backup policy relative to Drive C. Now they all show success. So I'm going to go ahead and click Close. Now in the right-hand panel of the screen, we have our protection group listed, and I can see that the protection status here is that the replica creation is currently in progress. Now that's a local replica for local backup purposes. Once that's done, we're going to right-click on it and we're going to enable a backup to the Azure Online environment and check it out from there. And we can now see after a moment the protection status is shown as OK. So I'm going to right-click on our protection group item, and I'm going to choose Create Recovery Point, and I'm going to choose Online Protection in the Create Recovery Point 4 drop-down list. Then I'm going to click OK. And we can see it's creating an online recovery point for what we're backing up from Drive C on premises. The results column currently shows in progress, so we're going to wait and bide our time until it's completed. And it won't take long before the results show success. So we've created our online recovery point. I'm just going to go ahead and close that out. Now, if we were to go to Recovery, so the Recovery tab in the bottom left, I'm presented with the calendar on the right, and any recovery points will show in bold. So I can go ahead and select that, and then down below in the bottom panel will be listed any recoverable items. And we can right-click on those and choose Show All Recovery Points. I'll choose Yes. It just gave me a warning saying it might take a while. Well, we can see that we've got some recovery points for disk on premises, but also online. Now, if I were to right-click on my recoverable item in the bottom panel and choose Recover, then we could click Next. recover to the original location, and just continue on specifying the recovery details. So we would be recovering, for example, from a specific source to a destination, in this case, drive C. The recovery media in this case is showing as online, so we can not only back up to Azure, but of course restore from it using our Azure backup server on premises. Now, from the perspective in the portal of the recovery vault where that Azure backup server is registered, in the navigation bar, I'm going to go down and click on Backup Infrastructure. Then I'm going to click on Backup Management Servers. So here I see our backup management server is shown here. If I click on it to open it up, we'll get a few little details. We'll have a sense of if anything is even stored here. And it looks like we've got one disk here that is showing up. This is disk utilization here, really refers to the online disk space available for our backup server. Now that is actually on premises, but we can see that we also have a count here for backup items. When I click on the link for the backup items, it'll show me what has been backed up to this recovery services vault in the cloud from my on-premises Azure backup server. Now, it might be out of date, so you might have to wait a little while to see the latest items that are stored here. But this is how we can integrate an on-premises backup solution with cloud-based backup storage. So in this course, we've examined the use of Azure Recovery Services Vaults, Azure Backup and Azure Backup Server, VM failover, and update management as methods for recovering from service disruptions or disaster. We did this by exploring disaster recovery terms as they are related to Azure. We looked at the use of Azure Site Recovery. We looked at how to use the portal and PowerShell to create a recovery services vault. We looked at Azure Backup Cloud options. We looked at how to back up an Azure VM, back up on-premises files to Azure, and restore backed up files from Azure. We looked at how to enable Azure VM replication and run a VM failover test and then execute cleanup. We looked at how to disable VM replication and also how to configure Azure VM update management. We learned how to reuse VM OS disks, and finally, how to install and use the Microsoft Azure Backup Server. In our next course, we'll move on to explore how to secure and manage Azure resources using role-based access control or RBAC and policies, including assigning Azure AD roles and policies, looking at the role of management groups, and finally, we'll look at the purpose of Azure blueprints. You can control what kind of access is granted to Azure resources using role-based access control, otherwise called RBAC. So it works well for delegated access control. This means that you might have additional Azure technicians or administrators that require limited, so not full, access to manage Azure resources. That's exactly what RBAC is for. There are built-in roles that you can use, and a role is really just a collection of permissions that are related, or you could build your own custom roles if the built-in roles don't suit your needs. So here we see some examples of some built-in RBAC roles, such as owner. This role has full control of the resource, whether that resource is a virtual machine, a storage account, or maybe the owner role was granted to a subscription, which means it flows down to everything in the subscription, or maybe to a resource group. It applies to everything in the resource group. The contributor role provides control over the resource, full control other than changing RBAC settings. Reader means read-only access. Then you have very specific RBAC roles for different types of Azure services. So for content delivery networks, as an example, you'll see the CDN endpoint reader, so read-only access for network endpoints related to the CDN. There's a cost management contributor to read and write Azure cost configs, including working with budgets. There's the virtual machine administrator login, which allows the reading of VM properties in the portal and then logging in with admin creds. There are many, many other built-in RBAC roles, but this is just a tiny sampling to give us a taste. Now, we mentioned that you can build custom RBAC roles, and to do that, you need to create a JSON role file. This is a definition file. It's just a text file, but it does use JSON syntax to define the role and which permissions are within the role. So the next thing you can do is create a custom role from that custom role definition file. You can do that, for instance, using PowerShell with the new -az role definition commandlet, or you might opt to do that using the CLI with the AZ role definition create syntax. Well, yeah, but what does it look like? What does the custom role file actually look like? It looks like this. We can see, because it's JSON syntax at the top, we have an open curly brace, and at the very bottom, a closing curly brace. We can see the name of the role here. So after name in double quotes, we have a colon, then the value for that item. And that's how JSON syntax works. So the name here is custom VM role. And at the end of that line, outside of the double quotes, we have a comma. We move on to the next attribute. In this case, it's ID. Once again, ID is in quotes, there's a colon, and in quotes we have the value for ID, comma, and so on. Notice the third line is custom. So this is a custom role. It's set to true. Then we have the actions section. So the actions section lists the permissions that are a part of this role. So for the Microsoft.storage provider, we see /*/read. That allows the reading of anything related to Microsoft storage. Same goes for Microsoft.network as a provider, Microsoft.compute. We can read all of those things, but for Microsoft.compute/virtual machines /start/action, we've got that enabled. That's one of the permissions, so the ability to start a VM, and below that, the ability to restart a VM. So there aren't any not actions listed. All we've opted to do here is specify what can be done. Now, the RBAC roles can be assigned to users in Azure AD, or groups, or service principals. A service principal is used by software to access a resource. So we can assign very specific permissions, for example, for a specific software component. But then you can also assign roles to a managed identity. And a managed identity would apply, for example, to a resource like a virtual machine. So you can either have a system assigned one, or you could define your own. Either way, the managed identity in our example tied to a virtual machine could be granted permissions to access other Azure resources, let's say a storage account. That would mean any code that we have running within that VM would have the ability, based on the roles that are assigned to the managed identity, such as the ability to read a storage account. That way, as a software developer, you wouldn't have to put the credentials to access that storage account in your code. It's handled more externally at a broad level to the virtual machine managed identity. The next consideration is the scope where the RBAC assignment will apply. You can do this at the subscription level, which means that the role assignment would apply at the subscription and everything under it, which is everything in Azure, all resource groups and all resources within resource groups. But there might be times when you want to set the RBAC assignment scope only to a particular resource group, maybe to allow a team to administer VMs in only a certain resource group. So it would flow down to the resources in the resource group. And at its most granular, you can set the assignment scope at a particular resource. So if I have a user or a group of users that need specific permissions to one storage account, I could assign it to that specific storage account. The assignment scope would be that particular resource. Here we see a screenshot. It's a resource group, as we see in the upper left, called RG1. And what's been opened up here is the Access Control IAM blade, where IAM stands for Identity and Access Management. So let's look over to the right. The first thing I see is a role called Network Contributor, and it looks like there's a group called Central Region, presumably Canada, and the Network Contributor role was assigned to this resource, it says. So to this resource group. So that means that the members of the Central Region Canada group would have network contributor permissions for everything in RG1. Down below on the right, we see the owner RBAC role. It's been granted to the Azure_admins group in Azure AD, and it's set at the subscription level. We can see that in the far right. It says subscription and in parentheses, inherited. So it was set up at the subscription level, but it's flowed down and is therefore applicable at this level, the resource group. In this demonstration, I'm going to use the portal to create an Azure RBAC role assignment. Now you can assign role permissions at a scope of the subscription level, so it flows down to everything in Azure in that subscription, or to a resource group, where it applies to everything in the resource group, or to an individual resource. I'm going to do this at the subscription level. So here in the center search bar at the top of the Azure portal, I'm going to search for sub, and I'm going to click subscriptions. Now in here for my Azure AD tenant, which is shown by name in the upper right, I can see that I've got one subscription. It's a pay-as-you-go subscription. So I'm going to go ahead and click on it to open it up. Now, when you open up a resource in Azure, in this case, it's a subscription, but it just as well could be a resource group or a specific resource like a virtual machine, storage account, and whatnot. When you open it up and you see the navigation bar, you'll always see Access Control IAM. That's where you need to go to work with role-based access control. So I'm going to click on that. Now, the first thing I can do is add a new role assignment, which I'm going to do here. So I'm going to click Add, and then I'll choose Add Role Assignment, and that opens up an Add Role Assignment blade that pops up on the far right of the screen. The first thing I have to do is select the role. Remember, a role is just a collection of related permissions. So what kind of role do I want to assign here? I can open up the drop-down list. Of course, I can also type in it to filter out the list of roles. So here I see a list of roles. If I'm interested, let's say, in storage type of roles, I can start typing in STOR, and it filters the list. So let's say I want to give the ability for a group to work with storage blobs, to upload storage blobs to a storage account and so on. So I could choose Storage Blob Data Contributor. Now the next thing I have to do is assign access to a specific type of security principal here. I'm going to use a group. So let's say, for example, I search for team and I choose the Team 1 group. So members of the Team 1 group will have the Storage Blob Data Contributor permission assigned here at the subscription level, which means it applies to all storage accounts in the subscription. If you only want it applied to one storage account, then do what we've just done, except at the individual storage account level. Let's take a look at this. I'm going to click Role Assignments at the top so we can take a look to see if our work has been saved. I'm going to scroll down a little bit so I can see the Storage Blob Data Contributor role is shown here, Team 1. It's been assigned to Team 1, which is a group, and it's been assigned at this resource level. Well, in this context, this resource means our pay-as-you-go subscription. So let's do the following. Let's open up in the left-hand navigator our resource groups view. I want to take a look to see what the implication of having a subscription level RBAC assignment is at resource groups within that subscription. So I'm going to open up an existing resource group, and I'm going to click on the same thing we did at the subscription level. In the navigation bar on the left, I'm going to click Access Control IAM. And over on the right, I'm going to click the Role Assignments tab, and let's take a look at what we've got here. I'm curious to see if the Storage Blob Data Contributor role is here, and it is. There it is, Storage Blob Data Contributor for Team 1, the group. However, for the scope column, it says Subscription Inherited. So it was inherited from the subscription level, but it still applies to this resource group and everything in it. In the exact same way, let's just navigate to our storage accounts view, and we're going to take a look at any storage account that we might already have in existence. So I'm going to click to open up a storage account, and in the navigation on the left, I'll click Access Control IAM. Now, while we could click Add to add a role assignment that only applies to this individual storage account, what we're really here to do is click Role Assignments to view what is effective, including what might have been inherited from up above. So I'm going to scroll to the right. If I scroll down, notice that we've got the Storage Blob Data Contributor role for Team 1, and it was inherited from the subscription level. So it flows all the way down to every resource in the subscription. You can use the Azure CLI to manage your Azure AD role assignments. To get started here in the portal, I've navigated to my Azure AD tenant, and I'm going to go into the user's view. I want to check out an existing user that we can use as an example to assign role permissions to. So I've got a user here called Jen Hill. We can see the username or the email address is quick24x7test.onmicrosoft.com. Perfect. That's all we need to know at this point. I'm going to click on the Cloud Shell icon at the top center to launch Cloud Shell, where we can use the CLI to create a role assignment. My Cloud Shell has timed out since I last used it, so I'm going to click the Reconnect button. So in this example, I'm going to use the AZ role assignment create syntax. So specifically, AZ role assignment create --role. Now the role I want to assign is called SQL DB contributor. So I have to know that. I've placed that role name within double quotes. Next, I'm going to use the --assignee parameter. And as a value, I'm going to specify Jen Hill, the user we looked at. I'm going to place her email address here for the value of that. Next, I'll use --resource group. And I'm going to specify that I want to set this at the resource group scope for user J Hill. So the resource group is called RG1. I'm going to go ahead and press enter to complete that assignment. And it looks like it's good to go. Now we can verify this in a few ways. I'll just clear the screen. Actually, why don't we minimize Cloud Shell? Back here in the background in the portal, I'm looking at my resource group RG1. I'm in the access control IAM blade, and I'm already looking at the role assignments. So let's just go ahead and click refresh to see if Jen Hill shows up here with the SQL role that was assigned, and it looks like it's there. SQL DB contributor for Jen Hill. Now let's go back into the Cloud Shell, because what we can also do is we can view the role assignments at a given scope. For example, here I'm going to use AZ role assignment list --resource group RG1. So I want to look at it from the RG1 resource group perspective. Indeed, we can see user J Hill is listed here with the SQL DB contributor role. Now we can not only set and view role assignments in the CLI, but we can also remove them. So to do that, I'm going to use the following syntax: AZ role assignment delete. So I have to specify the assignee. Whose role assignment am I changing here? Well, --assignee, I'll specify a value, which is the email address for user Jen Hill. I want to remove her assignment. Well, for which role? She might have many roles assigned. Well, --role allows me to specify that. And in double quotes, I'm specifying the SQL DB contributor role. Finally, I have to just specify the resource group where that permission was applied. So --resource group RG1. Let's go ahead and press enter to see what we get. Well, we get nothing, but in this case, no news is good news. Let's use the up arrow key to go up to our AZ role assignment list command, where previously it reported back that Jen Hill had the SQL DB contributor role for resource group 1, RG1. Now we get a whole lot of nothing. And so if I were to minimize the Cloud Shell and refresh our screen here in the portal where we're looking at the role assignments for the resource group, notice that Jen Hill is no longer here with the SQL DB contributor role because we just removed it using the CLI. In this demonstration, I'm going to be using PowerShell to add an RBAC role assignment. I've launched the Cloud Shell here within the portal. So to get started, I'm going to use the new -AZ role assignment commandlet, and I have to give it some parameters. -signin name is one of them, where I'll specify the email address, in this case of an individual user, that I want to use for the role assignment, user J Hill. Then I have to specify the role I want her to have. So I'll use -role definition name, and in quotes I've specified SQL DB contributor. Now you can assign roles, or you can scope them out rather, at the subscription level. You can make it applicable at a resource group level or at an individual resource itself. So subscription resource group resource. In this case, I want the SQL DB contributor role for J Hill to be applied to a resource group called RG1. So the last parameter I have here is -resource group name, and the value of that is the name of the resource group, RG1. So I'm going to press enter to put that into motion. Now we need to be able to check our work. Of course, we could do it using the portal. So for example, I could minimize Cloud Shell, and back here in the portal, I'm looking at the access control IAM blade for RG1, and there is no assignment here for Jen Hill for the SQL DB contributor role. So if I refresh it, because we just set it from PowerShell, well, when we scroll down, we're now going to see Jen Hill is listed with the SQL DB contributor role. Certainly we can do that. We can view that information from here in PowerShell. We can do that using the get-AZ role assignment commandlet, -resource group name, RG1, -signin name, the email address of the user. That's it. Let's see what roles she was given at that level. So we can see user Jen Hill was given the SQL DB contributor role at the resource group RG1 level. We can also remove that assignment using PowerShell. To do that, I'm going to use, well, let's clear the screen here to update the display. To do that, I'm going to use the remove-az role assignment commandlet. -sign and name is the email address for the user whose role we want to remove. -role definition, because she might have many roles assigned at that level. So with -role definition in quotes, I'll specify the role name of SQLDB contributor. -resource group name is our G1. Let's go ahead and press enter. Won't take long. And then we should use our up arrow key to go back to the get-az role assignment statement, because that showed us before that Jen Hill had the SQLDB contributor role for resource group 1. And if we run that again, we get nothing because she's been removed. When the built-in Azure RBAC roles don't suit your needs, you can create your own custom role definitions. And when you do that, it's just a text file that uses JSON syntax. Now you can use tools like WordPad or Notepad, or in my case, Microsoft Visual Studio, if you want to be able to create, edit, and or view those custom role files. So let's take a look here at Visual Studio. I've got a role, and the total role file is really only 8 lines long. This is a simple one. So in line 1, we've got our open curly brace, and in line 8, we've got a closing one, and within which we'll find the definition of our role. This is JSON syntax. So for the name of the role, I'm calling it Network Resource Viewer. Now, JSON syntax dictates that we have, in this case, the name item listed within quotes, colon, followed by the value. Next, we have the is custom item, and it's set to true. It's a custom role. I've got the description here. It says allows reading Azure Network Resources. And under actions, what I've put here is I've specified the Microsoft.network provider /*. So for all types of Azure Network components, /read. They will be readable. There are no not actions defined. And I've got the assignable scope here set to my subscription ID. So that's my definition of my custom role that's called Network Resource Viewer. Now to create that, I'm going to use PowerShell. So here in the portal, I've clicked the Cloud Shell icon, and I'm in PowerShell. I've typed dir because I've uploaded using the Upload Download Files button in the bar here at the top. I've uploaded the Create Custom Role JSON file that we were just looking at. So the file's available here in the Cloud Shell. So to build the role, I'm going to first clear the screen. I'm going to run new-az role definition, because that's what we're creating here. -input file is the parameter, and for the value of that, I'm going to specify the name of our custom role file. So I'm just going to make sure I spell it out correctly. I've typed in the first couple of letters because I'm in the current directory with it. First couple of letters that uniquely identify that file name, and I've pressed tab, and through the magic of tab completion, it spelled out the whole thing for me. Couldn't be easier. That's it. That's all I need to do. The hard part of this is making sure that your custom role JSON file is correct. So I'm just going to go ahead and press enter. Looks like it's good. Now let's just verify that. Why don't we just run, for example, get-az role definition. And I'm just going to press enter. Now we can see that that's quite the large list. So what I'm going to do is just clear the screen again, use the up arrow key to bring up that command, get-az role definition. I'm going to pipe that to select, and I'm going to tell it I only want the name property. The only problem with this is it's kind of a long list, but it's also not alphabetized. So I'm going to clear the screen again, use the up arrow key, and we're going to pipe what we currently have here with get-az role definition, pipe select name. I'm going to pipe that further. No one said you were limited to piping only once. I'm going to pipe that to sort. Well, it didn't like that. I'm just going to change sort to lowercase here, and now it's functioned. So let's just kind of scroll back up. Now it's all alphabetized, so we can quickly, of course, we can do it other ways, but we can quickly look at the ends, and we'll see that we've got our new role showing up. So here in the ends, I can see Network Resource Viewer. Before jumping into management groups, it's first important to understand the relationship between Azure AD tenants and Azure subscriptions. So the Azure AD tenant shown here on the left is used for authenticating. We can create user accounts, organize those users into groups. We can register devices, whether they're mobile devices or laptops. with Azure AD, so we have central configuration control. Now, what we're seeing in the diagram to the right is that we can have one or more subscriptions associated with a single Azure AD tenant. Of course, you could also have multiple Azure AD tenants within your Azure account. So here we see subscriptions 1 and 2 listed over on the right. Now, why is this important? Well, because when you talk about management groups, there is a strong correlation to subscriptions, as we'll see. There are many different types of Azure subscriptions. So you might go with a pay-as-you-go type of subscription. It's a paid subscription, and you pay based on your resource consumption on a monthly basis in Azure. Or you might go with different types of subscriptions depending on what your needs are, such as professional direct support, if you need additional technical support options, developer support, or even standard support. So there are some differences, such as the fact as if you're using a developer support subscription, this means that you do get support, but it's for developers and it's only during business hours. So if it's late on a Saturday night and you've got a problem with a mission-critical system deployed in Azure, the developer support subscription is not going to work in that case. So on to Azure management groups. What are they and why are they relevant? Well, the purpose of an Azure management group is to organize multiple Azure subscriptions if you have them. It does this for the purposes of policies and compliance, because we can associate policies for governance with a management group which might contain more than one subscription. So it's a quick way to have the same types of governance requirements applied at once on a large scale. So here we see the management group hierarchy. At the top, we have the root management group, the default management group, under which you can build a management group. Now, here we've got 2 built under the root management group. On the left, we've got management group 1, on the right, management group 2. And within each management group, you can move subscriptions. So this is really beneficial for larger organizations using multiple subscriptions. So when you work with Azure management groups, you would add the subscriptions as required to your Azure AD tenant. You would create 1 or more management groups. Then you would move subscriptions under the appropriate management groups and then apply your policies or governance options to management groups. Management groups are useful when you have multiple Azure subscriptions that you want to organize and have an easy way to apply policies. So here in the portal, I'm going to start in the top center search bar by looking for management groups. So I'll type in manage, and I'm going to choose management groups from the list. Now, what I'm going to see here is currently what we have for a hierarchy. And what I see here is we have our root group. It's called the tenant root group, under which we have our pay-as-you-go subscription. Now, I only have 1 subscription, so there's no real benefit of working with management groups, but I want to step through the process regardless of that fact. So I'm going to click the Add Management Group button up at the top, and I'm going to call this, I'm going to create a new one. I'm going to set the management group ID, let's say, to be Management 1, and the management group will be called Management Group 1. Management Group 1. Okay, and then I'll click Save. So we're going to have now another part of our hierarchy in the form of a management group. And you can go ahead and add multiple management groups. What's going to drive you to do that is thinking about how you're going to move your multiple subscriptions under umbrellas, which are management groups, and then apply policies to those management groups, which flows down to the underlying subscription. So that's what's going to tell you how many management groups you need and perhaps what they should be called and so on. Okay, so we still see our tenant root group at the top, and at the bottom we still see our pay-as-you-go subscription, but notice the presence of our management group 1. What I want to do is move my subscription into management group 1. So to do that, to the far right listing of my subscription, I'll click the context menu, it looks like 3 dots, and I'll choose Move. It's that easy. I have to choose the target location, so the new parent management group I'll choose from the list, and in this case, it's going to be management group 1, and I'll go ahead and click on Save. Okay, so the next thing I'll do is click Refresh at the top, and now all we see below is our tenant root group, and within that, our management group 1. So I'm going to click on it to open it, and within the management group, notice now we can see indeed our pay-as-you-go subscription has been moved to it. So I'm just going to navigate back to the tenant root group here. Now, when you're looking at your management group, you also have a context button or menu over on the right as well. So you can even move those around if you have multiple management group levels under your tenant root group. So let's open up our management group once again. So if we wanted to move the subscription under this management group elsewhere, we would do the exact same thing we did originally. So to the very far right of that subscription, we click the context menu and choose Move and specify an alternate location. However, now that we're in Management Group, I can see a Details link. I'm going to click the Details link for Management Group 1. Now this is where we could start working with policies. I'm going to click Policies on the left. Now this takes me to the policy area in the portal where I could go down to assignments. I can make a new policy assignment. The only thing that's really different here is we have the option now of setting that policy assignment at the management group level. So I'm going to click the Assign Policy button up at the top, just so we can see what the options look like. And we can see here at the top, the scope can now be set to a management group 1. Now, if I click the Scope Selector button to the right of that, of course, as is always the case with Azure policies, we can also elect to choose a subscription. So maybe we only want a single subscription within the management group to get the policy settings, whatever the policy is we're going to apply. If we select a subscription, we can even drill down and get more granular as to a specific resource group. So really what's new here is we can select from management groups as a part of the hierarchy at the top level for policy assignments. As you use Azure AD over time and you create users and put those users in groups and register applications, you might realize down the road that there might be users and groups that no longer require that membership, so they might have more permissions than they otherwise would need, perhaps if they've moved on to another job role, or if the user account is no longer active, meaning the user's left the company, but they still have an Azure AD account. The other thing to consider is if you've granted access to use an application and that access is no longer required by a user or a group. Well, that's easy to forget over time. And so that's where Azure AD Access Reviews come in as being useful. So why don't we take a look at it? So here in the portal in the top center bar, I'm going to search for Identity, and I'm going to choose Identity Governance. Okay, so I'm going to click Access Reviews in the navigation bar over on the left, because that's what we're going to create. Now notice it says on the right, no access. That's not good. How am I going to work with this feature? Well, the first thing I should do is click Onboard over on the left. So onboarding is required as a preliminary step before you can start working with Azure AD Access Reviews. No problem. I'm just going to click the Onboard Now button down at the bottom. And before you know it, if you check out the notification icon in the upper right of the portal, it will have successfully onboarded our Azure AD tenant. All right, well, let's go back into the search bar at the top and let's search for identity again and let's choose Identity Governance. Let's go back to where we were. This time when we go down and click Access Reviews, we're not going to get the no access error message. So instead it says no access review to display. Well, that makes sense. We've not done it yet. So I'm going to click the new access review button up at the top. For the name, I'm going to call it Check Group Members. Down below, I'm going to leave the frequency to 1 time, although you could run recurrent scheduled access reviews, weekly, monthly, quarterly, semi-annually, and annually. I'm going to leave it on 1 time. I'm going to scroll down, and I'm going to specify the users to review. Now, we can either review members of a group or assignments for applications. So the ability, the authorization to be allowed to use an app. I'm going to leave it on members of a group, and the scope is going to be everyone in a group, not just guest users that might be a member. Now, the group in question, we're going to have to select down below. So I'm going to go down and choose an existing Azure AD group. In this case, I'm going to select a group I've already got created called Team 1, and I'm going to click the Select button. And down below, we can set the reviewers. Who's going to determine whether the members of that group should still be members? Group owners, the individual selected users, or members themselves. So we can select users or have the members of the group do it. In this case, I'm going to leave it on members self. I'm okay with letting users decide if they still need access to a group. Down below, we don't have a link to a program because it doesn't apply. We're not checking access or authorization to use an app. And if I just click on the upon completion settings, we can determine what we want to do, such as auto apply results to the resources. I'm going to choose enable, and down below, if reviewers don't respond, I'm going to remove access, just from a safety standpoint. I can also take a look at the advanced settings here in my access review config. Do we want to show recommendations? Should there be a reason on approval? Do we want reminders sent out? I'm going to leave all those as enabled, and I'm going to click Start. After a moment, we'll see it showing up in the list, our new access review, and we can see that the status is currently that it is initializing. So I can click on that to actually open it up. When I do that, I can see over on the right that there are 2 users in the group, and also they haven't been reviewed yet. They haven't done it themselves because remember, the selected reviewers in our configuration is members or self. Now here in another browser window, I've opened up the members for that group, Team 1, that the Azure AD Access Review is based on, and I've looked at the members so we can see that we've got 2 users, Jen Hill and Marcia Lynn. So I'm going to log in as user Jen Hill just to see what the user's perspective is. And what I'm going to log into is the myapps.microsoft.com website. Okay, so I've done that here in a browser. We can see in the upper right, we're logged in as user Jen Hill, and she'll get this Access Reviews icon that shows up on her apps panel. And so if she clicks on it, she'll see that there is an access review called Check Group Members, and it's due on June 4th. That's the default. We didn't change that when we set up the access review. And she can click the Begin Review button. So I'll click the Begin Review button. We can see the message here asks, do you still need to be in the group Team 1? Let's say that this user, Jen, decides, yes, I do. I still need access. Access to what? Well, doesn't matter in this case. We'll just say I still need access, and I'll click the Submit button. Okay, so user Jen Hill, a member of the group, has determined that, yes, she still needs to be a member of that group. Now notice what was once labeled as Begin Review for the button on the right now says Open Review. Okay, so Jen can go back in and change her mind, but at this point, it's been completed from that perspective for that user. So what that means back here in the portal is that when you're looking at that access review and you're in the overview blade, it'll start to change. So we have 2 users in total, but 1 has not reviewed and 1 has approved. That was, of course, our user Jen Hill. So there you have it. That's the purpose of an Azure AD Access Review. Microsoft Azure policies are used to control how cloud resources are created or managed in the Azure environment. You have a number of built-in policies you can use, but you can also define your own custom policies if the built-in ones do not suit your needs. So a policy really is a text file that uses JSON syntax. You could call it a JSON rule file. Now you can apply policies to new resources, certainly, but also existing resources. Now, periodically, Azure will run a scan against resources if you have any policies that are configured to check for compliance, such as checking whether virtual machines have disk encryption enabled. So Microsoft Azure policies then are considered to be more granular than RBAC. That's role-based access control. So as an example, imagine that with RBAC, what you can do is you can limit whether someone can create virtual machines. But you can't really limit the details about that, such as the virtual machine sizes that they could specifically use. And that's where policies would kick in, where you can do that and much more. You can also specify the types of resources that can be deployed or managed. You can specify locations where they can be deployed. You might even configure an Azure policy to add a default tag value. So maybe you have a policy that adds a cost center tag for billing purposes. So even if the administrator or technician doesn't specify that tag value when they create a resource, it's created by default, magically. Not really magically, it's from the policy. So Microsoft policies look like this in Azure. They work in this manner. We can have parameter values that we feed into a policy. So you don't have to hardwire everything into a policy, like the names of resources and so on. We can then assign the policy to multiple levels of the Azure hierarchy. You can assign policies so they apply at the subscription level, which means the policy would apply to everything in the subscription. Or, to be a little more granular, only to a resource group, so the policy, whatever it happens to do, applies only to resources in that resource group. Also to management groups. Management groups are used to organize multiple subscriptions, and you can also make exclusions. So for example, I might have some kind of a policy that applies at the subscription level, but I can exclude maybe a certain resource group where we've got dev test Azure items. Azure policies have effects. Now, we're going to talk about just a few of them here. There are many more than we'll see on this screen. But as an example, we have the append effect. The purpose of append would be to append something, properties, to a resource, such as adding tags. So by default, you might add a cost center tag to newly deployed resources, even if it's not specified by the resource creator. That would be an append policy effect. You might have an audit policy effect. Audit is used when you only want to log data. You don't actually want to do anything, you just want to log it. Next thing is deploy if not exists. So we're checking to see if a certain type of item or resource exists in Azure. If it doesn't, it will exist after this policy is finished. We can also deny specific items through a policy. Next, we have policy initiatives. The notion of policy initiatives is really all about having policies organized into related groups. So policy groups would then be assigned. Now, as an example, imagine that we have an initiative called Harden Regional Azure Resources. That's a general name. Well, it might consist of multiple policies, as seen here, such as ensuring VM disk encryption is enabled. That's one policy. The second policy, ensuring that endpoint protection is enabled. So you can manage Azure policies using the portal, using the CLI, and using PowerShell. Azure policies provide a way to adhere to proper governance of Azure cloud computing resources, such as limiting which resources can be created, where they can be created, how they can be configured, and so on. So in this case, we're going to take a look at using the portal to create a policy assignment. So the first thing I'll do here in the portal, in the top search bar, is search for policy, and I'll click on policy to open up that section of the portal. Now the first thing I can do here is take a look at definitions, policy definitions, by clicking definitions over on the left. Now when I do this, I'm going to see a unified list of both custom as well as built-in policies. If I choose built-in, it filters it. I only see built-in policies. If I choose custom, well, naturally, I only see custom. I want to see all types. So we've got a lot of them here, and I can search through the list. I can filter it out. So I want to see only items or policies related to encryption. So I can see there's one here called disk encryption should be applied on virtual machines. And if I click to open that up, the policy definition, then we will see the actual JSON definition of that policy. So we can see that listed here. Now that's not necessary when you want to make a policy assignment. You don't have to go look at the definitions. So let's just go to the assignments view and let's get it done. Now in the assignments view, you will see existing assignments that might have been already applied. You'll see the scope, whether it's been applied to a subscription, as in our first case here, the pay-as-you-go subscription, or a resource group, where the nomenclature will have the name of the subscription / the name of the resource group. So in this case, I'm going to go at the top and click the Assign Policy button. The default scope is my pay-as-you-go subscription, but if I click the Scope Selector button over on the far right, I can change that. So what I could do is specify, for example, that we have a management group selected at the top, which could contain more than one subscription. So the policy settings would apply to everything in both subscriptions. Well, I say both, could be more than 2 subscriptions within the management group. However, if I choose the subscription, then we can drill down and select a specific resource group where we want to apply the policy. So I'm going to go ahead and choose resource group 1 in this particular case. You can also add exclusions. So for example, if we did apply the policy at the entire subscription level, you might have maybe a test dev type of resource group you wanted to exclude, since they're just temporary resources and why bother evaluating them for policy compliance? Although you may want to, it really depends on your organization's security policies. Down below, the policy definition, we haven't even specified it yet. So I'm going to click the selector button over on the right for the policy definition. And this is going to be a familiar list. It's similar to what we were looking at previously when we looked at the policy definitions, and we could filter it for custom or built-in. I'm just going to search built-in for the word encrypt, and I want this policy called disk encryption should be applied on virtual machines. So I'll click it, and I'll click the select button down at the bottom. Perfect. Down below, policy enforcement is set to enabled. You can configure it and turn it off for now, and then just turn it on later, activate it. But I want it enabled, so I'll leave that on. And that's about it. So I'm going to go ahead and click Review and Create in the bottom left, and then I'm going to click Create to create the policy assignment. And we can now see it's shown here. Disk encryption should be applied. We can see the scope here. It's applied to our subscription in this particular example. Now with the context menu over on the far right for that assignment, if I click it, I can view compliance, which I could also view in the compliance view on the left. I can view the definition. I can delete the assignment if it's no longer required, or duplicate it if I have a similar need, maybe for a different resource group or a different subscription. So I can just duplicate it and make minor modifications to it. So depending on how many resources are in your subscription will really determine how long it takes before you'll be able to start going to compliance and viewing any details for this assignment. So let's just go to the compliance view for a second. And notice for our new disk encryption policy assignment, the compliance state currently is not started. As is the case with most Azure administrative tasks, you can accomplish it using not only the portal and PowerShell commandlets or API calls, but also using the Azure CLI, which I've launched here in the portal by clicking the Cloud Shell icon up at the top. So the first thing I want to do is create a policy assignment, but before I can do that, I have to know the names of the policies. I have to know the name of the policy, more specifically, that I want to assign. So we can learn of that here in the CLI by running AZ policy definition list. Now, instead of viewing all of the properties for each and every policy definition, all I care about is the display name. So I'm going to filter for it. To do that, I'll use -- query with a space and then open and close square bracket, which represents that there could be a collection. There could be many definitions for policies, and then dot display name. Now it's case sensitive. So display name here has a capital N for name. That's important. So I'm going to go ahead and press enter. Let's see what we get here. Okay, looks like a pretty large list. So I kind of want to filter that further. What I'm interested in are policy definitions dealing with encryption. So let's clear the screen and let's filter it for that. Now this one's a little trickier syntactically. So what do we have? We have AZ policy definition list -- query as we did previously, but this is where things change. We have an open double quote. There's a matching double quote at the very end of our expression. Now within the first opening double quote, we have an open and close square bracket. And that's because we're dealing with an array. We have many policy definitions. Then we have a dot, and then within curly braces, we're telling it that we want the display name and we want the ID properties returned. Okay, so each of those is separated. There's only two of them. Those two specifications are separated with the comma. Now, after that, we've got another opening square bracket, and we have question mark contains. So we're doing a comparison. In parentheses, I've then got display name, comma, and then in single quotes, encrypt, close parentheses, close square bracket, and as we've already mentioned, close the double quote. So, strange syntax for sure if you're not used to how that works here in the CLI. Basically, we're saying, show me the display name and ID only for policy definitions that have the word encrypt in their display name. Okay, let's press enter, see what we get. Aha, this is a bit of a smaller list, a little more digestible. Perfect. Now, what I'm interested in here is looking at, well, let's see here. We've got one policy definition here called unattached disks should be encrypted. So these are managed disks that aren't even attached to a VM. We still want them encrypted. So that's what we're going to do. We want to assign that policy. That's our example. Okay, now we know what it's called at least, so that's the first step out of the way. So to assign the policy, I'm going to use AZ policy assignment create -- name. This is the name of the assignment, not the name of the policy I want to use. I'm calling it encrypt unused disks. Then I'm using -- policy, and I've copied the policy ID. In our previous command, we displayed the display name of the policy as well as the ID. So I just copied the ID and put that in quotes. Then for -- resource - group, I'm specifying RG1. Let's go ahead and press enter to create that policy assignment. And it looks like it's done already. Let's go check it out here in the portal. So I'm going to go back here in the portal to my policy section and the assignments view. Now you might have to click the refresh button a few times at the top and wait a moment, but I now see our encrypt unused disks policy assignment shown in the list. You can use PowerShell commandlets to assign policies in Azure. Let's start here in the portal where I'm already looking at policy assignments. We've got 3 of them. So bear that in mind because when we come back and we're finished in PowerShell, there will be a 4th policy assignment shown in the list. So I'm going to launch the Cloud Shell by clicking the Cloud Shell icon here in the portal up at the top. And to get started, I need a resource group type of variable. So to do that, I'm going to use $RG equals get-az resource group -name. And RG1 is the resource group I'm interested in because I'm going to need that a little bit further on. The next thing I want to do is I want to figure out what policy definition I can use in order to make a policy assignment. Now, I already know which one I want. So I'm going to paste in this code where I'm creating a $definition variable. That's going to store the result of running get-az policy definition, which I am then piping to where-object. This is for filtering in PowerShell. Now, my filter expression is contained within an opening and closing curly brace, and I'm using $_. This is the built-in placeholder variable. Let's think about it. When you run get-az policy definition, it's going to return a lot of policy definitions. You need to cycle through each and every one of them, looking for the one you want. So the way that we're doing that here is with $_. It's kind of like a built-in loop variable. So within each policy definition return, we're going to look at .properties.displayName to see if it equals -eq audit VMs that do not use managed disks. I know that that is a valid name of a built-in policy. So that's what we will be storing in our definition variable. So let's just check our variables. $RG. Okay, yeah, it's got our RG1 resource group. And if I run $definition, just to see what's in that variable, it's got the definition for our audit VMs that do not use managed disks policy. That looks good to me. They're not null, as in empty, so that's good. We're ready to move on. The next thing that we're going to do is actually perform the assignment. So to do that, I'm going to use the new dash. Let's just scroll back up here. It's executed already. That's how fast Azure is. We've got new -az policy assignment for the commandlet. Now I have to give this assignment a name. So -name, I'm calling it VMs-managed disks. And the display name here is going to be check for VM managed disks. Then -scope. Where do you want this policy assigned? At the management group level, at the subscription level? In my case, the resource group level. So I'm using $RG.resourceID, using the resource ID property. And I have to tell it the policy definition I want to use for this assignment. So -policy definition, I will just pass it my $definition variable. So if we minimize Cloud Shell here, let's just go back into the portal where we had our previous 3 listings for policy assignments. Let's click refresh. Might have to do that once or twice. And after a moment, we're going to see that we've got our new policy assignment shown here. It's called check for VM managed disks. You can build your own custom policy definitions in Microsoft Azure, and then you can assign those to the Azure hierarchy, whether you assign it to a management group, a subscription, or a resource group. In this particular example, I'm using Microsoft Visual Studio as an editor, the Community Edition, which is free, and I've got my policy definition in here. Now, the file is called custompolicy.json. Policies in Azure use the JSON syntax. So I've got an open curly brace at the very top and at the very bottom as well. So that's part of the JSON syntax. The display name of my custom policy is called add cost center tag, and policy type is set to custom. The category here is tags. Now the category is just to organize them when you're working with all of your policies in the interface. So you can say only show me policies in the tags category, and this one will show up. Now down below, what I'm interested in doing is looking at the policy rule section. What we're doing is say if there is a field called cost center, so if that does not exist, if exists is false, then the effect will be modify. We want to modify the resource, the Azure resource, whether it's a virtual machine, storage account, whatever it is. If it does not have a cost center tag, we want to make a modification. And what we want to do, if I'll scroll down further, under operations, the operation value here is add. I want to add a tag called cost center. So the field is tags cost center, and the value for that tag cost center will be YHZ. That's an airport code. So as I scroll down, that's it. That's the end of my policy definition. Now, policies can do a lot more than just this. This is only but one example. So now what we want to do is we actually want to make sure that we have this definition created in Azure. Okay, so here in the portal, I'm going to search in the top center search bar for policy, and I'm going to click on policy. So what we want to do is create a new policy definition. So therefore, in the navigation bar, I'm going to click on definitions. Okay, and then on the right, I'm going to click the policy definition button. For the definition location, I'll click the scope selector button on the right. I'm just going to make sure it's tied to my Azure subscription. I'll just choose that from the list, and I'll choose select. For the name, I'm going to call it Add Cost Center Tag. And down below, we can specify the category. And remember, that's what we saw in the definition. We can create a new category, use existing. But really, we could use the editor down below and make all the changes. I'm just going to paste in what we were just looking at in Visual Studio. So we've now pasted in our custom policy definition. So if I scroll down to the very bottom, I'll be able to create the policy definition by clicking Save. And if we look at our notification icon in the upper right, indeed, creating the policy definition succeeded. And so if we stay in the definitions view, we're still in there, I could filter. So in the search field over on the far right at the top, I can filter by just typing in, let's say, add, and there it is, add cost center tag. It's our custom policy. So at this point, you would assign it like you would any other policy, like built-in policies. You would go to the assignments view if you're using the portal, the GUI, to do this, and you would click the assign policy button up at the top. And when it comes time to specify the policy definition, so I'll just go down and click the selector button to the right of policy definition, you would choose our newly created custom definition. What you might find useful is to filter the types for custom in this case, because there's so many there. And there's add cost center tag, our custom policy. After you've assigned policies in Azure, you can then check on their compliance. Depending on the nature of the policy will determine what compliance means. For example, if you've got a policy that's checking whether or not VM disks are encrypted, then those VMs whose disks are not will show up as non-compliant. So we have to put it in perspective. So here in the portal, I'm going to start in the top center search bar by searching for policy, and then I'll click on policy in the list of services. Now that's going to put us in the overview blade, which gives us an absolute wealth of information related to compliance. For example, right away, the first thing I'm presented with in this case is I have 88% of overall resource compliance. Now that's going to depend on how many policy assignments you have, how many resources you have in your subscription, how they're configured, and so on. So I have 2 non-compliant policies out of 3 overall, and I have 26 non-compliant resources out of a total of 210. Down below, we can see policy assignments. So we can see the policies here, like adding a cost center tag. We can see non-compliant, 89% are compliant. Disk encryption should be enabled. Non-compliant, looks like 0%, 0 out of 3 are encrypted. So we've got 3 non-compliant resources, in this case, managed disks. Check VM for managed disks. It's compliant, 100%, 3 out of 3. So this is great. So we can see that it's giving us some great stats, a quick high-level executive overview, if you will, about compliance. But we can get more detail by clicking on compliance over on the left if we want to drill into it even further. So we see some of the same stuff, the overall resource compliance, non-compliant policies, non-compliant resources. But we actually see the individual assignments down here, policy assignments, which we saw before. So for example, I'm interested, let's say, in this disk encryption should be enabled because it's non-compliant. I'm going to click to open up that policy assignment. So we can see over on the right under events for the last 7 days that the audit effect here is what was set as opposed to deny or deploy and so on. So we're auditing, checking for something, in this case, whether or not VM disks are encrypted. If we scroll down, I can actually see the names of the virtual machines that are in a non-compliance state. So all of them in this case. And let's say we pick on one. I'll click on the first virtual machine listed here. So in this case, if we were to drill down into that resource and we're interested in looking at whether or not it's got disk encryption enabled, it says disk encryption should be applied on the virtual machines. Okay, well that's good to know. And I can actually click on that link, which takes me into that policy definition. So exactly what is that policy definition doing if we need to get that level of detail? I'm going to click the X to close that. Now, on the previous screen for DC1 here, we can also view the resource itself. There's a View Resource button at the top. So I can go ahead and click on that if I want to investigate further. Now, in this case, investigating further means in the navigation bar, I'm going to scroll down and choose Disks. This is going to show me all of the disks, so the OS disk and the attached data disks for the VM and their encryption status. So I can see here that all we've got is an OS disk, and I can see under encryption, indeed, it says not enabled. Aha! So that's why it's showing up as non-compliant. We could even take care of business right here. We could click the encryption button up at the top, and then we could choose to encrypt the disks for this VM, whether it's the OS disk or the OS and data disks. However, I'm going to go back in the breadcrumb trail links at the upper left to policy and compliance. When you work with Azure policy assignments, not only can you see which Azure resources are compliant with whatever your policy is, such as, for example, checking disk encryption, but depending on the nature of the policy, specifically the policy effect, you might be able to create a remediation task, specifically if it uses a modify type of effect. Let me show you what I mean. Here in the portal, I'm going to search in the top center bar for policy, and I'm going to choose the policy listing under services. What I want to do here is I want to click on the compliance view over on the left. That's going to show me any assigned policies down below, and I can see the compliance state, whether something is non-compliant or compliant. For example, I'm going to choose a disk encryption policy assignment here. Now, what if we don't have compliance? What do we do about it? That's where remediation kicks in. However, here I can see that I've got some non-compliant virtual machines whose disks are not encrypted, but at the top, the Create Remediation Task button is grayed out. Well, I'll point your attention over to the right here under Events Last 7 Days that the effect for this policy, as it's configured, is Audit. So there are 3 items related to the audit event. So we're only auditing. We're not really doing anything. So in this case, to remediate the issue, I'd have to go into each and every virtual machine. So I can click on the link for the virtual machine here. And then within that, I could then view the specific resource by clicking the View Resource button, and then I could go and encrypt the disk. So that's fine, but that's not a remediation task. So let's back up a little bit here. I'm going to click the X's to get back to our compliance view here. We've got a policy here called Add Cost Center Tag, and again, we've got some non-compliance. Okay, so I'm going to click to open up the assignment details. First thing I notice is that the Create Remediation Task is available. Well, why is that? Well, because if we take a look over at the events over on the right, the way that this policy was created is that it's got a modify effect. So we've got 395 listed items, in this case, for the modify effect. Now, interestingly, let's just scroll down. If we take a look here, we can see we've got an awful lot of resources that are not compliant with whatever this policy should be doing. Well, what should the policy be doing? Well, adding a cost center tag. So if I click the View Definition button up at the top, it'll show me the definition of this policy, and we can see the JSON syntax here. And I'm interested in pointing out here that the effect is modify. So when you want to work with policy remediations, that's a must. So let's close down that policy definition, and let's click on the Create Remediation Task button up at the top. Okay, so here we have to specify the scope where we want the remediation to begin taking place in the hierarchy. It's currently set at my pay-as-you-go subscription, but if I click the Scope Selector button over to the far right, you'll see that we have other options. So we could specify only a specific resource group where we want to remediate the fact that there's not a cost center tag in this particular case. However, I'm going to leave it for the whole subscription because I want everything to have that cost center tag in this particular subscription. So we also have the option to reevaluate compliance before remediating in case it's just out of date. So I'm going to go ahead and do that. Now, if I uncheck it, then we can get back into business. So I'm going to leave it on all locations, all selected, and then I'm going to choose remediate. So I'm not going to check for compliance. And it's currently on its way. So we can see here, if we go to our notification icon, that the remediation task creation has succeeded. And if I just kind of scroll down here in the assignment details, we can see that adding the cost center tag, that policy, currently it's in progress. The remediation state shows in progress. So depending on how many resources are in your subscription will determine how long it takes for the remediation task to complete And eventually, the policy compliance will also be updated so that everything will show as being compliant. When you're thinking about Azure blueprints, think of a blueprint for a house. What is its purpose? It's a template that we can use to build many houses that has very specific instructions on how that's done. And so Azure blueprints really have a purpose of setting a standard pattern for compliance, for proper governance. So an Azure blueprint can be created in Azure, and it consists of what are called artifacts, each of which are listed here. So when you build an Azure blueprint, you can add resource groups that should be created, RBAC role assignments that should be configured, policy assignments that should be configured. You can even specify an ARM template artifact for resources that should be created or modified in some way. Azure Blueprint Storage means you can store the definition of the blueprint in the subscription or at the management group level. Now, you're going to need to have at least contributor access in Azure to save the blueprint in either of those two locations. So the blueprint lifecycle then begins with creating a blueprint. Now, when you create it initially, it's in what's called draft mode until it's published. So then you could test and make changes to your blueprint and ultimately publish it. Now, publishing means that you can then assign the blueprint and define a version, such as version 1.0 of it. Azure blueprints are essentially templates that can be used for orchestration. What does that mean? It means that when we want to set up a new environment, we can lump a bunch of items together. Now, when I say lump items together, those items are called artifacts, things like policy assignments, RBAC role definitions and assignments, resource group creation, ARM templates that deploy resources. All of that can be grouped into what's called a blueprint, and it allows us to have control for proper security governance of our environment. So we're going to go ahead and build a blueprint here in the portal. So to get started, I'm going to search in the top center bar for blueprint, and I'm going to choose blueprints. The first order of business here to make this happen is to go to the blueprint definitions view. So we're going to start by creating the blueprint before we can actually assign the blueprint. So I'm going to click the Create Blueprint button up at the top. Now you might do this in some cases because you have very specific compliance requirements. So you could kind of build that into the artifacts that you add to your blueprint. So down below we have a number of blueprints samples that we can select. So Canada Federal PBMM for security controls, or we have FedRAMP for compliance with U.S. government agencies, or HIPAA for U.S. agencies dealing, or U.S. companies rather, dealing with sensitive medical information, and so on. However, we're going to build our own. So I'm going to choose Start with Blank Blueprint up at the top. I'm going to call this Blueprint 1. And I have to define a location for storage. So I'm going to click the Scope Selector button over on the far right. And in this case, I'm going to store it in my subscription. So you can have a management group or a subscription for storage. So I'm going to select my subscription. Now the next thing I have to do is click the Next Artifacts button to add one or more artifacts. If we click on it, that's those items I was talking about lumping together when we started this discussion. You'll see the artifact type drop-down list includes policy assignments, role assignments, ARM templates, Azure Resource Manager template, and resource group. This is all encompassing. So let's say that you need to be compliant when you deploy Azure resources for a new team. Well, you could build a blueprint to do that and have the appropriate RBAC role assignments, policy assignments, ARM template to deploy the required resources the team needs in the cloud, and have that done in its own resource group. So this is great. So I'm going to start with resource group. I'm going to add that artifact. Now we can set the value here, but it says this value should be specified when the blueprint is assigned. Fair enough. If I uncheck that, I can specify the name of the resource group that will be created, but I don't want to do that. I can also specify the location or hardwire it here and add tags, but that's it. That's all I want to add is the fact that we want to create a resource group. The next thing I will add in this example is an ARM template. So down under the resource group, I'm going to click Add Artifact, and I'm going to choose from the artifact type drop-down list, Azure Resource Manager template. I have to give a display name for this, so I'm going to call it Create Linux VM. Maybe that's required to set up this environment from the blueprint. And down below, I need to specify a template. So I'm going to go ahead and do that. Okay, so we can see that we've got the JSON text here for that template to create a Linux VM. So I'm going to go ahead and click the Parameters tab here. Here's where it'll pick up the parameters based on what is inside our template. It may have none or it may have many. Here we have many, like the VM name, the admin username, the authentication type for, in this case, the Linux VM, whether it be password-based or SSH public key. So all of them are set to be specified when the blueprint is assigned, unless you uncheck them and hardcode the value. So that's fine. I'm okay with this. So I'm going to click Add. So we've now added a Create Linux VM ARM template artifact under our resource group. So we could continue adding artifacts for RBAC assignments and policy assignments. But in this case, I'm good with this. So I'm going to go ahead and click Save Draft in the bottom left. And sure enough, we're placed back in the Blueprint Definitions view where I can see Blueprint 1. The latest version is shown here as Draft. Now, if I click on the Context menu button over on the far right of Blueprint 1, I can choose to publish the blueprint. Of course, I can edit, delete it, view it, but I want to publish it so it can actually be used for assignments. The only requirement here is a version number. How about 1.0? And I'll click Publish. So notice instead of draft under the latest version, it now has what we put in as the version string 1.0. Now that we've published Blueprint 1, if we click the selector icon to the far right of Blueprint 1, we now have the option of assigning the blueprint. So I'll choose that. So we can see the assignment name is determined. I can specify a location. So in this case, I'm just going to choose a region from the list that makes sense, maybe East US. That's near where I am. And I can select the version of the blueprint I'm interested in if we've made changes over time. We can also determine if we want this blueprint assignment itself to be locked. It's currently set on Don't Lock, so I'm going to leave it there. And as I scroll further down, here are all the parameters based on the items I've added, like the resource group name. And when I've filled everything out to my liking, I would then click Assign. And after a moment, if we go to the notification icon in the upper right, we can see indeed that the blueprint assignment has succeeded. So in this course, we've examined the use of role-based access control, or RBAC, and policies to secure and manage Azure resources, including the use of management groups and Azure blueprints. We did this by exploring Azure RBAC and how Azure roles assign permissions to different scopes. We looked at how to assign built-in Azure roles using the portal, CLI, and PowerShell. We looked at how to create and assign a custom Azure role. We looked at how to manage multiple subscriptions with management groups and how to use the portal to work with a management group. We looked at how to initiate an Azure AD access review and examine how policies apply Azure permissions. We looked at how to use the portal, CLI, and PowerShell to assign a built-in Azure policy, and also how to create a custom policy. We looked at how to view Azure policy compliance and how to view and apply policy remediations. We looked at the purpose of Azure blueprints, and finally, how to create and publish an Azure blueprint using the portal. In our next course, we're going to move on to explore Azure migration tools designed to assess and move workloads from on-premises environments to the Azure cloud, including the Data Migration Assistant, or DMA, the Web Application Migration Assistant, and Azure Data Box. It's important to plan the migration of existing on-premises resources to the Azure cloud. That way you have the benefit of reusing the investment that was already made in IT services. So we can do this using the Azure Migrate service, and you can completely control it through the portal GUI. So it's a centralized assessment and migration tracking tool. It allows for on-premises server discovery, assessment, and migration, whether those servers are physical or virtual in the form of running as VMware virtual machines or Hyper-V virtual machines. You can also use Azure Migrate to assess and migrate databases and web applications. There are also independent software vendor, or ISV, migration tools that can be selected, such as Turbonomic for assessments or Current Technology tools for assessment and migration. Of course, you can always use the free Microsoft Azure assessment and migration tools for servers, databases, and web apps. When it comes to server assessment and database assessment, Azure Migrate has a few details that we should go over. The first of which is for server assessment. So you can assess on-premises VMware virtual machines, Hyper-V virtual machines, as well as physical servers. And what will happen is, as part of the assessment, Azure Migrate will make some sizing recommendations based on what it learns about the hardware configuration of the on-premises servers. To do this, it just uses an on-site or on-premises lightweight appliance. Now, it doesn't have to run within a virtual machine. You can run on a physical host as well. But that is what is used to perform the server assessment. Database assessments are done using the Database Migration Assistant tool, or DMA. So this way you can assess and then migrate, if you so choose, on-premises SQL databases. You can migrate them then to VMs running SQL or to Azure SQL Database, which is a managed service in the Azure environment. So the Azure Database Migration Service then lets you move your on-premises data workloads into the cloud. Gives you an easy way to do it directly over the internet, for example. So you could also do it through a site-to-site VPN if you needed an encrypted tunnel for security, or an express route circuit. So the database migration process then begins on the left with a migration assessment. This means discovering which databases are available on a given server, so as a SQL server. You can also actually choose Amazon Web Services RDS, or Relational Database Services, as a source as well, and discover databases and assess them to determine their Azure migration readiness. So after that's done, the database will then be converted to the appropriate format required for the migration into the cloud. Data is synchronized during that process between on-premises and the cloud until we finally cut off the synchronization and we end up, for example, with Azure SQL Database. When you migrate on-premises apps, they can be ASP.NET app migrations, could also be a PHP web app, so they would be running in the Windows platform. You would download and install the Migration Assistant tool, or if it's a public-facing app, you'll have the option of putting in the URL, and the assessment can be done straight from Azure over the internet. Finally, either way, you can choose to then migrate the app to Azure. So it would end up, for example, running an app service or an Azure web application in the Azure environment. To assess on-premises servers that you might want to migrate into the Azure cloud, the first thing you need to do is you need to set up an Azure Migrate project. So to get started here in the portal, I'm going to search in the top center bar for Migrate, and then I'm going to click on Azure Migrate. That puts us in the overview blade here in Azure Migrate, and on the right, I have options for assessing and potentially migrating Windows and Linux servers, SQL and other databases, and additional scenarios like web applications. So under Windows and Linux servers, I'm going to click the button that says Assess and Migrate Servers. Now that puts me into the Servers blade, so we could have clicked Servers over on the left, and on the right, I can then click the Add Tools button at the bottom. What we have to do is specify the assessment tool that will be used to assess our on-premises servers, and then the actual migration tool. They can be both one and the same, or they could each be different tools. So I'll specify a resource group for this Azure Migrate project, and then I'm going to specify a name for it. I'm going to call this Canada. And then for the geography, I have to choose a country. In this case, I'm going to choose Canada, and then I'll click Next. Now that's going to put us into the Select Assessment Tools section of the wizard. We have a number of tools that we can use to assess our on-premises workloads. And we can see under the Supported Workloads column exactly what is supported by the various assessment tools. So in this case, I'm going to select Azure Migrate Server Assessment, and then I'll click the Next button at the bottom. That puts us in the Select Migration Tool part of the wizard, where we have to choose the tool that would actually perform the migration. Once again, we have a number of tools listed, and we could read the details under the Supported Workloads and Features column. In this case, I'm going to select, once again, Azure Migrate and Server Migration. Then I'll click Next. That puts me on the Review and Add Tools final summary screen. So to actually create this project, I'm going to click the Add Tools button in the bottom left. So still in the Servers blade, on the right, I can now see Assessment Tools, and I can see my Migrate project. So the first thing I need to do here is click the Discover link. That's going to put me in the Discover Machines pages where I have to determine how I'm going to run an on-premises appliance to start discovering servers that are potential migration candidates. Now, instead of Discover using appliance, we also have a preview option at the top labeled Import using CSV. So if we already have the machine information, we could also do that. However, I'm going to leave it on Discover using appliance, and from the drop-down list, we've got three choices. We could specify a lightweight VMware type of appliance for on-prem discovery and assessment, or a Hyper-V appliance, or not virtualized. In other words, on a physical server, which is what I'm going to do. So down below that, we have a number of steps. The first of which is to download the Azure Migrate appliance. So it's a PowerShell script, so I have to download this zipped folder. It's about 50 megabytes, so I'm going to go ahead and click download to do that. So after having downloaded it, step number 2 instructs me to run the script to set up the appliance, after which I configure the appliance and start discovery from a web browser, so I can access the appliance's config UI from the browser. So I'm going to go ahead and do that, and then I just wait for the appliance to be connected and to provide the information to Azure. So let's go back to step 2 and let's run the script to set up our Azure Migrate appliance. So I've got my download for Azure Migrate installer, so I'm just going to right-click and extract it, and I'll just accept the defaults to get that to happen. So that creates a folder called Azure Migrate Installer, in which we've got a Windows PowerShell script file called Azure Migrate Installer. Let's just turn on our file extensions for a second here. I'm going to go to the View menu at the top, and I'm going to turn on the check mark for file name extension, so we can see that that has a .ps1 extension, as PowerShell scripts normally do. So Azure Migrate Installer .ps1. So what I'm going to do then is start an elevated PowerShell session. So I'm going to search my start menu for Power, and I'm going to right-click on PowerShell and choose Run as Administrator. So I've changed directory to the location where I've extracted the files. I'll type in a /Azure, and I'll press Tab for tab completion to kick in, and it's spelled out the name of the script. So that's great. I'm going to run it. I'm going to press Enter. So we can see it's installing it on my physical server. It's adding and updating registry keys and enabling some IIS components. All right, and before long, we can see as we scroll down through the PowerShell script output, for all the phases of the installer, we've got a green OK, and so that puts us back at our PowerShell prompt. So far, so good. Now, what that will have done is place this icon on the desktop of the server. It says Azure Migrate Appliance Configuration Manager, and it will have launched it in the browser, which has happened here automatically. So to move on with discovery, I'm going to turn on the check mark to accept license terms. That's the first step under Setup Prerequisites. It's then going to check connectivity to the internet, check that time is sync with internet time servers, and then make sure that the latest Azure Migrate components are installed on the host. I'm then prompted to authenticate with domain credentials, so I'll go ahead and enter those in and click OK. Now, in my particular case, the management app has been updated, so it needs to be restarted, and I've got a link here. It says click here to restart. So I'm going to go ahead and click on that link and do that. That'll put me back at Setup Prerequisites, so I'll just turn on the check mark to accept the license terms again, and we'll let it go through the items it checked previously, such as connecting to the internet, making sure time is in sync, and making sure the latest Azure Migrate updates are installed on this machine. So now that it's done, that's good. We can then click the Continue button. Now, the next thing we have to do is register this Azure Migrate appliance with Azure Migrate. So we have to log into Azure to do that, and we're provided with a login button, which I will click on. Okay, so now I've signed in through PowerShell on this device, so I can close that window. So I am logged in. So now what I have to do is select the appropriate Azure subscription, and I can select my Migrate project. Remember, we called that Canada, and it's in the RG1 resource group, and I have to specify an appliance name. So I'm going to call it MIG App 1, and I'm going to click the Register button. And before you know it, it'll say successfully registered, so I can click the Continue button to move on beyond that. And so the next thing I need to do is Add Servers for Discovery. So if I scroll up just a bit, I can click Add Credentials to provide credentials that will be used, whether they are Windows-based or Linux-based. And these will be used to essentially go in and poke around in my on-premises environment to assess my on-premises servers. So once I've specified these credentials and provided a friendly name for the credential set, I'll go ahead and click Add. So now it's added on the screen. And now we can provide our physical information by clicking the Add button. It's now available. So we can give a list of physical servers. So I can then add in an IP address, a comma, followed by the name of my credential set. Here I've just got one server I'm adding, so I'm going to go ahead and click Validate, which adds it to the list at the bottom. So we can see that the status is such that we have a green circle with a white check mark. So I'm going to go ahead and click the Save and Start Discovery button at the bottom. After a moment, we'll have a message at the bottom that states that it has initiated discovery and completed the appliance configuration. And so it says we can review the discovered machines in the Azure portal, and we even have a button in the bottom right to go to portal. We also have a link at the bottom to manage the appliance. It will take me to the appliance configuration page where I can see the prerequisites that we ran through initially, the physical server details, so the credentials sets, and also the servers that I've added down for discovery. And then, of course, if I go to Appliance Services, I'll see all of the version strings for each of the agents or components for the Azure Migration app. Now, back here in the Azure portal, I've searched for Azure Migrate in the top center bar to open up the Azure Migrate console. And in the left-hand navigator, what I'm interested in doing now is clicking on Discovered Items. So here we want to make sure that we've got our subscription selected on the right, the appropriate migration project that the appliance was registered with, and under the Microsoft Tools section down below, under Azure Migrate Appliance, I can see what we named our appliance when it was registered, MIG App 1. Down below, I can see one of the servers that we specified as part of the discovery. So the next thing to do is to create an assessment. So we actually want to assess that host as a potential migration candidate. Now, you first have to create a group. You can do that either separately or within the Create Assessment action. So I'm going to click the Create Assessment button at the top. We're going to do two things at once here. So first of all, the assessment name will be Assessment 1. Down below, I'm going to create a new group. I'm going to call it Group 1. Down below, the appliance name is selected, and I can see the discovered servers down below listed. So I'm going to put a check mark next to the only server that we discovered, and then I'm going to click the Create Assessment button in the bottom left. If we look at our notification area in the upper right of the portal, the bell icon, we can see that our assessment is being computed, and it might take a few moments for it to be ready to use. Next, I'll click on Servers in the left-hand navigator because I want to go into my assessment. So what I'm presented on the right is Discovered Servers, which has a number 1 to the right of it, Groups, 1 to the right of that, and Assessments, 1 to the right of that. We're interested in the assessment, so I'm going to click on the one link to the right of Assessments. Our assessments will be listed here, and I'm interested in the status column. So our assessment, Assessment 1, has a status of ready, which is great. It means we can go in and take a look to see our discovered servers, in our case it's one server, and the assessment status of it. Is it ready to be migrated to the Azure cloud? So I'm going to click on the assessment to open it up, which places us in the overview blade. We can see for Azure readiness, we've got one server ready for Azure. It also presents us with information related to the monthly storage cost estimate and the compute versus storage cost estimate. I can also click the export button at the top to export this as an Excel spreadsheet. Not really very useful when you've got one server that was discovered and assessed, but certainly useful when you have many that were. On the left, I'll click Azure Readiness, which will present me with a list of the servers that are ready for migration. We've only got one server. Under the Suggested Tool column, it suggests the Azure Migrate Server Migration Tool. If I click on the link for the name of this listed server, then it will say that it's ready for Azure Readiness. It'll suggest an Azure VM size. We can see our monthly cost estimate for compute and storage. And we even have some listing information down below for the number of cores and the current CPU utilization and the memory size. We've also got information here related to disks. I'll just expand the little triangle here to drill down under the 2 disks for this server because it wants to recreate these in the Azure cloud. And I've got one network adapter listing for the on-premises discovered and assessed host, which means we'd have to have a network interface resource created in Azure. Once you've configured Azure Migrate and discovered services and determined their cloud readiness, depending on the results of that assessment, you'll be able to migrate them into the Azure cloud. Let's take a look at how to do that for a server that was discovered and determined to be ready to be migrated. So here in the portal, I'm going to search first of all for Migrate, and then I'll just choose Azure Migrate from the list. Now this has already been configured, so if I click on Servers in the left-hand navigator, I will realize that I've got a discovered server, I've got one assessment, and if I drill into the assessment by clicking the one, there's one assessment and it's a link. If I drill into that assessment further in the right-hand panel, I'll be able to determine whether or not I've got servers ready for Azure. If I click Azure Readiness on the left, I can get further details on the servers, such as their name and so on. So I'm going to go back into Azure Migrate Servers. I'll click the breadcrumb trail link up at the top to do that. And what I'm going to do, I'm still looking at the Servers blade, is over on the right, I'm going to scroll down under Migration Tools. Now, when I set up Azure Migrate, I selected the Azure Migrate Server Migration Tool, but down below that, there's a link to add additional migration tools, even from different vendors. So I'm going to stick with the Azure Migration Tool for server migration. So I'm going to click Discover under that. I'm then asked if my machines are virtualized. So from the drop-down list, I'm going to choose Not Virtualized, Other, and I'm asked if I want to install a new replication appliance. Well, I need a replication appliance if I want to perform an actual server migration. So I'm going to choose from the drop-down list, Install a replication appliance. That gives me a couple of other details down below where step one is to download and install the replication appliance software. I need an on-premises Windows Server 2016 machine that I will then download the replication appliance software on and configure it. So I've got one already, so I'm going to go ahead and click the download link to download the replication appliance software. That's going to prompt me to save a file called Microsoft Azure Site Recovery Unified Setup.exe. It's approximately 2 gigabytes in size, so I'm going to go ahead and save that. Once the download is completed, I'm going to go ahead and right-click on it and run it as administrator. That's going to take us to the screen where we can elect to install the configuration server and process server. That's what we want here. So it's already selected. I'm going to click the Next button. I will accept the third-party license agreement and click Next again. Now at this point, I need a site recovery registration key. So we're going to have to get that back in the portal. And so back here in the portal where we started off the whole thing, in step 2, we have a download button to download our registration key file. So I'm going to go ahead and do that. And then back here on my on-premises server, I'm going to click the Browse button, and I've put that in my local downloads folder, and we've got a Migrate Vault type of key file. Now you might say, what kind of vault is this? We didn't make a vault. Well, what happened automatically in the background is it created a Recovery Services vault. So I'm going to choose the Vault Credentials file, and then I'll click Next. I'm going to tell it to connect directly to Azure Site Recovery without a proxy server. I'm not going through a proxy server. And I'll click Next again. It's checking the network connectivity to make sure that that's going to work. So it's checked through the prerequisites. We've got a warning for a few of them, such as the minimum memory and CPU checks. I can just go ahead and double-click on the warning and read the details. Here it states that the server only has 8 gig of RAM, but it recommends 16. That's fine. It's only a warning. It's not a showstopper. It's checking for other things, like whether a restart is pending, if you've installed or uninstalled something recently. It's checking the IIS configuration. You can't have any other IIS websites configured on this host, and so on. So it looks good. We can proceed. So to do that, I'll click the Next button in the bottom. And I'm going to have to specify the MySQL root password because it uses MySQL, and also the MySQL database password. And then I'll go ahead and click on Next in the bottom right. Now it's asking me if I want to protect VMware virtual machines. No, I'm going to choose No, and I'll choose Next. I'm going to accept the default installation location, so I'll choose Next. On the network selection page, I have a network interface selection for connectivity with on-premises machines and also for failback from Azure components. The default listening port on this will be 9443, which is fine, and I'm going to go ahead and click Next, and then I'll click Install. After the installation is completed, I'm going to go ahead and click Finish. It reminds me that I need to restart the server. That's not a problem. I'm going to go ahead and do that. So then it tells me that I have a configuration server passphrase that I'm going to be asked for when installing agents on source and target server. So do I want to copy it to the clipboard? I'm going to choose yes, definitely. And I'm going to paste that in Notepad and save it in a file. So let me just fire up Notepad real quick here. And I'm just going to save this on the local machine so that we have a copy of it. I'm going to call it config pw. And I'm going to go ahead and restart the server. After restarting, there'll be a couple of icons on the desktop as a result of our installation. The first tool is the CSPS config tool. So I'm going to go ahead and click that. And from here, if we haven't already, we can click Add Account and fill in the details. These are credentials that can be used to access servers on-prem. So I've already added one called Config Serve Account 1. We can also go under Vault Registration, and if we've not already done it, we can go to Browse and select our Vault Registration file, and we can enable registration with the Recovery Services Vault. I've already done that. Localization has the language. Configuration details has some details for port numbers and the configuration server IP, which is this particular host. So I'm not going to change any of those things. So I'm going to click Close. Back here in the portal, in the Azure Migrate configuration, I'm in the Servers blade, and on the right, I'm going to scroll down to Migration Tools and click Discover. That's where we started the process of downloading the file to do the installation of our config server and also the Recovery Services Vault Credentials file. So are your machines virtualized? I'm going to choose Not Virtualized Other. I'm going to select the appliance type as Install a Replication Appliance. There's steps 1 and 2 we saw earlier. Now we're going to go into step 3 to finalize the registration. So down below that, in the Select Configuration Server drop-down list, I'm going to choose my config server and I'm going to click Finalize Registration. And after a moment, we'll see a message that states registration is finalized. So that's great. Now we can close that screen with the X in the upper right. And still in the Servers blade of Azure Migrate, over on the right under Migration Tools, this time I'll click Replicate. So from here, the first thing I'm going to have to do is specify whether or not the machines I want to replicate and ultimately have migrated are virtualized. So again, I would choose Not Virtualized Other. I have to choose my on-premises replication appliance, so I'll choose that from the list now that it's registered. Process server and the guest credentials I configured show up. So from here, I would click Next Virtual Machines, and we can see across the top, we would start selecting virtual machine assessments or candidates for migration, set the target settings, configure the target compute and disk configuration, and start the replication into the cloud. Now I'm going to click the Close, the X to get out of that, after which we could then click Migrate. Migrate is currently grayed out because we've not yet done the replication, but after that, we would be able to migrate our on-premises server into the Azure cloud as an Azure virtual machine. In this demonstration, I'm going to perform a migration assessment of on-premises databases to determine their readiness for cloud migration. And so to get started here in the portal, I've gone into Azure Migrate. You can search for Azure Migrate up in the center search bar. Here I'm then going to click on Databases on the left. On the right, I'll scroll down and click the Add Tools button. I need to add the specific tools that will be used for performing the assessment as well as performing the database migration. So we're looking at the assessment tool where I can select either the Azure Migrate Database Assessment tool, which is free, or third-party tools. I'm going to use the Azure Migrate tool that's free. I'll click Next after selecting that. That puts us in the Select Migration tool part of the wizard, where I'm going to select the Azure Migration Database Migration tool, and I'll click Next. And on the Review and Add Tools screen, I will click the Add Tools button in the bottom left. So this is the first part of configuring the database migration portion in Azure Migrate. After we've done that, we're given the option of downloading DMA. That's the Database Migration Assistant. So we've got a link to do that. That's step 1. And step 2 is to assess using the Database Migration Assessment tool. So I'm going to go ahead and download DMA. So now that I've downloaded the Database Migration Assistant, I'm going to right-click on it here and choose Install. And I'll click Next. I'll accept the terms of the license agreement and click Next again, and I'll click the Install button. So it doesn't take very long to get that installed. I'm going to turn on the checkbox here to launch Microsoft Data Migration Assistant, and then I'll go ahead and click the Finish button. And I'm going to click the plus sign in the left-hand navigation bar to build a new project. Now I can build a project that assesses my on-premises SQL environment, and then from that I can determine cloud readiness, or I can actually perform the migration if I've already run an assessment. In this case, we're only going to run an assessment, so I'm going to go ahead and do that. And I need to give this project a name. I'll call it HFX Proj 1. For the source server type, I can choose either SQL Server, so that's running on premises, or AWS Amazon Web Services RDS, that's Relational Database Services for SQL Server. So those are the sources I can migrate from and bring into the Azure cloud. The target server type could be, for example, Azure SQL Database. So I do want to do that. I want to bring over my databases from on-prem into Azure SQL Database. At least I want to assess that possibility. So I'll go ahead and click Create to create this project. Then I'm going to click Next. I'm going to have to give it some details, such as the name of the on-premises server that I want to use. So I'll fill that in. That's my on-premises SQL server. It uses Windows authentication, but I could choose the appropriate authentication type. If you're not sure what to choose here, talk to your on-prem SQL people. And I'm going to click Connect. I'm not going to change anything else here. So I know it's made a good connection because I have a list of valid databases that are being hosted on that SQL Server instance. So I'm just going to choose one of the databases in question that I'm thinking about migrating to Azure, and I'm going to click Add. So we can see it's been added here, and we can add and remove sources at will here to determine what we want our assessment to be run against. So I'm going to go ahead and click Start Assessment in the bottom right. Once the assessment is complete, we can see that we are in step 3, where we are reviewing the results. And so we can see our SQL Server on premises listed over here on the left, and then we can see our listed items of unsupported features. So the service broker feature not being supported in the Azure cloud. And when we select that unsupported feature, we get some details listed over here on the right. Then we also get some recommendations about what we might be able to do to resolve this issue once the database has actually been migrated into the Azure cloud. Now, also remember that once you're happy with this, you can actually add an actual migration project where you can actually start moving data into the cloud. So this migration assistant is a great tool then for you to evaluate your on-premises SQL databases and how likely they are as candidates for running in the Azure cloud. You can use the Azure Migrate service to migrate not only physical and virtual on-premises servers to Azure and databases, but also web applications. Let's take a look at this. So here in the portal, in the top center, I'm going to search for Migrate, and I'll choose Azure Migrate to take me into the service. And in the left-hand navigator, I'm going to go down and I'm going to select Web Apps. I'm then going to scroll down on the right and click the Add Tools button at the bottom. I need to select a tool for assessing any on-premises .NET or PHP apps, and then I need to select a migration tool. So for assessment tools, the only option here is the free Azure Migrate Web App Assessment tool. So I'm going to select it, and I'll click the next button in the bottom left. That puts me in the Select Migration Tool part of the wizard, where I'm going to choose the free Azure Migrate Web App Migration Tool. And I'm going to click Next. Now on the Review and Add Tools screen, I'm then going to click the Add Tools button in the bottom left. So what I'm doing here is adding these tools for assessment migration to the Azure Migrate service. After we've done that, still in the Web Apps blade on the right, things are a bit different. We have different options. We have assessment tools and migration tools. So for assessment tools, I'm going to click the Assess link. And from here, step 1 is to download the App Service Migration Assistant. Step 2 is to assess websites using that. And step 3 is to upload the assessment results to Azure Migrate. So I'm going to click the Download button to download the App Service Migration Assistant. Now when I click that, it takes me to a Migrate to Azure App Service web page where I can either provide a public URL to assess the migration if I've got a public-facing type of web app, or for internal use for .NET PHP apps, I can download the tool that will allow me to assess and then ultimately we can configure a migration. So I'm going to click the download button to download the tool. So it says the minimum system requirements for this are IIS 7.5 and administrative access on the server. No problem. So I'm going to scroll down and I'm going to click the download button. Then I'll click accept and download. And I will choose to save it in my downloads folder. You want to make sure you're saving this installer. Notice it's a .msi file. You're going to want to make sure this installer is available on the server where you want the Web App Migration Assistant to run. So I'm going to go ahead and right-click on the App Service Migration MSI file, and I'm going to choose Install. It's a pretty quick and simple installation. So after that's done, you're going to have this App Service Migration Assistant icon on your desktop. I'm going to go ahead and launch it. So there's going to be a series of steps here. The first of which is that we're going to have to select a site that was discovered. So for example, down below, I've got 2 websites found. Now this is on the server where I'm running this App Service Migration Assistant. So I'm going to select the default website and click the next button at the bottom. So we can see here that we've got assessment reports categorized by successful items that make this a prime candidate for migration, warnings, and errors. We don't have any warnings or errors, but 13 successful items. And I can click to drill down into them and take a look. I don't really care about that because they're all success. I would only be very interested in taking a look at warnings and definitely looking at errors that might prevent migrating the app into the cloud. So now that we've got that done, the next thing we'll do is scroll down and in the bottom left area, click the next button. Now we have to log in to Azure. So it provides a unique device code here. So I'm going to copy that code and open a web browser so that we can make the connection into our Azure environment. So I'm going to paste the code and I will click Next. And then I'm going to choose an account to log in with. I then get a message that says I've signed in, so I don't need to be in the browser anymore. So now I can see my Azure subscription. I can create a resource group to host the app or use an existing one that I can simply choose from the list, which I will do. I can choose a destination site name. Notice, as usual, it wants to use the .azurewebsites.net DNS suffix by default. I'm going to call this Migrated App 172 just so we can easily identify it. We can either create a new app service plan or use an existing one. So we can select it from the list. We can also scroll down and create a new Azure migration project or associate it. So I'm going to associate it with an existing migration project that I've got created called Canada. And other than that, I'm going to scroll down at the very bottom and I'm going to click the Migrate button to begin the migration process. And after a moment, it is done. So we have the option of going to our website directly in here, migrating another site, or even exporting an ARM template for the migrated web app. Let's take a look at it in the portal. So in the portal, I've just navigated to the App Services view, and indeed, we have our Migrated App 172 shown in the list. I can click on it. It's a functional web app. In the overview blade, I can see that the status is that it's running. And if I click the URL for it, I'll see whatever the home page was for that on-premises application. In this case, it was just an on-premises IIS Windows Server default page. Azure Data Box is a Microsoft Azure Migrate option that's really designed to transfer large amounts of data from an on-premises environment, such as a data center that your organization might use, into the Azure cloud. So the idea is that we don't need to transfer these large, vast amounts of data over the network, which could take an unreasonably long amount of time. Instead, we have physical storage devices that we have in our data centers that we copy the data to and then physically ship to an Azure data center. Now, there are a couple of options for Azure Data Box, one of which is called Azure Data Box Disk. This one has a capacity of 40 terabytes. It uses SSD drives with USB or SATA interfaces. You can copy data to the drives using tools such as the Robocopy command line interface tool. And it supports AES 128-bit encryption. The next one is Azure Data Box, which has a capacity of 100 terabytes. It supports access over the network locally using SMB or NFS, and it supports AES 256-bit encryption. Then there's Azure Data Box Heavy, which has a capacity of up to 1 petabyte. It also has network attached storage or NAS protocol support, and it supports AES 128-bit encryption. You also have an option called Azure Data Box Gateway, which is a virtual appliance that you can run on an on-premises host, whether it's Hyper-V or VMware as the engine. So it supports SMB and NFS access, and its purpose is to transfer data to Azure. But it also at the same time serves kind of as a cache, so you still have local access on premises to those files. Now, of course, depending on the amount of data, this might not be a viable solution because it might take too long to transfer data to the Azure environment through the Azure Data Box Gateway. Before I can use Azure Data Box with my own disks to copy data from my on-premises environment into the Azure cloud in a storage account, I first need to generate a journal file. On my machine, I've plugged in an external removable drive, drive letter L, so I've enabled disk volume encryption. So currently, drive L is locked with BitLocker. So I'm going to click on Unlock Drive so that we can get to the contents of the drive. Enter the password, and I'll click the Unlock button. If I flip over to Windows Explorer, I can check out the contents of drive letter L. I've got a projects folder with a couple of sample files within it. The next thing I'm going to do here at the command prompt is I'm going to run the manage-bde, that's BitLocker drive encryption. And what I want to do is be able to view the key value for this. So I'm going to put in dash protectors dash get, and then I'll specify the drive letter, in this case, L:. And I'm interested here in taking a look at the encryption detail, the password item listed at the bottom. That's because that's a BitLocker key item that I'm going to need if I want to be able to generate a job using WA import export so that I can use DataBox to get data into Azure. So now I'm going to use the WA import export.exe. I'll specify the prep import parameter /j:, and I'm going to specify the name of the journal file I want to create, which in this case, I'm going to call it driveljournal.jrn, file extension. Then /id, I'm going to call this session1, /t for the drive I'm interested in, drive letter L, but no colon after the L, /bk for the BitLocker key that we mentioned earlier. So that's the key from up above here. That's the password item that results from manage-bde, that command that we ran. Then /source_dir: is L:, this time we do have the colon after the L, L:/, and then /destination dir is a container that I want to store this in a storage account. /blob type is a block blob. /skip write I'm specifying since I already have data on drive letter L, and /enable content MD5 to generate file hashes. So I'm going to go ahead and do that. Okay, we can now see it's on its way. So what we want to do is let this complete and then check out the files that are created, in this case, on drive L. So now that it's completed, if I go into Windows Explorer and navigate to drive L, I still have my projects folder. That's the original source data that I want to upload into the Azure cloud. However, I've also got a drive manifest file that's an XML document, and I've got a drive manifest hash file. So I'm going to open up the drive manifest XML file. That's going to open in a web browser. But by going through this, I get a sense of the data. There's a reference for the files that were already on the drive that will be brought into the Azure cloud, into a storage account. So we've got that information stored here in the XML manifest. Now in the location where I ran WA import export, I'll also have the journal file. To use DataBox, the last thing you would do in the portal is go into Azure Migrate and click DataBox on the left. Now it may prompt you with some details such as a resource group, the transfer type, which is going to be import to Azure, the source country or region, I'm going to choose Canada here, and the destination Azure region, which I'm going to select as Canada Central, and then I'll click Apply. I'm then presented with options for DataBox Disk up to 40 terabytes, DataBox up to 100 terabytes, and DataBox Heavy up to 1,000 terabytes. These options would be for enterprise customers or Microsoft Cloud Solution Provider customers or Microsoft Partner Network customers, and so on. But I also have an option to send my own disks, so 1 terabyte onward. So I'm going to click Select because this is where I'll have the option of uploading the journal file. So when I do this, the first thing on Basics is I determine if I want to import into Azure or export from it. I want to import in, so I'm going to call this import job 1, specify a resource group. The next thing I would do is click OK. And in step 2, I would then proceed with uploading the journal file, specifying the storage count destination. Step 3 would be to add the return shipping information and then a summary. The drives would then be picked up and physically sent to an Azure data center. So in this course, we've examined Azure migration tools used to assess and move servers, databases, web apps, and data files from on-premises into the Azure cloud. We did this by exploring the features and tools provided by the Azure Migrate service, as well as how to install the Azure Migrate appliance. We looked at how to perform a migration assessment of on-premises servers using the Azure Migrate Server Assessment tool. We looked at how to perform a migration assessment of on-premises databases using the Database Migration Assistant, or DMA. We looked at how to perform a migration assessment of on-premises web apps using the Web App Migration Assistant. And finally, we looked at Azure Data Box and how to generate a journal file and when it should be used for moving data into Azure. In our next course, we'll move on to explore a number of Azure features for monitoring both individual and centralized resources, including Azure Monitor, Application Insights, Security Center, and Azure Sentinel. Monitoring your Azure resources is important for a number of reasons. Some examples would include metrics. You want to be able to track the performance of your deployed resources, such as making sure that virtual machines have the correct sizing to accommodate the workload. Then there's the issue of availability. For example, making sure we are tracking any failed database connections or any successful or failed replications between regions. We can also monitor security events from an auditing standpoint, and we can also monitor the management of Azure resources. This type of data is stored in what's called an activity log, and every Azure resource has one of them. Monitoring also allows, at a higher level, proper resource governance, such as making sure that the organization is compliant with the appropriate regulations. Monitoring is also important to ensure that we have effective security controls in place to protect assets, such as making sure that network security groups have the appropriate firewall rules to allow or deny the appropriate traffic. Monitoring also lends itself to accountability. Everything that's logged, such as activity log information for the management of Azure resources, is date and time stamped, but not only that, it also includes the name of the user that made that administrative change. So there's accountability on who did what, when. So legal and regulatory compliance could include the safekeeping of stored data, such as in a storage account, and ensuring that not only that data is encrypted, but also perhaps ensuring that customer-managed keys are used to manage that encryption. Azure monitoring comes in many different categories. You can monitor Azure network components, such as VNets and subnets, or you might look at the network aspect of a web application, an app service, to see ingress and egress traffic to and from that web app. We can also monitor individual virtual machine hosts. We can monitor individual web applications. This is especially useful when you enable application insights to drill down into the detail of the code running to support that app. Continuous monitoring is always crucial. We don't want to monitor once a quarter or once a year. We want to be monitoring resources continuously to make sure that we have the best deployment model available. This means monitoring not only on-premises resources that might be linked to Azure, but also cloud resources. And when we talk about monitoring in the cloud, such as using the Azure Monitor service, this is referred to as monitoring as a service. We can also monitor the overall health of Azure services available in each region globally. We can enable virtual machine diagnostics. By doing this, we're getting logged information about what's happening within the VM. As an example, we might be interested, if it's a Windows VM, in getting certain event log items, such as auditing records, maybe failure records from within the Windows OS. We might also want something specific like Microsoft IIS web server log information. We can also create custom dashboards. Once we've monitored what we think is relevant, we might want to put those items in one place, and that would be a custom dashboard. Of course, you can have multiple dashboards. So after you add the relevant items to the dashboard, essentially one-stop shopping, so to speak, for monitoring, you can then set a custom dashboard as the Azure start page. So it's the first thing you see when you go into the Azure portal. And then we have Log Analytics Workspaces. Log Analytics Workspaces are their own type of resource in Azure that allow for the centralized monitoring of Azure log data. So this would be configuration data, so configuring the resource in Azure, as well as log data related to what's happening within that resource. This can feed into the Azure Monitor service as a data source. You can also run log queries within an analytics workspace. You can configure alert notifications and view metrics. Now, we can set alerts and metrics on an individual Azure resource, but here we're talking about doing it centrally in a Log Analytics workspace. And the great thing about adding a metric, for example, within this is that it will prompt you to select a scope. And that scope could even include adding metrics to monitor resources across multiple Azure subscriptions. There are a number of data sources that feed into a Log Analytics workspace, including storage account logs, Azure activity logs, even automation accounts. Automation accounts are primarily used for things like runbooks, essentially running PowerShell scripts in the cloud. And you could configure alerts that would report to the Log Analytics workspace when something occurs related to that in the automation account. We can also use physical and virtual servers by connecting them to the Log Analytics workspace. They would be data sources, and also System Center Operations Manager, or SCOM. The data sources can come from across multiple regions. So for instance, you might add multiple virtual machines in different Azure regions to one Log Analytics workspace. Along the same vein of logic, you can also have multiple Log Analytics workspaces. Usually that's done for administrative purposes. So if we have an IT team that handles cloud resources in Azure in the Eastern US, then we might have a Log Analytics workspace created for that versus the Western US. You can use the Azure portal to monitor individual Azure resources, whether you want to see management activity about that resource or whether you're looking at performance metrics. As an example, here in the portal, I'm going to open up my navigation bar on the left and I'm going to click App Services. Now, what I can do here is check the status column to see if any of my web apps are stopped or running. I've got one running, so I'm going to click on it to open it up. Now that's going to put me in the overview blade, which is where I want to be, because from here, I have the option of accessing some of the performance metrics like HTTP 500 series errors, or the amount of data into the web app or data out. So this is plotted in terms of a unit of measurement for data in and out for kilobytes. And at the bottom, we can see we've got a timeline. And using these graphs, I can determine by looking at the peaks when there was the most activity for data in or data out of the web application. Scrolling down, I also have charts here for the number of requests and the average response time. Now, the average response time is very important because we want to ensure that users have an optimal and quick experience. And if they're not consistently, we might consider determining where those users are connecting from, and maybe even deploying a content delivery network. If I click on any one of these charts, it zooms into it so I can get into more detail. And from here, I can add metrics by clicking the Add Metric button by selecting the metric from the drop-down list. For example, if I were to choose connections, it will be plotted on the chart as well. I can also click Add Filter if I want to filter some aspect of the chart data so it's not appearing. I also can switch the different chart types by clicking on what's currently set line chart. I can select an area chart. I might choose a bar chart. I might even just choose grid if I just want the raw data, the numeric data. In this case, for the items that were added, requests and connections. At the top, we can also build a new chart by clicking the New Chart button. Under Share, we could download this as an Excel file, or we could copy the link and provide it to other people of interest, people that might be interested in this type of metric. And they would need to have at least the monitoring reader role, the RBAC role, in order to be able to see this type of information. The other thing to consider is that we can look at metrics and activity log information for other types of resources. Let's start by going back to our web application by clicking on the name of the web app in the breadcrumb trail in the upper left, because we've also got activity log shown in the left-hand navigator. The activity log is just that, activity about managing this Azure resource. If you want to get details about access to a web application and types of requests made, you'd be looking more at application insights. So the activity log gives us the ability to determine when management tasks were completed against this resource. I have an entry for when the website was updated. It succeeded, it was 4 hours ago, and I can drill down within that by expanding it and start seeing further details. We can also filter out things at the top, such as the time span. The default is the last 6 hours. Well, we could click on that and choose the last month. Now, if the web application didn't exist for that long, we might not get that much more information. We can also filter by event severity or by resource group, and so on. You can also search this log. So if I search for the word update, it'll filter everything out other than those items related to updating this app service, this web application. Now let's go and open the left-hand navigation bar, and maybe I'll open the virtual machines view. We can do the same type of thing. We can view the activity log. We can view performance metrics for an individual resource like a virtual machine. So I've got one here that's shown as running. I'm going to go ahead and click on it to open up its properties. And in the overview blade, if I scroll down on the right, we've got some information related to CPU utilization. There's a graph for that. There's a graph for network traffic. I also have a graph for disk bytes, disk operations per second. Now, the default is that we're looking at this for the last hour, but we can say for the last 12 hours, last 7 days, even the last 30 days for this particular VM, which can be especially useful if you're trying to establish a baseline of normal activity, and also if you need an easy way to identify abnormalities. When are we seeing anomalies? Well, maybe by looking at peaks, we'll be able to pinpoint a date and a time when things were above average or unusual. We can also click on the activity log in the left-hand navigator, in this case to view the activity log related to management tasks for this VM. The time span here is the last 6 hours, but we might say I want it for the last week. I'll click Apply, and if the VM existed for that time period and there's activity for it, then we'll see it listed here. Just like when we're reviewing an app service, we can also filter items out by event severity, resource group, or by searching for something specific up at the top. Finally, let's go back into our navigation bar on the left. Let's take a look at some individual monitoring for a storage account. So we've looked at an app service, a virtual machine. Let's take a look at a storage account by clicking to open it up. The first thing we'll do, consistent with what we've done with the other items, is we're going to stay on the overview blade, which is what you land on by default, and I'm going to scroll down where I've got some charts for the total egress traffic. So that's outbound traffic related to the storage account versus ingress traffic. We'll also have a chart for the average latency, and we can even get a breakdown of the request. Remember, you can click on any one of these to zoom into the individual details. And instead of viewing the default line chart, you might want to go grid if you want to see just numeric values, have that available. You also have the option of pinning to a dashboard. If some of these prove interesting and you are referring to them often, for convenience, instead of having to drill down and find these monitoring items, you can pin them to a dashboard. I'm going to click Pin to Dashboard, and I'm going to choose Select Another Dashboard, and I'm going to create a new one. So this way I can have the things that are of interest for my job in one place. So I'm going to choose Create New. I'm going to call this Dashboard 1. And the next thing I'll do is just go down and specify the location. Here it's going to be Canada Central, and I'm going to click apply. So now if I go into some other chart that I find interesting and relevant, what I could do is click Pin to Dashboard, select another dashboard, and then I'll be able to select it from a list because it will exist. We will have created it. So down in the dashboard drop-down list, I could select dashboard 1, and I could click Apply, and it says Pinned to Dashboard. Now to use the dashboard, in the left-hand navigator, I can select Dashboard, and I have a drop-down list of dashboards to choose from. Here I've got Dashboard 1, and I've got the 2 charts listed that were added to this dashboard for convenience. A log analytics workspace in Microsoft Azure you can think of as being a centralized container for log information, for some monitoring information, and even for some alert configurations from a variety of different data sources. Here in the portal, I'm in the All Resources view. I'm just going to scroll down and notice that we're going to have one or more existing log analytics workspaces depending on what you've been doing in your subscription. For instance, I have one here prefixed with default workspace. If I click on it to open it up, it'll take me into the navigation bar for it. However, we're going to create a new log analytics workspace. Now, why would you do that? Why not stick with just one? Well, what you can do is determine which virtual machines and storage accounts and automation accounts and so on are linked to a log analytics workspace. So if you're responsible for the eastern part of Canada with Azure, then you might have your own log analytics workspace created with data sources in that region or those regions linked to that workspace for your administrative purposes. So I'm going to go ahead and click Create a Resource here in the portal because I want to create a new log analytic workspace. So I'll search for log. I will choose Log Analytics Workspace, and then I'll click on Create. I'll specify a resource group I want this log analytics workspace to exist in, and I'll give this a name. I'm going to call it Canada East _log analytics WS for workspace. Now, I have a problem here because we have an invalid symbol. We have an underscore. Not a problem. I'll change that to a dash. Not every name that you'll specify in Azure adheres to the exact same rules, so make sure you pay attention to the feedback you're getting when you type things in. I'm going to put this naturally in this example in the one of the Canada regions. Even Canada Central will suffice in this case. I'll click Next to go to the pricing tier. So I want this to be pay-as-you-go. I'll click Next for tagging. I'm not going to add tags. Next for review and create. So the validation is passed. Let's create this log analytics workspace. I'm going to click the Create button to do just that. After a moment, the deployment is complete, so I'll click Go to Resource so we can open it up. Now, in the left-hand navigator, probably the first thing that we should do is go down and just point out a few important items about this. One of which would be the workplace data sources. So we could have data sources that include virtual machines, storage accounts, Azure activity logs. We could even link an automation account here. So at this point, we could even go down to alerts. Now, when we open the alerts blade at the top, we can create a new alert rule. So maybe we want to know when CPU utilization on a virtual machine exceeds a certain threshold value. We could also manage action groups to determine notification methods if we want administrators perhaps notified through an SMS text message or an email or both. So in essence, a log analytics workspace is a centralized container for logging and monitoring information. Because a log analytics workspace is really, in essence, a centralized container for data related to monitoring and performance metrics and log data, then what we want to be able to do then is add data sources and control them. The data sources are feeders that feed data into the log analytic workspace. So to get started here in the portal, I'm in the All Resources view. I'm going to filter it out so we're only looking at log analytics workspaces. So I'll click Type up at the top. I will uncheck Select All, and down in the L's, I'm going to turn on the check mark for Log Analytics Workspace, and I'll click outside of it to put the filter into effect. In my particular case, I have 3 Log Analytic Workspaces, but depending on what you're doing in your subscription will determine how many you have. There's no rhyme or reason. It really depends on what you want to configure. You might configure, for instance, a new log analytics workspace with different data sources for a region that you are responsible for. I'm going to open up an existing workspace here that I have. That's going to open up the properties as always, and in the navigation bar on the left, what I'm primarily interested in here is scrolling down to and looking at the workspace data sources. I'm going to click virtual machines. So virtual machines can be feeders into the workspace. I will get a list of virtual machines on the right. Some will show as not connected. Some will be listed with this workspace, meaning they are connected to this workspace. So for a virtual machine that is not currently connected to this workspace, it'll either say not connected or other workspace if it's connected to a different log analytics workspace. Remember, you can have multiple workspaces in your subscription. Well, I want to link or connect this virtual machine to this log analytics workspace. So I'm going to click on it to open it up. And at the top, I'm going to click the connect button. The status shows connecting, and it won't take too long before this virtual machine is connected to this log analytics workspace. After a moment, it will be connected. Even if we check our notifications in the upper right, we'll see a message stating it has successfully connected the VM to the workspace. So I'm going to click on the breadcrumb trail link to go back to the workspace. I'm going to select a different server that's currently connected to this workspace, and I'm going to click disconnect, and then I'll choose yes. Now that seemed awful quick, and the disconnect button is still lit up, which implies that it's still an option. So why is that happening that way? The truth lies inside of our notifications. So in the upper right, it says it failed to disconnect because it can't modify the VM when it's not running. Okay, so you need to make sure VMs are running when you want to connect and disconnect them to and from a log analytics workspace. I'm going to click on storage account logs in the left-hand navigator, still under the workspace data sources section. From here, we can click the add button at the top, and we can choose a storage account. And within that storage account, we can select the type of data that we want made available here in the log analytics workspace, such as IIS logs, if that type of information is being written into the storage account. So I'm just going to go ahead and click save. Now it shows up. We can also choose Azure Activity Log. Bear in mind that activity logs are related to the administration of Azure resources, not what's going on within them, like application requests for a web app, for instance. That wouldn't be applicable. So on the right, I've got my pay-as-you-go subscription listed, but under the log analytics connection, it states it's not connected. Not connected to anything. Well, that's a travesty. We want it to be connected to a workspace somewhere. So I'm going to click on my subscription to open it up. And just like with the virtual machine, I have a connect and disconnect button at the top. I'm going to choose connect. And just like that, it's done. So if I go back in my breadcrumb trail, the Azure Activity Log blade will now reflect that our subscription, pay-as-you-go, is connected to this workspace. If I go under automation account, I'll also see a reference if there is a link between this analytics workspace and an automation account. Now I'm going to click on the link for the automation account. The automation account will include things like runbooks. So there's a runbooks area over on the left. Runbooks are essentially PowerShell scripts that can be scheduled to automate tasks in Azure. And that's through an automation account. The cool thing about linking the automation account to your log analytics workspace is that if there are any errors, for instance, when a runbook tries to execute, you could get alerts that show up centrally in your log analytics workspace instead of having to check all the alerts for each individual automation account. So that's a good feature. The other thing is update management if I'm working with updates. So in the left-hand navigator, if I click update management, this is one of those features that requires you to link the automation account to a log analytics workspace, and that's already been done. Update management, like the name implies, allows you to manage the updates that get deployed to Windows virtual machines. So there you have it. We have a lot of great reasons to think carefully about how many log analytics workspaces we need and which data sources should be connected to them. One of the problems that can arise over time when you use a lot of cloud computing services is the lack of a centralized place to monitor your resources. And that's where Azure Monitor comes in. Here in the portal, in the top center search bar, I'm going to search for Monitor, and I'm going to click on Monitor. That's going to take me into the Microsoft Azure Monitor service, where in the left-hand navigator, I have quite a range of options available to me. So first of all, if I go down and click on Alerts on the left, from here, I'll see if there are any alerts that have been generated and reported here. Now, I can also configure a new alert rule and also manage my action groups, which are used to determine notification methods when alerts occur. I can also click on Metrics over on the left. Now, metrics are used to monitor things like the performance of a virtual machine in terms of memory utilization, network traffic, CPU utilization. So it's asking me here to select a scope. So I can select a specific subscription, drill down into a resource group, and I can start choosing specific resources. For example, I'll choose a virtual machine named DC1, and from there I'll click Apply. Now, after a moment, it allows me to select a metric from the drop-down list associated to a virtual machine host. So I can scroll all the way down and choose something that is of interest to me. For example, percentage CPU. The default aggregation is average, and it will plot the information on the chart listed below. So I can see if I have any peaks in my activity for CPU utilization for that particular host. Now, you can, of course, view the same type of information when you go into an individual resource, such as the DC1 virtual machine. We can also pin it to a dashboard. We've got the option towards the upper right to do that. I can choose to pin to the current dashboard, or I can choose select another dashboard, and if I have one, I can choose it from the list. The benefit here is you can pin what's very relevant and important to a dashboard, and then simply open up the dashboard instead of having to drill down through many different places to find what it is you need. So from the drop-down list for dashboards, I'm going to choose one I already have called Dashboard 1, and I'll click Apply. And it's done. So I'll just click the X to close out of that. If what's been charted here in your metrics is of grave importance, you can also go under the Share button at the top and either download this information into an Excel spreadsheet or copy the link and provide it to people that have at least the monitor reader type of RBAC role permissions. So I'm going to choose Download the Excel spreadsheet, and I'm going to go ahead and save it. So this is what you can expect to see in the Excel spreadsheet. So we've got some header information up at the top, including the date and timestamp information. But as I scroll down, I can see the date and timestamp and each point that was plotted on the graph, in this case, for the percentage CPU average. Now, why would you want to do this? Because you have more control. You can massage this data and create visualizations any way you see fit if you have all the information in an Excel spreadsheet. So that's another good option to think about. Over in the left-hand navigator, if I drill down here in Azure Monitor, I have an Insights section. This provides an absolute wealth of information for monitoring. Let's start by clicking on Applications on the left. This is going to present me with a list of web applications whose details I can monitor. So on the right, two web apps are listed, East App 1 and West App 1. I'm going to click directly on the link for East App 1 so I can view details about that web application. Now what that does is opens up the application insights for that specific web app, which provides a wealth of information. I'm in the overview blade on the left for application insights, and on the right as I scroll down, I'll have some details related to requests and response time, such as failed requests for the web application, server requests, and also availability. But as is the case when you're viewing many of these types of details, always make sure that you're viewing the monitoring details over the time frame that is relevant for your current need. At the top, we're currently showing data for the last 1 hour, and that might be what you need. But if I want to see it over a longer period of time, for example, 7 days, then I would click 7 days at the top to make sure that I track things appropriately. Maybe I'm looking at tracking this type of performance for this web app over the last week. So we can also do that. So I'm just going to click the X over in the upper right to close out of that for East App 1. On the left, still under the Insights section in the navigation bar, I can click on Virtual Machines. Over on the right, there are 0 monitored virtual machines, but there's a note here about 3 not monitored virtual machines. Well, it seems like a travesty to not have them monitored here. So I'm going to click directly on 3 not monitored, and I can see the virtual machine shown here. I'm going to click the Enable button for the first virtual machine listed, and then I'll click the Enable button again. So there's a message at the top stating that Insight's deployment is in progress. Please wait. There's also a note stating it can take between 5 and 10 minutes for this to be set up and for data to show up here. So you need to be patient when you are enabling monitoring of a resource initially for data to show up here in Monitor. After a moment, if I open the notification area in the upper right, I'll see that the deployment succeeded. I'll just click the refresh button up at the top. And DC1 is now shown as enabling waiting for data. So we could do this for each of the virtual machines that we want monitored here in Azure Monitor. While that's happening, let's continue on. We'll come back here. I'm going to click Storage Accounts over on the left. Now, this is a great way to centrally monitor details related to all of your storage accounts and the activity. So people placing data into storage accounts or downloading data from them or any errors that might have resulted from those activities. So over on the right, I'm going to scroll down. I have a list of storage accounts in my subscription with a column showing the number of transactions, the transactions timeline of when we had activity, any latency, and also any errors, which will show up here in red. And I can click directly on the link for the errors to drill down into that to examine it further. So I can start to see when I was having any types of failed transactions with the storage account. And as I keep scrolling down, I can start to determine that in this case, it's related to blobs within the storage account as opposed to message queues or tables or Azure files shares. So I'm going to go ahead and click the X in the upper right to close out of that. That can be very useful information. We can also click on Networks over on the left if we want to get a general sense of our network configuration in Azure. Things like network interfaces, network security groups, public IPs, virtual networks. So for example, if I were to click on virtual networks over on the right, it would drill down into my virtual networks where they are listed down at the bottom. And I would be primarily interested in the alerts column if there are any alerts related to any of those networks. They are currently all showing a value of 0 for the alerts. We can also click on the connectivity link up at the top to see if there are any problems with unreachable networks. So all of the alert counters are set to a value 0. That's good in this particular case. So I'm going to click the X up there. If I scroll down in the left-hand navigator, I can also click on Diagnostic Settings. Think of this as one-stop shopping, Azure Monitor. Here I'm going to be able to determine if diagnostic logging is enabled or not for various Azure resources. I can look under the diagnostic status to determine if that's enabled or not. So if I navigate back to virtual machines on the left, DC1 is now shown under Monitored. And if I click the link for it, we'll be able to get some more details about the performance of that VM. So I'm going to click the Performance tab up at the top. We're then shown a time range of the last hour, but we could, of course, select that and choose a different time frame, such as the last 30 days, which I'm going to do, and I'll click Apply. We're provided then with details about disk performance within the VM over time, so the current size, the current use in percentage, IOPS or disk I/O operations per second statistics, latency for read and write, a lot of details on the disk activity. As we scroll further down, we'll have charts related to CPU utilization, available memory, and again, some disk IOPS charts, and so on. So there's a wealth of information then that can be gathered through Azure Monitor. In Azure, you can work with dashboards to essentially bring some order to the chaos that is administering all of these Azure resources in the cloud. So we can take what's relevant to us and place it on a dashboard and pull up that dashboard instead of looking at other things that might not be as pressing or relevant for Azure administration. So to get started here in the portal, I'm going to open up my navigation bar on the left because I want to click on Dashboard. This will show me any dashboards that I have available. All we have is a default one called My Dashboard. I'm going to click on the plus sign to add a new one. And over on the right, I'm going to name this Canada East. So it's the Canada East dashboard. Now in the left-hand navigator, I've got what's called the tile gallery. And we've got a number of different tiles that we can add to our dashboard on the right. For example, I have the All Resources view, which I can add. So I'm going to click Add for All Resources, and that will add it over onto the right on my dashboard. I can click and drag to move that item anywhere I want on the dashboard. So I really have control of where things are placed relative to other ones. I can also use the context menu, the three little dots in the upper right of this tile item, and I can change the size. For example, if all I want is a 4x4, then I can view it smaller that way. So you can adjust the sizing that way, just like you could by clicking and dragging from the bottom right. Really depends on what your requirements are. I'm also going to add resource groups. That might be something I might be interested in. So I'm going to drag that over to the right of all resources, so I have an easy way to do that. If the nature of my work in Azure is that I'm working with Azure AD users and groups, why not have that there for convenience? So for users and groups, I'm going to click Add, and you'll see that it shows up over on the right. So again, I can go to the context menu, and I can refresh it if it's out of date. But notice that this one doesn't give me the sizing options that we had in the context menu for the other tiles that we added from the gallery. So I'm happy with this dashboard. I'm going to click the Done Customizing button up at the top. Now, back in our list of dashboards, which we can select from the drop-down arrow in the upper left, we see Canada East in my dashboard. So we have an easy way to get to them in that sense. But let's go back into Azure. Let's say, for example, I'm going to go and look at my virtual machines. There would be times where you might be monitoring something like virtual machine metrics and decide that you want to add something that you're viewing to a dashboard. So let's open up the DC1 virtual machine. That's going to put us in the overview blade. I'm just going to scroll over to the right within the overview blade. And I'm then going to scroll down because I've got a couple of metric charts that are here automatically for the virtual machine, one of which is called Network Total. So let's assume that that's one I'm very interested in monitoring frequently. So for convenience, what I might want to do is place that on a dashboard, which would be quicker than navigating into this virtual machine like we've just done. So I've got a little push pin icon in the upper right of that metric chart that says pin this chart to the dashboard. And when I go ahead and click it, I'll see in the upper right, I'll have a notification message that says it was pinned to the dashboard. And if I click on the link for pinned to dashboard, that'll take me into my dashboard area. And because Canada East was the last active dashboard, we'll see it's listed at the bottom, our network total metric chart. However, if I want to arrange that or organize these panels, including the new metric chart that was just added, up at the top, I could click the little pencil to edit my dashboard. That will allow me to move things around so that it makes the most sense for what my needs are. When I'm finished, I can click Done Customizing. The other thing that's important is you might want to go into your configuration options. So my portal settings, I can click the cog icon in the top of the toolbar towards the right. Now what's interesting is the default view when I open up the portal is home. But what I could do is select dashboard. Now by doing this, it means whenever I open the portal, I'm going to be placed directly in my dashboard area. Let's see if that works. I'm going to go ahead and sign out of my account here in the portal by choosing Sign Out in the upper right. And sure enough, when I sign back in, the first thing I'm presented with is my Canada East custom dashboard. Tracking metrics in Azure is an important part of monitoring your Azure ecosystem because when you monitor metrics, it might emphasize that there's a problem with the web app. Maybe it's overloaded or clients are receiving certain types of web app errors, or we would be able to determine how available a storage account is, how busy a virtual machine is, and so on. One way we can work with metrics is by doing it at the individual Azure resource level. For example, I'm going to open up my storage accounts view here in the portal, and I'm going to click on an existing storage account to open up its properties. In the overview blade, which we're placed on automatically, if I go over to the right and then scroll down, we do have some access to a couple of charts, such as for total egress and total ingress activity. So for data coming into the storage account versus data leaving the storage account. We have average latency and the request breakdown type, but if I scroll down on the left-hand navigator, I can then go under the monitoring section and I can click on metrics from there. Now this will give me an empty skeletal type of chart, and the metric drop-down list is opened up waiting for me to select something. So maybe, for instance, I'm interested in looking at the used capacity for the storage account. So it gets plotted on a chart. I can see that I have approximately 4.5 gig of space used. But that's for a storage account. Let's go back to home here in the portal, and let's open up app services. We can look at metrics for many different types of resources, including app services or web apps. So I'm going to open up one of my existing web apps, and we're going to take a look at some of its metrics. So again, we're placed in the overview page, and over on the right, if I scroll down, I have a couple of charts that are available for HTTP 500 series errors, data in, data out for this particular web application, requests, the average response time. But as always, I can scroll down in the left-hand navigator and go all the way down under monitoring, and once again, I can click on metrics. So we're going to get an empty skeletal chart where the metric drop-down list is open. And these metrics are different because it's for a different class of object. This is for an app service as opposed to a storage account. So I can select whatever is of interest to me from the drop-down list to have it plotted on the chart. And I can add metrics by clicking the Add Metric button. I can also add a filter if I want, change the chart type. So for example, if I click on line chart, the current default chart type, I might choose grid if I just want to see the raw numbers. The other thing to bear in mind is that when you are looking at this information, you want to make sure that you know whether you're looking at the sum, the average, the min, the max. When you go to add a metric, you'll be able to select a metric and you will be able to select the appropriate aggregation. Here in the portal in the top center search bar, I'm going to search for Monitor. I'm going to open up Azure Monitor because that's a central way that you can also work with performance metrics. So in the left-hand navigator, I'm going to click on Metrics. Now because we didn't start off within a specific Azure resource, we're going to have to select the resource by browsing through our subscription and then resource groups. So I'm going to open up an existing resource group until I come across a resource I'm interested in looking at metrics for. So in this case, I'm going to choose a VM called DC1. I'll click on it and then I'll click the Apply button down at the bottom. Then I can select the appropriate metric or metrics, I can have more than one, that I want charted from the metric drop-down list. So for example, maybe what I'm interested in, so from the metric drop-down list, I'll go ahead and select percentage CPU, which then gets added to my chart listed below. So we can centrally do this from here. We can also share these metrics by going to the Share button and downloading as an Excel spreadsheet or copying the link and providing it to others. And we can also build a new alert rule based on this specific metric if we want to be notified when, in this case, the percentage CPU for DC1 reaches a certain value. And we can also pin to a dashboard for quick access. If I choose pin to dashboard, I can choose select another dashboard, and if I've created a custom dashboard, I'll be able to select it from the list. So from the dashboard list, if I don't have any, I won't have any shared dashboards, but I'll have the ability to create a new one by choosing Create New at the top. So I'm going to call this new dashboard VM Stats, and I'm going to click Apply. So now if I open up dashboards in the left-hand navigator, so I'll click Dashboard, then from the drop-down list, I'll be able to choose, in this case, VM Stats, where I'll see my average percentage CPU for DC1 is shown. You can enable diagnostic logging for a variety of different types of Azure resources, such as storage accounts, content delivery network configurations, and also virtual machines, to name just a few. So to get started here in the portal, let's begin by navigating to virtual machines. What I'm going to do is click on an existing virtual machine, and we're going to take a look at how to enable diagnostic logging for detailed log information. So I'm going to click on the VM to open up its properties. And in the left-hand navigator, I'm going to scroll all the way down under Monitoring, where I will then click on Diagnostic Settings on the left. Now, it's not yet been enabled, and to enable it, you have to make sure the VM is running. This one is running. So I need to select a diagnostics storage account. So I'm going to select one that I already have, although I do have a link to create a new one if I want to make a new one. And I'm going to click the Enable Guest Level Monitoring button. After a few moments, we'll then have the option of going in and looking in at some of the diagnostic settings details. So we have the overview, but at the top we can also click on performance counters, where basic performance counters for CPU, memory, disk, and network will be logged. We can change this. So if we know that this virtual machine will be running SQL Server, we can also flick on diagnostic logging for that item and specify the sampling rate in seconds, which defaults to a value of 60. I can also click on logs up at the top because I get to determine which logs I am interested in including from within the VM OS, which type of log events. So for the application log, we might want critical, error, warning. Those are flicked on by default, but information and verbose are not. For security, maybe I want the audit failure to be logged. That's turned on. For the system log in Windows, critical, error, warning. So we get to determine all of these details, what is included with diagnostic logging for the VM. I can also scroll down and turn on IIS logs if I want to specify that I want that included in diagnostic logging. I want to grab the web server logs from within the Windows VM operating system. So we have a number of options related to that. We can also configure crash dump collection. We can also go under syncs, and we can specify if we want to send diagnostic data to App Insights. So I can enable that. And finally, under agent, I can also go under agent and specify a storage account to store agent-related information. I can set the disk quota. We can see the log level is set to error. So I'm going to click Save at the top to save these diagnostic log settings. You can then go to Logs in the left-hand navigator and put together some log queries to start running queries against that logged information to get more insights about your VMs. So once I'm in the Logs panel on the right, I can scroll down under the virtual machine category. And as an example, I might expand Security Event, under which I then see all of the fields available, including things, if I go down to the E's, like the event ID as it would show up in Windows. I could start double-clicking these items, which puts it in the query builder, so I can build up a query to start getting some results back about this. We could also, if we scroll down the left-hand navigator, enable boot diagnostics for a virtual machine. Now again, this will result in data being stored within a storage account. In this case, for this virtual machine, it hasn't written anything here yet, but let's take a look at a storage account to see one that has been running for a long time. So I'm going to go back home here in the Azure portal. I'm going to click on Storage Accounts, and I'm going to go into a storage account container that's used for boot diagnostics for another VM. So I just have to click to open up that storage account, and then I'll scroll down on the navigator, because what I really want to do here is go to Blob Service and then select Containers. And then what I'll see are some boot diagnostics logged information for specific hosts. So if I click on one of those, then I can see that I've got essentially a screenshot for boot diagnostics here for a couple of different date and timestamps. So I can click to open that up. That'll open up Properties Blade. But in the Properties Blade for a storage blob, I then have the option of clicking Edit to see it. And when I do, I'll see it's a screenshot that was sent as part of boot diagnostics for that VM. When you host web applications in the Azure cloud, you need a way to not only log the activity, the management activity of that resource in Azure, but you need some details about the application itself. And that's where Application Insights comes in. Let's start here in the portal by going to the All Resources view. And I think the first thing I'll do is filter it out for app service plans and app services or web applications. So I'm going to go to type equals all. I'll click on that and I will uncheck select all, but I will turn on the check mark for app service and app service plan, and I'll click outside of it to put it into effect. The first thing I'd like to do is just open up an app service plan. When you deploy a web application in Azure, it's linked with an app service plan, whether you build a new one or link it to an existing one. And when I'm in the overview blade for the app service plan, I have a couple of performance metrics, although understand that this would apply to all of the apps that are a part of this app service plan. We'll take a look at those in a second. So we've got charts here for CPU percentage, memory percentage, data in. If I scroll down further, data out. And if we click in the left-hand navigator on apps, then we'll get a listing of applications that are linked with this app service plan object. And there are two of them, East App 1 and Migrated App 172. So when we look at performance metrics for the app service plan, we have to have that understanding. It would apply to the apps, but we can get more detail on a per app basis. I'm going to click on Migrated App 172. That's just a very simple web application that's currently running and hosted in Azure. Now, to get some real details, and not just summary information for all of the web apps in an app service plan, but for real details at the application level, you need to enable application insights for the app. So now that I've opened up my app service, I'm going to scroll down in its navigation bar, and under settings on the left, I'm going to click on application insights. If it's not already been enabled, then you'll have a button here like I do that's labeled turn on application insights, which I'm most certainly going to do. I'm going to click on that button. Now, the next thing I have to do is make sure it's enabled. It will be by default by clicking that. And I also have to specify the name of an application insights resource that will be created. So it's suggested a name and a location down below. I could also choose an existing app insights resource, but I'll let it create a brand new one. And here for the collection level under .NET, assuming that's what my web app is using, I can then scroll down and use recommended for the collection level. The profiler is going to be important. I'm definitely going to want that one on. This will allow me to see any code paths that are taken when the application is being used normally. Scrolling down, I want the snapshot debugger turned on so that when we get an exception thrown in our app, we can go back and play through it to see where the problem occurred. We can even turn the show local variables for your application when an exception is thrown option on so that I can see the variables that existed in memory at that time when an exception was thrown for the web app and what the values of those variables were. And as a developer, if you've done a lot of work that way, you'll know that that is absolutely crucial and paramount in quickly troubleshooting problems with a web application. We can also turn on the dependency tracking for compiled SQL statements and variables that might be present in web requests. So I'm going to go ahead and click the Apply button at the bottom, and then I'll choose Yes. Now, back in the All Resources view, I've included in my filter Application Insights Resources. So my original app service or web app is called Migrated App 172, and I've got an object with the same name but of a different type, of Application Insights type. So I'm going to click on that Application Insights object now that we've enabled it. Now, it's not necessarily real-time information from the web application. So if you've got recent activity, especially through testing, it might not show up right away. In the overview blade for my App Insights item, on the right, I've got a couple of charts for failed requests, server response times, server requests, and overall availability. But in the left-hand navigator, I've got a number of tools I can work with down on the left. For example, if I click on failures, then on the right, I'll have some details about any problems encountered with my app. Now, that's not necessarily just the app itself without user interaction. It could be users passing invalid types of requests to the server, if there's a form-based front end, and that type of thing. And what I can do is under Operations, Dependencies, or Exceptions, if I click Exceptions, if there are any humps in the chart, it will imply that there were exceptions. And I can click and drag to highlight over that area, and I'll see the details listed for those exceptions within that time range shown on the right. So I can start to troubleshoot what the problem might have been. Using Microsoft Azure results in ongoing monthly operational expenses. Now, we can analyze those costs through the portal. So here in the portal in the top center, I'm going to search for sub, and I'm going to click on subscriptions. You could say that a subscription is kind of a loose boundary for creating Azure resources. It's tied to an Azure AD tenant, and it also has everything to do with billing. I've got a subscription shown here for pay-as-you-go, and I can see the current cost is a value of $174.18 Canadian, and the status is that this is an active subscription. Well, I might look at my cost and wonder, well, where does that come from? How is it broken down? Is it virtual machines that are left running? Is it databases in the cloud? Is it a lot of storage space being used with a storage account? Well, that's when we would then click on the subscription to get into some details. If I scroll over to the right, we have information related to our last billed amount, so we can compare it with the current month. We have a chart showing our last billed amount versus the current month's bill, so we can see very easily what the difference is. And I have a breakdown by the top services. So by far, storage is the bulk of the cost here in the amount of $71.78 Canadian, followed by Azure App Service, Azure Active Directory Domain Services, virtual machines, and so on. So we get a general sense of where the costs are coming from. Now, the great thing about this overview blade when you go into your subscription is that you also get a spending rate and forecast chart. Now, that's assuming the continued use of resources compared to the previous month. So it may or may not be accurate. It really depends on what you actually end up using. Now, over on the left, I can also click Cost Analysis. Now, when I do that, I'm presented with a chart that is trying to show me the accumulated cost as well as the forecast cost on a chart. I then get a breakdown based on the services used, whether it's storage or Azure App Service and so on. I also have a breakdown by location, geographical region. So it looks like the bulk of the costs in my particular case come from Canada Central, followed by Canada East, followed by US East, and so on. I can even see it by resource group, because you might use resource groups to group related resources for a project or some kind of a dev environment. So for billing purposes, it's easy to track when you do things by resource group. Up at the top, we also have the option of clicking the export button, where we can choose to export what we're looking at as a PNG format, Excel, or CSV. We also have the option of clicking cost by resource. Now, this one is really important because it allows us to determine the specific individual resources generating costs as opposed to the resource type. It's wonderful to know that virtual machines are costing me $100 a month, but wouldn't it be great to know out of your 100 virtual machines, which one is by far the lion's share of that cost? So we're going to have a listing of all of our Azure resources, and as we take a look at our list, we'll be able to see the costs associated with each and every individual item. This is important, not only to determine where the current costs stem from, but for future planning. Now, not only that, we can also add a filter up at the top by clicking the Add Filter button. And what I might do is filter by location, if that's what I'm interested in seeing. And then I can choose a location from the drop-down list. In my example, I'm going to turn on only Canada Central, CA Central. And when I do that, it filters out, in this case, what I'm looking at, which is my cost by resource, only for the Canada Central or CA Central region. This can be verified by checking out the data under the location column. It's all Canada Central now. We're not seeing anything else. So this is a great way to start breaking down all of your charges and determining where they stem from, which can help with future budgeting. Knowing how to go in and analyze costs in your Azure subscription is certainly an important skill, but it's also important to know how to create a budget so that you can be notified when a specific price ceiling limit is reached, instead of you having to go back into the subscription all the time to monitor things. So to do that, here in the portal, in the top center search bar, I'm going to search for sub and I'll click on subscriptions. Now I want to click on a specific subscription because billing is tied to this subscription. I'm going to click on my pay-as-you-go subscription to open up its details. And in the left-hand navigator, I have an option called Budgets, which I will click on. Any existing budgets, because you could have more than one, will show up in the right-hand panel. I don't have any, so I'm going to go ahead and click the Add button. The first thing that I have to deal with when I build a budget in Azure is the scoping. Do I want to look at billing and get notifications at the subscription level? This is the default scope. But I could click Change Scope, and from here I could navigate through my Azure AD tenant, any management groups I might have. Management groups simply are used to organize multiple subscriptions together to facilitate things like policy assignments. But within a subscription, I can also select a specific resource group that I might want to set a budget for. You might do this for a project manager whose resources are always deployed in Azure into a specific project management group. And then that way, not only does that facilitate billing for resources in that resource group, but also setting budgets. I'm going to click the cancel button though, because I still want this budget scoping to be set to the default of my subscription. Then I need to give a name to the budget. So you can't use spaces between words, so I'll just use dashes. I'm going to call this monthly subscription budget. The reset period where it starts recounting is up to you. The default is every billing month, but you could choose billing quarter, billing year, monthly, quarter, annually. It's up to you. I'll leave it on billing month, and I'm going to set an expiration date 2 years down the road. Then I have to specify the budget threshold. Now, the great thing about this, to help you along with setting that to a meaningful value, is down below we are presented with information for last month's cost, the maximum over the last 5 months, and the maximum monthly forecast. So it gives you a general idea of what to think about when setting your budget threshold. As I scroll down, I have a chart that shows me the forecast, actual, and budget. Well, there's no budget yet, but that's the information that we're given. So I'm going to set this, let's say, to $100. Now, based on my subscription, it's set in Canadian dollars. So I'm going to go ahead and click on Next. I'm just going to make sure I scroll up because I'm going to set a percent of the budget when I want an alert set. So let's say when we get to 80% of our budget, we have an action group that triggers to do something, to send some kind of a notification. Now, I don't have any meaningful action groups here, but that's okay because I've got a link down below to manage action group, which I'm going to click on. I want to be notified via email. It could be through other means, but here in the action groups, I'm going to click the Add Action Group button up at the top. I want to add an action group that's going to make sure notification gets sent when 80% of our budget is reached. So for this action group name, I'm going to call it Notify Admins, and I'll use the exact same thing for the short name down below because that's a required field. And I'm going to scroll down and I'm going to click in the action name. I'm going to put in email notification for the action name. And in the action type drop-down list to the right, I'm going to choose email. Now, email, SMS, push, or voice. But we could trigger an automation runbook. We could trigger an Azure function or a logic app or a webhook. In this case, I'm just going to choose email, SMS, push, voice. And then I have to specify the details related to that selection. So I'll turn on the check mark for email and I'll fill in admins at quick24x7 test.info. So assuming that's a valid email address for a group, then we're good to go. I'm going to scroll down and click on the OK button and OK once again. So now we've got an action group that was just created or is in the midst of being created. So after a moment, it shows up in the list. I'm just going to click the X in the upper right to close out of that. Back at the Set Alerts portion of configuring our budget, I want to make sure I go into the action group drop-down list where now I'm going to see Notify Admins. And it says one email is the result of that notification type. Notice that we can also set alert recipients' email addresses down below if we have a specific user or group that should also generically receive alerts related to this. So I'm going to specify an administrative individual email, and then I'm going to click Create. And that will then put me back in the Budgets view where the newly created budget is currently showing up. Action groups are used in Azure when you have alerts and notifications that you want treated in a specific manner, such as sending notifications to email addresses or through SMS text messaging or push notifications or running an Azure function or some kind of a webhook URI. So to get started here in the portal, I'm going to type in the top center search bar monitor. The reason I'm doing this is because this is where I can go. It's a central location for monitoring purposes that also includes a central way to work with action groups. To do this, in the left-hand navigator for Azure Monitor, I'm going to click on Alerts. This is where we need to go. Now, not only can I view and configure alerts here, but I can also manage actions. We've got a button with that same title at the top. So I'm going to go ahead and click on that. What you can expect to have listed are existing action groups that might already have been created. And I have one shown here. But I'm going to click the Add Action Group button up at the top to create a new one. What I want to do is create an action group so that an administrator in Azure can receive notifications through SMS text messaging. The action group is kind of like a container that can consist of multiple actions. We can see the action type drop-down list down below, where the action might involve running an automation runbook. A runbook is really a PowerShell script, or it can trigger an Azure function. It can email an Azure Resource Manager role. It can send a regular email to an email address or SMS text message, push or leave a voicemail. It can go to ITSM, which stands for IT Service Management. You'd have to have an ITSM connector for another ITSM tool that you want to trigger. We can also trigger a logic app, a secure webhook, or just a webhook. If I were to choose webhook, for example, then I have to provide details like the URI that I want to send this notification to. And presumably there would be a listener component at that URI that would process what is being provided to it. So in this case, I'm going to open up the list and I'm going to choose email, SMS message, push, voice. And that'll pop up a new blade where I have to fill in those specific details. I'm primarily interested in SMS. So I'm going to turn that on. The country code has to be specified and the actual phone number, which I'll do here. Once I've done that, I'll go ahead and click the OK button at the bottom. I have to give a name to that specific action. So I'm going to call this SMS text message to admin. Now, remember we said that this action group is kind of like a container that could consist of multiple actions. So for the action group name, I'm just going to call it notify admins, and I'm going to use the exact same thing for the short name field because it's required. Now, having done that, I'm going to click on OK. So at this point, we've got our action group that's going to show up in this view in a moment once it's been created. And I can see it listed here with the short name, the resource group affiliation, and the fact that it's enabled, and the action, which is showing here as one SMS message. So in the breadcrumb trail link in the upper left, I'm going to go back to monitor alerts. If we were to create an alert rule, we could then use that action for notifications. For example, if I were to click the new alert rule button up at the top, one of the things we'd have to specify in the alert rule, and I'll just go down, we could see that we would specify the action group to send notifications. The select action group link is unavailable because we haven't yet configured the rule with the scope and a condition and so on. On my phone, if I take a look at my text messages, I will see I've got a message telling me I'm part of the notify admins group and that I can reply stop to stop all. Configuring Azure alerts allows you to save more time because instead of going into individual Azure resources to check on them, to see how they're performing and so on, you can instead have notifications sent to you when something occurs given a configured threshold of your choosing. So here in the portal, let's start by looking at the alert configuration for an individual Azure resource like a virtual machine. So I'm going to open up an existing virtual machine, and in the navigation panel on the left, I'm going to scroll all the way down to the monitoring section where I'll then click on alerts. So I'm configuring alerts here for a specific virtual machine. We don't have any current alerts that have fired off or triggered. That's the first thing that we would see if that were the case. Instead, I'm going to click the new alert rule button up at the top because we haven't got any configured yet. So the resource is already selected since we went into this virtual machine to begin with, although I could change that. But I'm going to leave the scope set to my virtual machine resource. Down below, I now have to specify a condition for that virtual machine. So I'm going to choose Select Condition. I'm then presented with a list of signals for that particular type of resource. So for a virtual machine, percentage CPU, disk read bytes, disk write bytes, and so on. I'm going to choose percentage CPU. And I can then see I've got a chart that shows me what the CPU utilization has been by default over the last 6 hours. I might say over the last 24 hours to get a more broad sense of what's going on, because I want to make sure I'm configuring a reasonable alert. If I set the alert for whenever the CPU is greater than 10%, and it's always greater than 10%, then I'm always getting an alert and it doesn't have any meaning. So in this case, I don't really see much above 50%, so that's good to know. So down below, I'm going to leave the operator set to greater than, but I could choose greater than or equal to, less than or equal to, less than. I want the average aggregation for the CPU utilization for this VM. If it's greater than 80%, then I want to know about it. So it's going to evaluate this with an aggregation granularity period of every 5 minutes. That's the aggregation. The evaluation itself will occur every 1 minute. It'll be checking the CPU utilization. So I'm going to accept those, and I'm going to click Done at the bottom center. So we've now got our resource selected at the top. We've got our conditions selected below that. The next thing we have to do is specify an action group that should be used to do something, whether it's trigger an Azure function or whether it's to send an email message, depending on how the action group is configured. I'm going to click the Select Action Group link. That's going to give me a list of existing action groups, but I can also click the Create Action Group button at the top. I've got a previous action group I've created called Notify Admins that I'm going to select. And the action that's contained within that is to send one SMS text message. So I'm going to go ahead and click the Select button down at the bottom. As I scroll further down, I have to give this alert rule a name. Now, this virtual machine is called DC1, so I'm going to call this DC1 Busy CPU. And there's nothing else I'm going to change, so to create this rule, I'm going to choose the Create Alert Rule button in the bottom left. Because we have at least one alert rule for this resource, when we're viewing our alerts, we have a message that states all is good, you have no alerts. We could go back to the Manage Alert Rules button at the top to see any configured alert rules and maybe add new ones, edit what's already there, or delete the one that we've created. I don't want to delete it, I want to keep it there. So now that that's done, another option is to configure alerts more centrally through Azure Monitor. So in the top center search bar, I'm going to search for Monitor, and I'm going to select Monitor from the resultant list. So Azure Monitor is like centralized one-stop shopping. So I could see in the left-hand navigator for Azure Monitor alerts. And if I have any alert notifications, they will be shown on the right. Otherwise, I can click the Manage Alert Rules button at the top, just like we did within our individual virtual machine. Now you're going to see any existing alert rules that might be associated with Azure Monitor. So there are some here created automatically for web applications. But just like we did for the virtual machine, we can also click the New Alert Rule button up at the top and add an alert rule here centrally in Azure Monitor. The only difference is that the resource won't be automatically selected because we aren't in a specific resource that we want to create the alert for. So I would click the Select Resource link, and then I would choose the resource of interest. So I'm going to filter the list for VIR, and then down in the list, I'm going to choose virtual machines. And here I can select, for example, DC1, which we had done previously. So I'm going to go ahead and select the DC1 virtual machine. Then I have to specify the condition. So I'll click the Select Condition link. Now, in this case, maybe I'm more interested in the number of disk read bytes. So I'm going to go ahead and perhaps select that and specify a threshold value. So maybe if it's greater than a specific value that makes sense based on what's been charted here. So maybe I'll put in 500 million. That would be bytes because this unit of measurement is bytes. And then down below, I'm going to accept the default aggregation granularity period and the evaluation period, which is every 1 minute. And I'm going to go ahead and click on Done. So at this point, we've got the condition specified. Now we need to specify the action group like we did previously. So once again, I can click the Select Action Group link and either create an action group or choose an existing one for notifications when this configured condition is reached. So I'll click Select to choose an existing action group, and I'm going to give this a name. For the alert rule name, I'll call it DC1 Disk Read. And then I'll click Create Alert Rule at the bottom left. And after a minute, if I click the refresh button, not only will I see our new DC1 Disk Read alert, but I'll also see the alert that we created in the individual virtual machine, DC1 busy CPU. We can use the Azure portal to drill into a specific Azure resource and check out any alerts that might be a result of some configured threshold being violated. We might also just view things like performance metrics. For instance, here in the portal, I'm in my virtual machines view, so I'm just going to go ahead and click to open up an existing VM. And sure enough, in the left-hand navigator, if I scroll down, we'll have the option of taking a look at alerts and metrics down here under the monitoring section. Now that's fine for an individual resource, but we can also do this through Azure Monitor. So here in the top center search bar in the portal, I'm going to search for Monitor, and I'm going to choose Monitor. That's going to take us into the Azure Monitor service. Now in the left-hand navigator, what I want to do here is click on Metrics. Now, because we're doing it from this centralized Azure Monitor perspective, it doesn't know what the resource is for which we want to view metrics. So this way, we have to select a scope. Now, down below, we can go through a specific subscription and resource groups until we come across the resource we're interested in viewing metrics for. This means then that you could actually add metrics from across multiple subscriptions. So for instance, here I'll choose a virtual machine and I'll click Apply. In the metric drop-down list, we can then select the appropriate metric or metrics. You can add multiple metrics that we want added to the chart. So maybe I'll scroll down in the list. I'm interested in network traffic in total to this particular VM, and it gets plotted down below automatically using the sum aggregation. But I might be interested in the average network traffic in. We can also, depending on what our needs are, add multiple metrics. If I click the Add Metric button up at the top, we get the same drop-down list for the selected virtual machine, and we can choose whichever item we feel is relevant, such as percentage CPU, let's say. The legend for the chart will reflect that we've added 2 metrics. Now, while we can view these types of metrics for an individual Azure resource, doing it this way centrally in Azure Monitor is a bit easier because we don't have to reach out to each and every resource. It's one-stop shopping in one location. One way to keep costs down within Azure is to monitor for unused resources and either stop them, such as if it's a running website or a running virtual machine, because if you don't stop it, you're being charged while it's running. But the other option is to remove or delete the item if it's no longer required. So we want to make sure that we focus not only on unused resources, but also on unnecessary resources. So to get started here in the portal, why don't we navigate to our virtual machines? One of the first things that we can do is monitor activity over time to see if something's being used or not. So let's say I were to go into a virtual machine by clicking on it. Now in the overview blade, which we're placed in by default, if I were to scroll down over on the right, I've got a couple of items that are charted. But if I look at the timeline, which is labeled as Show Data for Last, it defaults to 1 hour. Well, that's not going to give me a really good indication as to whether this virtual machine is used often or not. What about activity over the last 30 days? So I'm going to click 30 days. Now, if I only see very small periodic spikes, then it could indicate that this virtual machine is not being used often. And because it's so easy to deploy resources in Azure, such as virtual machines, sometimes you can end up with VM sprawl. You have a lot of virtual machines that were deployed, but nobody turned them off or removed them when they were finished with them because it's so incredibly easy to do, but also easy to lose track of. So this is one way that we can track utilization over time. Has there been activity? The other thing to think about is going into Azure Monitor. So in the top center, I'm going to search for Monitor. Azure Monitor is a centralized place where we can have data fed and we can configure alerts and metrics. So it's centralized monitoring. And if I scroll down in the left-hand navigator all the way towards the bottom, one of the things I can click on is Advisor Recommendations. Depending on your Azure subscription and how you've configured resources will determine whether or not there are any recommendations here related to unused resources. Now, I have a medium impact item shown here. It states that we should delete a public IP address because it's not associated to a running Azure resource. Well, that's an interesting point. Why would we have that if we're not using it? Now, maybe you have it there temporarily until you build a virtual machine and attach it to that public IP address. There's a potential benefits column that also tells us or gives us an estimation of the cost savings that we might think about by, in this case, deleting public IP addresses that are not used. The next thing I'm going to do here is search for sub in the top search bar, and I'll click on subscriptions. Sometimes the way that you can identify resources that aren't being used or perhaps are being used but are no longer really needed is by looking at your bill. So when I go into Azure subscriptions, I can click on one of my subscriptions. I've only got one, and I can click cost analysis over on the left. Now, when I scroll over on the right, I can then scroll down, and I've got some listings by service. So the lion's share of my costs right now are stemming from storage. Second would be app services, then bandwidth charges, followed by virtual machines, and so on. Other times, it might be important to look at it by location. So Canada Central seems to be where most of the costs stem from. And if I see a region listed here, such as US West, this could indicate that I've got resources perhaps that were deployed for use in that region that are no longer required. And so I should go explore that and determine which resources are in that region and remove them. So that's another option. You can also use PowerShell to check on unused items in your subscription. So straight from the Microsoft documentation, if I scroll down here, I'm looking at a find and delete unattached Azure managed and unmanaged disks page. Well, if I scroll down, we'll see that there's a PowerShell script that will do just that. So here we are using the get-az-disk PowerShell commandlet to return all disks in a variable called $managed disks. Then we are looping through with a for each loop each managed disk with a looping variable called $MD within the $managed disks variable. So what we're doing is checking with an if statement if the managed by property of an individual managed disk is equal to null. Because if it is equal to null, it means that that managed disk isn't attached to a virtual machine. Now, the first line in our script up here is setting a variable called $delete unattached disks equal 0, which means presumably false. However, if we were to set that to a value of 1, it would delete any unattached disks. So we're going to go ahead and run this script and see what the output looks like. So here in the Cloud Shell, I'm just going to go ahead and paste that script in, and we're going to take a peek to see what the result is. I'm going to press Enter. So what we have down at the bottom is a listing of multiple managed disks in our Azure subscription that are not attached to VMs. So you might question, why do they exist? Because they are taking up space, it's a resource, and we are paying for it, even if we're not using it. So there are a number of ways then that we can check for unused as well as unnecessary resources in Azure. Security is a crucial part of monitoring your Azure environment to make sure that resources and data are protected. One easy way to do this in Azure is through the centralized Azure Security Center. So in the portal, you can get to that by opening up the navigation bar over on the left, and then when you scroll down on the left-hand navigator, you'll come across Security Center. So I'm going to go ahead and click on that. Now, there's no configuration required to get this up and running and to have data fed into it. It's set up by default automatically, and as you begin deploying resources and configuring them, then this will update in response to that environment. So in the overview blade for the Security Center on the right, there is a policy and compliance panel, and I have an overall score listed here of 84%. Well, I'm going to click directly on that to open up that section. What does that mean, policy compliance, exactly? The next thing I'll have to do is select the appropriate subscription I want to jump into for that. I only have one, so I'm going to go ahead and click on it. So this is definitely going to be very relevant for any regulatory roles within the organization that check for compliance. If we scroll down, we start seeing that there are some controls such as enabling encryption at rest. And if we drill down under that, it's telling us that for 2 of 3 virtual machines, disk encryption is not applied. So there's a little scoring mechanism for each of these items that determines the overall compliance score. As we go further down, we can see that there are some things such as endpoint protection, which is enabled, so we don't have any problems. So they show up as green bars over on the right-hand side. So this is an easy way for you to go in a centralized manner to view the overall security posture of your deployed Azure resources. I'm going to go back to the overview blade of the Security Center. We can also view specific regulatory compliance details for certain types of security standards, such as PCI DSS, if we're going to be dealing with credit card holder data. So if I were to click on that, that's another way to view compliance. So down below, I'm going to click PCI DSS. And in the PCI DSS security standards, we have references to doing things like installing and maintaining a firewall configuration. Well, that's colored green here, so we know that we are compliant with that. But the protection of stored cardholder data, which is a part of the PCI DSS standard, we're not compliant with that. It's red. And if we expand that, we'll start to see a little bit of detail related to that. So this is going specifically to the guidelines within that security standard. I'm going to go back to the overview blade once again. If I scroll down a little bit in the overview blade, I can see I've got resource health by severity. It looks like we've got a red bar here. There are 4 compute and apps resources that are potentially problematic. I'm going to click on that to open it up. Once again, we're seeing something we've already come across, just being shown in a different way, that disk encryption needs to be applied on virtual machines. So I'm going to click on that item to get into some details. So finally, what am I going to do? I need to figure out which VMs need this done. So by scrolling down, I will see the offending VMs. 2 of them are listed here. I can even expand up above that the remediation steps. So they've got a lot of helpful links here, Microsoft does, for how to solve the problems related to the recommendations made by Security Center. I'm going to go back to the overview blade yet again. If I scroll all the way down here in the overview blade, I'll also come across a threat protection section where I can view security alerts by severity. I can view it in a different way. I can see security alerts over time. This way I can, at a glance, determine about which day or days I had issues with security alerts. So I'm going to click on security alerts by severity just to open that up. And we've got a couple of items shown. Medium severity is orange, low severity is blue. We've got a couple items shown here on Sunday the 3rd, also on Monday the 4th, and so on. If I go down below, I can see some further details, such as suspicious activity detected. There's 1 occurrence of that. Under the count column, it has 1. And if I click on that, we'll be able to get more details about what it's referring to. So I've got a virtual machine here called Hyper-V Host that seems to have been attacked. Well, let's find out if that's true, because sometimes it could be a false positive where it could be just normal, benign administrative activity. I'm going to click on that host. Now I've got a lot of details here. If I scroll down in the middle, I'll eventually come across the command list. It detects that there might have been suspicious activity based on some issued commands. And it's pretty detailed. Check it out. It says the hostname command was executed. Wow, that's detailed. The task list command was executed. The firewall was disabled. A new firewall rule was added. A new scheduled task was created. Process was killed. Now, that's very interesting. And I can see the account that was used to execute those actions. So then I would explore this further and investigate to determine if, indeed, that was a security incident or whether it's just normal activity. So there's a wealth of information then that can be gathered from the Azure Security Center, and it's automatically generated over time. Azure Sentinel is a centralized anomaly detection type of tool. Its benefit really lies in the fact that it can bring a lot of data sources into a single place looking for anomalies, and as a result can reduce incident response time. Azure Sentinel uses a log analytics workspace, but there are additional connectors so we can grab data from additional data source. So where other tools like Azure Security Center are more of a recommendation-based type of tool, Sentinel takes it a step further. It takes alerts, it ingests them, and then it correlates them so that we can take the appropriate actions, and we can automate that using playbooks. A couple of terms that we should be aware of when we talk about Sentinel include security information and event management, otherwise called SIEM or SIEM or SIM, depending on how you like to pronounce things. But in the end, it's all the same thing. A SIEM solution deals with real-time security alerts. It allows for security events to be submitted from a multitude of different sources, and it results in event analysis and correlation. So you can think of Sentinel as kind of being SIEM in the cloud. Traditional SIEM data sources would include web applications, network infrastructure equipment, databases, shared folders, authentication servers, and so on. In Sentinel, these are connectors, and they could be Azure sources or third-party sources such as Cisco, Barracuda, Palo Alto Networks, etc. So the connectors then allow Sentinel to access security data without duplicating it by copying it into the underlying log analytics workspace. Security orchestration, automation, and response, otherwise called SOAR, allows us to bring in data from multiple sources and apply a workflow playbook. Now, playbooks in Sentinel can use logic apps, and the idea is that we can reduce incident response time, so we can automate security triage, and we can automate incident response. Another benefit is that it allows us to weed out false positives so that there are less alerts being sent in to already fatigued security experts. It reduces security incident response time. It allows us to automate the containment of the incident. It allows us to automate the remediation of the incident. So you can think of Azure Sentinel then as being an overlay of many other underlying data sources, including using a log analytics workspace to bring data in and start to correlate it to look for any potential security incidents. Azure Sentinel is a cloud-based SIEM solution. Some people will pronounce it as SIM or SIEM, but either way, it's a centralized way to look at a variety of different data sources to determine if there's suspicious activity, to determine if a security incident has occurred or is occurring. So to get to Sentinel, to configure it, here in the portal in the top center search bar, I'm just going to search for Sentinel and I'll choose Azure Sentinel. The first order of business is to add a log analytics workspace, otherwise called an Azure Sentinel workspace, since it's kind of an overlay on top of that. I've already added one, otherwise you could click the Add button to do that. So I'm going to click on the name of the workspace to open it up. The first order of business when you initially set up Sentinel is to think about the data sources you want to reach into to look for security incidents. And that means thinking about data connectors, which I'll click over on the left. So you can use a multitude of different data sources to look for anomalous activity here through Sentinel. We have an alphabetical listing of data connectors here on the right, starting with Amazon Web Services. So we could reach into AWS by providing the appropriate credentials and then looking for security incidents. We can look inside Azure Active Directory. I'm just going to scroll down here. Azure Security Center is already enabled as indicated with the green bar to the left of that connector. Well, when I have a specific connector selected, over on the right, I can scroll down and determine what I need to do to make a connection to it. Now, what I would then do is click the Open Connector page on the right, just wait a moment, so that I would then be able to specify things like authentication credentials, or in this case, simply specifying that I want to enable the connection. So if I scroll down on the far right, I would just have to connect, which I've already done. I've connected my subscription for Azure Security Center here to Sentinel. So I'm just going to go ahead and click the X to close out of that. That puts me back in my data connectors list, where I can also search by name or provider. So if I were to type in SYS, for example, SYS, I have a couple of hits for even third-party solutions, whether it be Cisco or, in this case, Citrix Analytics. But I also have syslog. So syslog, of course, is an old Unix and Linux daemon that still persists to this day, where you can filter out the type of log events that you want to send somewhere, such as to a syslog logging host. And so what we can do here is use syslog as an ingestion mechanism to look for security events here in Sentinel. So that's kind of a cool option. Now, the other consideration are playbooks. So let me just scroll down a little bit on the left and click on playbooks. A playbook allows us to take some kind of an action when we get some kind of a security incident response here in Azure Sentinel. So I'm going to click the Add Playbook button up at the top. That's going to open up a new tab for Azure because what it wants to do is build a new logic app. In Azure, a logic app is a way to sort of generate your own custom code without writing code. It's a GUI-based solution as opposed to Azure Functions where you do write code. So from the resource group drop-down list, I'm just going to choose a resource group. I'm going to call this Logic App 1, and I'm just going to click the Review and Create button in the bottom left, and then I'll click Create. And then after a moment, I'll click Go to Resource to jump into essentially the designer tool for my logic app. Then I'm just going to scroll down a little bit and choose Blank Logic App. And the first thing I have to do is search for connectors and triggers. So what's going to trigger this app to run? Well, ideally, the occurrence of some kind of a security incident that pops up in Azure Sentinel. So I'm going to search for Sentinel. And what I'm going to do is then choose Azure Sentinel. That's my trigger, and I'm going to click directly on it. Now from here, I can sign into my Azure AD tenant, and I can also add new steps. So what do you want to occur once an incident occurs from Sentinel? So we specified the source for our logic app, the trigger. What do we do now? When I click New Step, I have a wide variety of possible actions. So if I were to click the All link at the top, I could determine if I want to look at the HTTP category, determine what I want to do. But I can also just remove that. I'll click the X and click New Step again. If I just simply click on All, scroll down a little bit, I then have a large list of potential actions. Whether I want to start a web app, you can also filter these things out. For example, let's say I type in the word drop. Well, I have a Dropbox type of action. And what do you want to do? Do you want to copy a file to Dropbox in the cloud, create a file, delete a file? This is only but one possible example of many different types of actions or steps that you could run in your logic app. So at this point, I'm just going to go ahead and save it. We're not going to actually configure it any further or use it. But back in Sentinel, what we would then be interested in looking at is the overview blade, because over time, you'll probably end up with some security incidents, and you'll start to get some indicators of that here, where you'll see listed number of events. And also, over time as you scroll down, you might even see potential malicious events plotted on the map geographically. So in this course, we've examined how to use Azure features, including Azure Monitor, Application Insights, Security Center, and Sentinel to monitor individual and centralized Azure resources. We did this by exploring ways to monitor Azure resources, including monitoring individual resources, how to deploy a log analytics workspace and add data sources to the workspace, how to work with Azure Monitor and dashboards, view performance metrics, and enable diagnostic logging. We looked at how to enable application insights, use the portal to analyze Azure costs, and configure a budget scope. We saw how to configure action groups, alerts, and notifications, how to use Azure Monitor to monitor alerts and metrics, and how to monitor for unused resources, how to view Security Center recommendations, and we saw the purpose of Azure Sentinel and how to configure